depends upon the method in which the data are collected. If you want to believe something is good, it should demonstrate the validity, right? Only then you can believe that. So if the data are not done correctly, then you cannot trust that data directly. Okay, therefore, you can see there is a process. If you go and initiate a study, first, you should get your protocol done and you should ask clear to your institutional ethics committee. After giving the permission, then we will able to conduct a study. You can see from the beginning of recruitment till you publish, there is lot of methods in place to ensure that the quality of data is correct, right? Even if you try to publish an article, there's a peer review system which actually takes care of whether the data that you collected are robust and try to give you the right result or not. Therefore, when you perform a secondary research, it is always important to try and identify the appropriate source. Okay, therefore, published literature plays a major role, but when doing systematic reviews, it is not only refined only to a published literature. They also go to a non-published literature data and explain you why it is important to have all the information. How do we handle this validity and all the checks and balance that we try to do in a peer reviewed system. Okay, now coming back to this talk of systematic review and meta-analysis, I think I've just given you a broad perspective of where we are leading now. So we are going to do this today. At least I will try to cover as maximum as possible, and we do some practicals tomorrow. So we'll talk about what systematic reviews and the definitions and what the systematic review can help to achieve. And secondly, meta-analysis. And if you read any systematic reviews, it should have some sort of a standard, minimum mandatory information. Only then you can trust that. So what are they? You need to have a proper question. If you didn't ask a right question, you cannot answer that. Okay, how do we ask a right question? We see all of that. And also the most important component of systematic review is identifying the studies. Okay, that is kind of a heart. How did you conduct and identify these studies to be a part of your review? Okay, the randomized control trial, participant is the very important aspect. What do you do with participants? How do you select them? Inclusion and exclusion. Why do you want to have an inclusion and exclusion? Why can't we just do everybody into a study? There are people attempt to do everybody into a study. That's called pragmatic trial. Okay, why do you want to have inclusion and exclusion criteria? Inclusion criteria try to ensure that the confounders that are going to play a major role in altering your effect, treatment effect, can be controlled with your inclusion criteria. Okay, therefore you select an inclusion criteria, try to recruit the subject so that you can balance those confounders. Similarly, in systematic reviews, you set up some specific criteria and try to recruit that study into your review. Okay, we talk about that, selecting studies, and then don't trust all the studies are 100% valid. I mentioned that there is a screening, institutional ethics committee is there, peer review system is there, data collection is there. So even though whatever they have done, at the end of the day, GPT can write a manuscript. Okay, it is not that you have just followed all the principles and try to provide a proper manuscript. There could be possible limitations in your study. It's not like completely a fraud. It could be a limitation that in your study that we are investigating that in your systematic review. All right, and then do some data analysis, which is meta-analysis, and then further investigate those analysis valid, and then finally interpret and make a recommendation. Okay, that is the kind of picture that we will try to learn today. So when it comes to levels of evidence, we're talking about which type of study that we should trust basically. So what happened during COVID? Let's going back to COVID again, because all can relate that example. What happened during COVID? People are trying out a lot of different treatment strategies, and then who's endorsing that? The WHO endorsing that this is a possible treatment at this time. After 2 weeks, there's another drug which could possibly help. So you can see that there are people making recommendations on the usage of the different therapies that are going to be useful for treating COVID. So systematic review plays a major role in terms of making those decisions. So therefore, you can see that when we talk about evidence-based medicine or evidence-informed healthcare, so you will see that on this pyramid, a systematic review lies on the top level. Okay, the rest of the other information which we call as the primary studies, it all falls below a systematic review because it is like aggregator. Systematic review is like an aggregator. Okay, it tries to aggregate the information from all the primary studies and then trying to give you some sort of confidence in the results. Okay, that is what systematic review is trying to do. And you can see a lot of other filtered information like critical appraisal tools, which primarily people use on journal clubs. Okay, if you do a journal club, there are tools available, something called CASP. How many of you are aware of this CASP tool? Critical Appraisal Skill Program. Okay, you can download that and then evaluate the primary study against that to see whether the studies that you are actually reading is good enough to give you proper information. Okay, there are filtered information that you can use, which is called critical appraisal methods. Now, coming back to the definition of systematic reviews, you can see that there are three different components in this definition. Can you highlight that? What do you think are most important elements in this sentence? Limit bias, perfect. Critically appraise, synthesis. You can see that these are the three important elements in a systematic review. I'll explain it to how the process goes with these three definitions. Okay, so it says that you have to scientifically put some methods to limit bias. What is this bias? What do you think bias translates or define bias? Anybody want to just take an attempt? It need not supposed to be correct. You can make an attempt so that we have some discussion. Otherwise, I will be speaking and you'll be listening. What is bias? Exactly. So you can see that anything that just deviates from the truth. How do you know what is truth? We don't know what is truth first. Okay. But we are hypothesizing that I'm expecting this sort of a result there. Okay. How we can deviate from the truth? We don't know the truth first, but we can try and lead the results towards a specific outcome of interest. For example, I wanted to do a study. I wanted to perform some diet program which I invented. I want to claim this diet program helps people to reduce weight. How can I achieve this result? What is the truth for me here? How do we do it? What is the outcome? So outcome is weight reduction. Okay. How can I achieve this weight reduction with my diet program? Correct. But I expecting a truth. The truth here is I want to show my drug is or a diet program is beneficial. How do I design a study? Before and after. But I can try to recruit a subject which I think possibly can reduce weight. Therefore, I can show that my diet program is actually showing a beneficial. So you can see that I'm introducing something called a bias here. Can I just control or limit this bias? Yes, because I have an option of implementing a new method there, trying to ensure that I am not being choosy in selecting these individuals who are obese and then trying to show them that there is a reduction. Let's do a trial where I will recruit one group of people where everybody is working in an IT firm. They all been put as a control group. I recruit people who take bus and walk every day and then trying to put them in my intervention group. What is going to happen? Without intervention, there will be a benefit, right? So that is the kind of bias that we are trying to talk. Okay, so we have some methodology here trying to limit that bias. Okay, you can control or put some methods to eliminate to an extent of this bias. And the second component is critically appraise. Don't believe all the studies done as a randomized control trial are 100% valid and 100% giving you a right result. Okay, so you have to apply some method to limit that, you know, studies validity. And finally, you perform a meta-analysis. Those are three important components of, definition of systematic review. So not all systematic review end up conducting a meta-analysis, which means that meta-analysis is a statistical analysis, which is a part of systematic review. People most of the time they get confused because they think I'm doing a meta-analysis. So you're not doing a meta-analysis. You're only doing a systematic review. If you perform within a systematic review, then you can call your meta-analysis valid. Okay. For example, if I can go to PubMed and find 5 studies on a topic of interest. Example, weight rate reduction. If I only just do pooling all the 5 studies, will you accept that result? Yes or no? Probably not, because there are 10 other studies exist on the topic, which I have not searched for it. I'm just only going to PubMed and picking up those 5 studies and calling them myself as I did a meta-analysis. So that gives you a wrong result. Therefore, meta-analysis is just a statistical procedure. Okay, you cannot just call that I'm just doing a meta-analysis. Unless you perform that in a systematic review way, it may not have a perfect validity. Okay. So I gave you this definition of meta-analysis, which has been defined by Glass, 1976. The statistical methods that combines the results from several independent studies, which is just a statistical procedure to pool the data together to arrive at a consolidated or evidence that you are expecting. Okay. Now, this is how people try to, write reviews. When we say reviews, people have been, doing lot more, different types of reviews. So those days, people try to call that as a review section. If you look at journal, what are the different sections are available? They'll say original article, case reports, review article, letter to editor. These are the components, right? So if you look at the review articles, who writes review articles? Everybody writes. Not a junior person can write a review article. Maybe an expert in the field or the person who is on the board of review might write some review articles. So you can see that review articles are generally written by an expert in that field and then trying to say what is their thoughts. Okay, that is how people were writing reviews initially, and then suddenly systematic review methodology come into place. Then what happened? Systematic reviews, people have started writing systematic reviews. Then there is separate methodology of analyzing the same systematic review in various ways, starting from meta-analysis, individual patient data meta-analysis. Now currently you can see that network meta-analysis or multiple treatment meta-analysis. So there are various statistical components added on to this method of how you analyze these data. Okay, so therefore you can see lot variety of systematic reviews which are being conducted right now. So in practice, not everything, called as meta-analysis. You can see that people have been taking information in different way and trying to present them in different, methodology of publishing the article. Okay. So as I just mentioned, the traditional way people start writing reviews by an expert, and then they will have access to only few information. They might, look up for Medline or PubMed. They might look, contact their friends who are the research collaborators or experts, and then try to put together and publish some article. Okay, and the conclusion may be very, very influential. Maybe if the sponsor is going to be a pharmaceutical company, requesting expert to write a review, probably he might be biased because he has to write something in favor of the drug. He cannot just put all the evidence and say this is what the truth. Okay, there are some conflict of interest comes into picture. when you see or read any, narrative reviews. So traditionally, what people do as a narrative review, what is the difference between systematic reviews? In narrative review, you will never find some sort of a clear methodology, right? So why methods are important? Why do you think methods are very important? So we all write articles, right? What is the importance of having a method section? You have to tell adequate information for reproducibility. Why? If you want to believe the results is true, you give me how you have actually done. If I repeat the same experiment here, I should also get a similar sort of a result, not exactly the same, at least a close result that I should see. Then I can trust the findings. Okay, you can imagine that most of the studies that we do in our country is all research with the innovative ideas. We do research more often validation framework. This has not been done in Mangalore, therefore I'm doing it. It is not done in South India, therefore I'm doing it. These are the common justification people provide to do research. This is all validation research. We're not going to find anything new there. Probably if you fail to show a significant value, then it is good. That is new to you. If you give the same result, nothing new about what is already known. Okay, that is why you can see when you start publishing in BMJ and NEJM and all of this high impact journal, you should write a section what's new in your research. They'll explicitly ask you to write some bullet points to explain what is new in your findings. Okay, so no methodology, okay, you cannot reproduce it, therefore I cannot trust it. But in systematic review, there is a clear protocol which is written in place, and sometimes protocol are getting published. Especially Cochrane review protocol has to be peer reviewed and published. Therefore, there is a check on your protocol. And secondly, we try to perform searches only in limited databases, like mentioned about PubMed. Any other database that you are aware of? Embase, Scopus, Web of Science, Google Scholar, Signal. Whatever you have to search there. There's no option of leaving any database. There are a lot of new AI features. We live in an AI world, right? How many of you are aware of there are AI tools and AI databases available? There is something called Semantic Scholar. Okay, there are now tools, connected papers. There are research rabbits. These are AI tools which helps you to just identify and access to information very quickly. Okay, there are a lot more tools are emerging, and the way the publication happens with the AI framework is translating the entire, Web3 will change the entire way that we consume the information. Okay, so you have to just perform as maximum search possibly on our various database, including non-published data, which means that even if you write a thesis and then you leave it in your university website, people will go and find that information. Okay, that is the extent Cochrane reviews are being performed. All right. Okay. So here, the third point is you don't have any restriction of selecting the studies. So you can see that when we try to perform any research study, the first important component is identifying a right design. Correct? If you did not find a right design, what's going to happen? You never can find the right result. Okay, design is very, very important. So if you want to know the prevalence of a disease, how can I measure prevalence? I want to estimate the prevalence of tuberculosis in Mangalore. What I should do? This is my research question. So I can do a cross-sectional study. Okay, I cannot just go, investigate all of this. It takes a lot of time. Cross-sectional study is the quickest solution to find what is happening in the community. Okay, if I want to establish a risk factor for tuberculosis, how can I prove that? I should wait little longer and collect more information. Either it could be a case control or cohort study to understand what is the risk factor. Okay. The third component, I want to do test that what intervention helps them to, either treat or prevent. How do we just establish that? Randomized control trial or experimental studies. You can see that for each of the question, there is a specific design. So if you just try to just, write a review, including all these different designs in a review, can you trust the findings? No. Because if studies have been observed and then showing that remdesivir works, if somebody proves with the randomized control trial remdesivir works for COVID, you will better bet on the randomized control trial than the observational data. And the example of this is ivermectin. We all know what happened with ivermectin. People were writing a good article and then they found the data are not valid. There's an investigation happened to see what happened. Okay, so you can see that initially when you try to do observational data, that comes from observational data, but it does not give us a valid information. So therefore, it's important to just identify a design and the methods how the data are collected. And here we more rely on the p-value concept. Okay, whereas in meta-analysis, we're not going to most rely on the p-value. We'll explain you why and how we can just investigate that. Here we have an effect size and precision. And narrative reviews are most of vote counting approach. What I mean by vote counting approaches, there are 10 studies that you identified. 6 studies are showing that intervention didn't work. 4 studies shows there is a beneficial effect. What will be your decision? You go with 6? Yes? Okay, what if the 6 studies are done with very, very bad quality? What is the sample size? Only 10. Thesis, all thesis 6 studies. What is going to happen? You cannot bet on the vote counting approach because it can lead to a wrong conclusion. Therefore, we have to have some methodology of trying to analyze that. That's where this weighted approach comes in the meta-analysis, which is trying to combine the results and give you more confidence on your various results. Okay, 6 studies are showing not beneficial, 4 studies are showing beneficial. When you combine this data, if the weights are going to be more with the studies, which is having a good result, then your pooled estimate is going to give you a correct result there, even though the number of studies are more for against the intervention. Okay, and these are more of descriptive, but we have here a meta-analysis which is going to give you proper results, and it is more subjective and biased. It could be a pharmaceutical funding studies, then it might lead to a problem. And whereas here this is more objective because you write everything in a protocol stage and each of the step is been performed by 2 authors independently. That is where I'm saying that limit bias. How do we limit bias? It is not that one person writes a review like a narrative review. Here you should have a team of people who just does all the steps 2 times. Therefore you have a check on each of this study selection, data collection, and then analyzing it. Therefore, the bias can be reduced. Okay, I might say, oh, 10 studies I identified in screening. The second person will screen the same studies. If he comes with 12 studies, you see that there is 2 studies missed by me and the 2 studies picked up by the second author. Therefore, every step has been, done twice in a systematic review. And most importantly, anybody can write systematic review. You don't need to be an expert to write a systematic review because there is a methodology. You just have to follow the methods. Maybe you might need one person who can be an expert, who can guide you what are the clinical challenges that you can face in a review writing. And you can see that most of the reviews that you find in the Western universities, these are written by assistant professors and people who are just as a medical graduate students. They write systematic reviews. Okay. And the other problem that we normally find is time bias. So you can see that people try to publish a paper, then forget about what happened to it. Right? Narrative reviews are like that. But systematic review, you keep on updating the reviews, because when there is a new set of studies, you might want to know what happened to the decision. Okay. Therefore, it also now people talk about something called living systematic reviews. You don't have to keep on publishing. You just keep it live. As and when the data comes in, you can keep on updating the data on a systematic review. Okay. I'll give you this example. Look at this. Tell me what we are trying to do here. Now you understand systematic review, meta-analysis, all this, components and terminologies. What did we see here? Okay. There are multiple studies are there. How many studies are there? 33. What type of studies? Trials, possibly a randomized control trial. And how many participants are there? 36,975. Can you imagine that? People doing a study with these many participants? And what was the duration of the studies? 1959 to 1988. You can see that people have been trying to see whether this IV streptokinase is going to help people with acute MI. Okay, now look at the story here. What is the diamond tells you at the end? Look at the labels. It says favors treatment, which means that IV streptokinase works. That is the overall result that we are able to find. Okay. Now, if you look at this side, this is a cumulative meta-analysis. People are asking a question. What if I lived during 1969? How many studies would have been there? I would have got 3 studies to pool. So as and when the study comes in, I'm just conducting a meta-analysis and showing my findings. What you are able to see is during 1973, what happened? You can see that the p-value turned to be significant and your diamond favors the treatment. And from there on, you can notice that the entire results is going to be telling you consistently that it favors treatment. What people have done during that time, there is no systematic review meta-analysis methodology. People are not practicing that. What people have done is they are still practicing a randomized control trial. What is this randomized control trial? When it is conducted? 1986. How many participants were randomized? 11,712 participants, which means if you divide them into 2 groups, almost 5,000 plus participants did not get any good treatment. Actually, this treatment is actually going to save life. But people have been doing trial, and even you can see this during 1988. Still, people are doing trial with how many participants? Even larger than that. People have deprived to get the good treatment. You can see that the importance of meta-analysis is you cannot keep on conducting study. You should stop at one time point. When you know there is a clear evidence, you cannot, ethics committee will not give permission. Will you allow to do a placebo control trial now for COVID? You cannot do that. You cannot make an attempt. Okay. So that is the importance of meta-analysis. If you establish the treatment is beneficial, you cannot keep on conducting multiple studies over the data. Okay. So now you get the same result. Lancet written an editorial saying that from August 2005, we will require authors of clinical trials submitted to Lancet include a clear summary of previous research findings to explain how their trial findings affect this summary. And this summary should be done with a direct reference to existing systematic reviews. which means you have to refer some systematic review on a topic if you plan to do any randomized control trial. If there is no randomized systematic review, they encourage the authors to do one and then tell there is a real gap in the research, then you can attempt to do a randomized control trial. Okay, you have to establish a clear equipoise. If you don't have that, you cannot simply just take humans and put into trial and see what is happening. That is unethical, right? So you are being encouraged to do on your own first. So if you go and look up for all the instruction to authors with all these major journals, there is a clear instruction. Okay, ICMJE, International Committee of Medical Journal Editors, has come up with the policy that you cannot just simply publish a randomized control trial in these journals. You should provide a reference in the background of your article to clearly state why there is a need for conducting such randomized control trial. Okay. Okay, any questions so far? Let me take a pause and see. All good? Any questions? No? Okay. So now you can see we will slowly move towards. Sorry, any questions? No? Okay. Please ask questions if you have anything so that we could clarify then and there. Yeah, please. Now it's all emerging. Another 2 years, no, nobody, going to sit and write. Even now, all people try to incorporate GPTs into their, academic writings, and there is a big shift is going to happen, and it will be monitored. And there are guidelines now people are developing on how it should be reported, and all of that is all work in progress. Now, currently, all major journals doesn't allow AI written articles at this moment. There are guidelines. If you go to Equator Network, now if you do any studies with the use of AI, they wanted how much level of information that you should describe. So one, you describe that, what is the details that you have used, what is the amount of AI component into your paper. So there is work in progress to explain. Not AI can do everything. You are trying to tell AI as an assistant. So basically it goes like this. It becomes your personal assistant. You have your postgraduate to write something, help you with some data collection. Similarly, you ask your GPT or somebody assistant to write your manuscript in favor of. But you will be taking the responsibility at the end of the day if something is wrong. So things will change quickly. There are, guidelines and principles which have been, developed to monitor that. But it will definitely have a place in the future. We cannot just completely, remove and say, oh, I have written it. That is how it is. Any questions? Anybody? Okay. No, it's not about randomized control. This is a systematic review. So it's systematic review. That's why this translates into the guidelines and policies. Okay, now you can see there's a separate section there. What happens after systematic review? What happens after systematic review is there is a guidelines development framework. Okay, so it is a society. Let's say for you belong to one particular society, they are going to make a recommendation of using of remdesivir. How did they decide it? So they use systematic review to inform you that this is beneficial. And there are methods in place to tell you that if you identify a large benefit, you're not allowed to do any studies there. There are another section of talk which talks about guidelines development process. Okay, I will explain it to you later, maybe tomorrow at the end of the session, or I will explain it to you when I show the example. You can understand that, what it means actually. There are guidelines and, tools are available to demonstrate that. Okay. Yeah. You cannot do the meta-analysis. We'll come to all these components of handling meta-analysis, heterogeneity, and all of that in the future. Very good question. I will just address that when I talk about it. All right. Okay, any other? Okay, if there are no questions, we will quickly move on to meta-analysis. So you can see that now meta-analysis is kind of a statistical procedure combining the information together, right? So when it can mislead, first, if you do outside systematic reviews, you did not collect all the adequate information and simply combine two studies and show there is a benefit, it is not going to be useful. It will leave a wrong result. The next problem is when you get all poor quality studies. Okay, let's say all, I have done some 5 theses in the department on the same topic. It is not done as a proper research. Maybe there are some limitations in the research that we have done. We don't have much resources. When I combine this together and publish it, it may not give a correct result. Poor quality studies will lead to a wrong conclusion. And inadequate attention to heterogeneity, like you are mentioning, sir. If you don't have a proper, consistency in the result, then pulling all this and showing something will not make any, sense. So that is very important to know. It could be inaccurate, data. All this reporting bias is another problem, meaning people will only try to accept your paper when you show a significant result. If your result is not significant, you have to struggle to sell your paper in some journal. Maybe that might be the truth, but if you have done it properly, you can sell it easily. Otherwise, it's never going to find a place in the public domain. Publication bias, language bias. You can see I'm going to search only in English language paper, not a Chinese or Scandinavian paper. You might lose the data there. So what to look in a systematic review? We have talked about this before. I will, and most importantly, Cochrane reviews, there are no language restrictions. They will go to an extent of identifying studies published in Chinese, Japanese, whatever language, they will find people to translate it and extract data and then, sorry? It's all done by humans. It's not a translation done. And you will hire or you will find somebody from Chinese Cochrane Center. You send this paper to them, extract the data on your behalf, and then use the data. And you can run some sensitivity analysis by excluding the study. What happens to your findings? But not at the moment, it's not a pure translation features. And as I just mentioned, every step is 2%. Only then you can try to minimize the bias in the process. Okay, let's go on to what is the first step. Now we have seen the entire story and background about what systematic review and what meta-analysis and all of that. From here on, it's more about kind of engaging you with the practical aspect of it. Okay? We got 10 minutes, or 5 minutes actually. We'll stop and then I think we can. How about the 10:30? Anything you wish you tell me, I will stop. Ah, what time is the tea break then? Stop it. Oh, after the inaugural. Okay, okay. Okay, we got another half an hour with us. So we will start. And this is going to be a little practical. I don't want just boring listening to me and a couple of things already. Let's do this practically. And the first thing is, for any research that you do, I mentioned that question is very, very important, right? There are some structures or a template in which you can write your research question. Okay. The most common one that you find is called PICO, right? Who is your participant? What is the intervention? What is your comparator? And what is the outcome of interest? Can you take a paper and pen, whatever documents or any paper, just make an attempt to just try to give what kind of research that you want to do or systematic review that you want to do. You can take reference. It's not an exam, so you could just Google for it. You can, do some research. There are a lot of tools available. I don't know how many of you are aware of Perplexity. Have you heard about this tool? Okay, Perplexity.ai is another tool which is going to compete against Google search engine. Perplexity, Perplexity. Okay, you just have to be aware of all the AI technology which has been developing. It's developing very rapidly. So you can, go to that perplexity.com or .ai. I think you can just Google yours, quickly search your topic and see what it says. And you know for sure GPT is available, but GPT sometimes give you wrong, references. But Perplexity works better than GPT in terms of giving you right information. Okay, you can spend like 3 minutes. Just check your topic there and see what you are able to find. You can access through mobile, whatever device that you have. This is not searching. This is an basically AI Q&A, basically kind of an chat GPT is there, right? You can ask a question. If you are looking for a systematic review on a topic, you go to Google and you ask Google, right? So it gives you 20 different articles, but this gives you a specific reference to information. If you want to access specific information, this might be the right place. Did you find any review already exist on your topic of interest? Mm. How many of you are able to get the site? Everybody got the site? Okay. If you need any help, just raise your hand. We can come over. Yeah, it just gives everywhere. It just gives the source where it picks up the information from, so that you can trust it. GPT doesn't give you the source; it just gives you a result. That is the difference between this and the GPT. So now what you're trying to do is you are establishing that the topic of your interest is vacant for you to choose. Meaning, can I do a review on this topic? Okay, you ask the AI tool now whether there are any systematic reviews already available. Okay, the second thing that you should do is you should go and ask Prospero. Prospero is another platform for registering systematic review. Prospero. PRO. Yes. So basically, why will you repeat the same review again? Nobody will publish it, and it's a different challenge for you to. That's where I'm just coming there. So you can see that if the review is very old and you find adequate amount of randomized control trial, which can give a new data, new evidence, then you could attempt to do it. That's why you are looking in a registration place, which is Prospero, where you are registering for a systematic review. Prospero. Prospero. So these are the two places that you will attempt to see. And there is another place where you can see is called epistemonikos. 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 These are, maybe I will just go internet. Yeah, I'm just looking for mine. Is it free to connect? 1 2 3. Yeah. Yeah. So this is a database which gives you information about systematic reviews. But what I want you all to do is just go here, and this is a place where you will register for your systematic review. Okay, if you perform a search here, you will know whether there are somebody who's already doing some reviews on your topic or not. This doesn't allow you to register for a scoping review. They clearly say that they are not interested in searching for a scoping review. The scoping review objective is just to map the information, not to generate an evidence, actually. So a scoping review can include all type of studies trying to map the information that these are studies done in India. It's more of a qualitative picturization of the information than going towards, and that is more often done in a social science research and criminology and qualitative studies. So you are interested in scoping review, then you should refer back to JBI scoping review methods. There are various organization writes review. JBI is more specific to scoping reviews, which is on Australian based. You can go there, then they won't accept because everybody writes scoping review without having a proper methodology. Scoping review, there are methods, but still people are flexible to publish. Whereas systematic review, there is a clear information that you should provide, and there is guidelines. So yeah. So I tell you a smartest way of doing review or learning review. People just go look for a new molecule which has been, published or approved by FDA, which is in phase 2. They do a quick systematic review on the topic because there is no study available. Yeah, yeah. That is what the data is. You cannot, they cannot say no to it, right? It depends on how, you are strategically trying to publish a paper. You can see all digital interventions. Cochrane actually publishes 0 articles before. Now they are not willing to spend their peer review time on no studies. They don't want to, spend their time on peer reviewing and, publishing that. Maybe by the time they publish, there'll be another article which pops up. So there is a duration of 6 months. Within your search, you should be able to, come up with your review. If you cross that 6 month duration, you have to repeat your search to see whether there are no studies available. You just follow the methodology. Unless you search for it, you will not able to know where there is 0 studies, right? Okay. Okay, I just kind of give you some little relaxing time. You can do your work. So you have learned where all you should look for information. Prospero is one place. Second is Perplexity, which kind of helps you with other information as well. Any doubts, any questions you have, you can just ask Perplexity to give you answers. Prospero is for systematic review. Epistemonicos is for systematic reviews. These are two information that you should search before you jump on to do any reviews. Otherwise, you might do all of that and come back and see there is already a review which is ongoing or it has been published just 2 weeks before. Then it's very difficult for you to publish your work. So therefore, you try to do this homework before you start any topic. Okay. Now, and especially when it's systematic review, we will add this component called study design. Because the study design serves as an inclusion criteria in your systematic review. Like in a randomized control trial, you are saying inclusion, exclusion criteria. Similarly, in systematic review, study design plays a major role on which type of study that you should include. If I am planning to know the prevalence of tuberculosis in India, you can see there might be a larger study. But I'm wanted to do a shorter version of the large review looking at Indian studies. Then I might include cross-sectional studies, which is published from India. Then it becomes a review. Okay. Or I can just say I want to do a study on identifying what is the tools available for measuring pain. It is not technically a review on evaluating an intervention. It is a systematic review on identifying what tool exists on this particular topic. Okay, that could be a systematic review. You can do some systematic review on educational method. Now you have a lot of this educational methodology, right? Now after COVID, everything changes on hybrid, all this technology versus no technology. So you can do any kind of systematic reviews, provided that you find some studies to support your research. Otherwise, no studies, you cannot publish that. Okay. And these are some details about this patient population. And when you try to define this patient group or We don't call them as patient in studies, we call them as participants because they're participating in a study and contributing data. So you should clearly define who these participants are. What is the, you don't have to worry about what people have done in their review or in the primary studies. They might say, we combine people from, children and adults together. But you might want to do a systematic review only including adults. So don't get confused or, deviated by looking at information that are published and then just follow what they have done. You try to determine your own research question and your outcomes. Just to ask you a question, if you are treating a patient with fever, what would be the outcome of your interest? Which will be your primary outcome? Temperature? Okay, everybody agree? Okay. So there is something called patient relevant information or patient reported outcomes. What the patient might be interested in. Time, he's going to look at the time. Yeah, that's right. Maybe define it from his perspective. Exactly. So he is interested in getting back to work. Probably when you do a systematic review, you should probably define your primary outcome as, the day he joined back the work or something like that. Not looking at the surrogate outcomes like, temperature and all of that. That is not, maybe you might be interested from clinical point of view. So there is a separate group of research which happens on core outcome set. Okay, you can just go and look at this core outcome set for your specialty, comets. You can just go there and you will find all set of outcomes that are available for you. And in fact, people try to just go and refer this place. If you try to select any outcome, are you just aligned with this established outcomes or not? You cannot just driven by the outcomes which is reported by the author. So you can go and take a look at these, core outcome set to see whether we are actually measuring what is intended to measure. And there is a lot of money on this. You can apply for this kind of research. So you can go and look at all these different types of group works on different, patient-centric outcome set. And now FDA is also looking for these outcome sets. You cannot just do a trial to show, oh, this is beneficial on this outcome. No. You have to establish your benefit on these outcomes, which has been defined by the patient group. Okay, only then they will give an approval. So things are changing very quick. Then you can just go and look at all these, patient-related outcomes and everything. All right. Now, outcomes. We classify these outcomes as primary and secondary, right? In a primary study, we do that primary and secondary outcomes. Whereas in a systematic review, we just define them as important and critical outcomes. Critical outcomes are outcomes which is going to help us to determine the benefit and the risk. Okay. Important outcomes are outcomes that are going to be present, but I'm not going to make a decision on this based on that. Okay. COVID, what will be the critical outcome? Death. You live whatever way that will, at least I can prevent death. That is a very, critical outcome of interest. The decisions are made on mortality. Okay. So you have to decide from your, that's where this expert panel comes into picture to help you out. Okay. Now you can decide what type of design that you want. You choose randomized control trial, you choose cohort, you choose cross-sectional, whatever you want. Depends on your objective. You could select this outcome set. This is one example that you can see. Is zinc effective in treating cold? Basic question. but you can see that it doesn't fit into the Pico format. You can just make it much more clear and robust by incorporating the Pico element in your research question. Therefore, it's easy for anybody to understand what exactly that you are doing. You can clearly find in children with common cold, okay, you know the participant, is oral zinc effective in reducing the duration of symptoms? That is the outcome as compared to placebo. So this entire question has the all Pico element. If we don't have that, then ask a question. Maybe you can understand in your mind that, oh, I'm going to do this, but it is not very evident for others to actually relate and understand the question unless you put it in a paper. So you should just use Pico format. The second information after you just finish your Pico, the second element is trying to search for studies. Okay, searching for studies is a very, very, very important component in a systematic review. If you go wrong here, then followed from here, all the steps and all the steps will not be, valid because you did not find the appropriate number of studies. Therefore, the first thing is you should list out what are the databases that you are going to search. So you mentioned Web of Science, Scopus, PubMed, Embase, and whatever database that you mentioned, you have to list down that these are the database that I'm going to perform a search. Okay. And many times, not all the databases are available for you to access. Embase, we cannot access unless your university has a subscription to that. So you put it as a limitation in your review that these databases we did not perform search and we did not search in non-English, studies. This is a limitation in my review. Uprightly, you can just say that these are not being performed in my review. This comes as a limitation. Okay. So that is very important. So now I will just show you one example and you tell me what you are able to understand. Okay, what are we trying to do here? What is the research question? This is not free. What is the research question here? Can you tell me what is the research question? So I'm interested in looking to see whether yoga can benefit for people with epilepsy, right? Now I want to find studies for this topic. That is an important component of a systematic review. Now I can just see here. You can see that Cochrane offers you a search strategy supplementary material. Tell me what you are able to understand from this. Okay, let's not do here. Okay, you little read this what it's trying to tell you. Just go through this whatever text is there and see what we are trying to do here. So you can see that initially we started off with my question is on yoga for epilepsy, but I cannot just only use yoga as a keyword to find all the relevant studies. So therefore, I'm going to find all the synonym terms or a mesh terms related to yoga. It could be relaxation therapy or it could be pranayama, asanas, and all this different combination of terms. Okay, that is for my intervention. Understood? Now I am going to combine all of this information in a search method by using a Boolean operator. What is a Boolean operator here? Or. You can see that up to the intervention, it is all or. That is done. The second component, when you pay attention, what I'm doing here, epilepsy, seizures, and all this various combination, and trying to combine all this participant into one group using the Boolean operator or. And then finally, what I'm trying to do, I'm actually searching for randomized control trial or all these combination. And you can see at the end, I'm just going to combine everything using an AND operator. Did you get this? So what OR operator is trying to do? What is the use of OR operator here? OR is going to increase the volume of information. It could be yoga or pranayama or asana or relaxation therapy. You can see that the amount of information that is available for yoga is going to be not only yoga, it is going to be all variety of combination of all these terms, which becomes a huge information. And then the second component is epilepsy. No, this is a search strategy. Now I went to the Cochrane review. You go to the Cochrane page, and then click on this search strategy, supplementary material search strategy. So you will get for all the reviews that are there in Cochrane. Cochrane gives you the entire search strategy for you. Okay. So now I'm going back to this epilepsy or seizure or preeclampsia or eclampsia, and then again make it into a big set of studies. There are two sets of studies, 10,000 articles in yoga, 15,000 articles in epilepsy. Now I go back another keyword saying randomized control trial in all these combination, and I create all the randomized control trial in one third bucket. Now I'm going to use AND operator to say yoga should be there, epilepsy should be there, randomized control trial also should be there, then give me the results. Now from three of this, I am narrowing down to one particular result which contains these three terms. So AND is doing what? AND is narrowing down. What OR is doing? Broadening as maximum as possible. Okay? Think like you are just going to catch a fish. Throw a net, everything comes. Then you are trying to specifically choose a specific fish of your interest. That is where the AND operator is trying to play a role. OR is going to just catch as maximum as possible. Is that clear? Yes. This has been done by this particular review, and they found these many studies. So for your review, you should create your own search keywords. And then you have to go to PubMed, find the information. You have to go to Cochrane, you can see Medline, Cochrane Central. You can see Scopus. You can see clinical trial. They just went to all these places to acquire this information. It is not just only searching in one place. The biggest task plays only in this place, in the review. Okay, is that clear? Okay, now what you do, whatever topic that you have written, right? Go to this Cochrane and see whether you can find any review and search strategy there, and see whether you can understand what they have done. So go to the Cochrane library and find your review, do a search here, and then go to this supplementary material search strategy, and then check whether any reviews available or keywords that you can find. Then we can stop. The Cochrane is not free now. Access is not available. So check whether you can access the search strategy. It's just all blocked. So probably if it is not free, maybe off the record you could use SkyHub to download. If you have, if you need the paper, you could just use the SkyHub to download it. Yeah, it's all the same paper. Paper will not change actually. If you give the full text of the article, it will. Yes. You're not going to search for the article there. Strategy. You can find an Cochrane review, then we are just stop for the or forward the next thing. Now, if you need help, just raise your hand, we can help you.
Ladies and gentlemen, welcome to the much anticipated workshop on systematic review and meta-analysis. I'm Dr. Aishwarya.
And I'm Dr. Sarah, and we are delighted to be your MCs for today's event. Where the mind is without fear and the head is held high, where knowledge is free, where the world has not broken up into fragments by narrow domestic walls, where words come out from the depth of truth, where tireless striving stretches its arms towards perfection, where the clear stream of reason has not lost its way, into the dreary desert stand of dead habit, where the mind is led forward by thee, into ever widening thought of action, into the heaven of freedom, my Father, let my country awake.
We invite Dr. Sheetal Savor, a professor and head of Department of Ophthalmology, Yenepoya Medical College, to welcome the August gathering.
A very good morning to everyone on this unique hands-on workshop. And I welcome all, especially our Dean, Faculty of Medicine. Abhay sir, you have been with us, very encouraging, supporting of so many programs that we've conducted, starting, I think, from the eye donation fortnight. And we have a very special guest today. For all his accomplishments, Mr. Richard Kirubakaran. He seems so young. I thought, I expected to see a much senior person. So nice to see someone young achieve so much. So he's the director at Center for Biostatistics and Evidence-Based Medicine at Vellore. He's a member of the Cochrane Infectious Disease Group, Cochrane Methods Group, Effective Healthcare Research Consortium, Liverpool, UK, and method support group on the Indian first evidence-based guidelines on extrapulmonary tuberculosis developed at AIIMS, New Delhi. He has more than 10 years of experience in the field of biostatistics, systematic review, and meta-analysis. He has been a part of the Cochrane systematic reviews and non-Cochrane systematic reviews in reproductive medicine, ADHD, pediatrics, infectious diseases, and public health. His major research interests include evidence-based medicine, meta-analysis, network meta-analysis, epidemiology, and designing RCTs. He's been involved in publishing over 40 systematic reviews, also serves as peer reviewer for major journals, BMJ Open, Indian Journal of Dermatology, and Dermatology, Venerology, and Leprology. He is active in teaching research methodology um, in the Department of Epidemiology at MGR University, Tamil Nadu. I think we are very, very fortunate to have such a person for the workshop. And, you will do justice if you all bring out a few meta-analysis or systematic reviews after this workshop. So a very warm welcome from all of us to you, sir. So his wife, Dr. Rekha, she is going to join us shortly. She's a lecturer. She's also a faculty person, and I welcome her. She's a lecturer in the Department of Biostatistics who has a very keen interest and involvement in research methods, starting from providing statistical inputs to protocol development, preparation, and reviewing of statistical analysis plan. She is very well-versed with recent statistical techniques and statistical softwares such as SAS, SPSS, and R. She has a very detailed understanding of ethics in clinical research and good clinical practices. Currently, her role is to provide excellent and accessible statistical consulting services to AHS students, MD, MS, nursing students, etc. So please convey a warm welcome when she comes. So with this brief introduction, I welcome each and every one of you to enjoy this workshop and give your 100% participation in. Thank you.
Thank you, ma'am. I request all the dignitaries to come forward for lighting the lamp.
Now I request Dr. Abhay Nirgude, Dean Faculty of Medicine, Yenepoya Medical College, to hand over the mementos as a token of appreciation to Mr. Richard.
Good morning, everybody. The lead resource person for today's workshop, Dr. Richard, HOD Ophthalmology, Dr. Sheetal Madam, Dr. Saujanya, Vidya Madam, and all the faculty members. Firstly, I would like to congratulate and compliment the participants for coming for the workshop. Good round of applause for the participants, because this required a lot of keen interest to work and dedicate 2 days, and that hunger to learn new things is required. I just wanted to share my little experience about systematic review. 7-8 months back, with my PhD student, I said, let us do some systematic review. We are doing review of literature, we are doing PubMed, Mendeley we are using, but we are not reaching to the proper systematic review the way it says. Then we started the journey together. I said, I have not trained. I know the theory as a professor, but I have not gone through the formal training. And previously, I was a novice. So we started, then there is something came like it got rejected because we have not done risk of bias assessment. Then comments has helped us. So let us see what is risk of bias assessment. Then when I was going through it, it said risk of bias assessment 1, 2. Okay. Then we could able to go through the some articles and studied the risk of bias. Then how these beautiful graphs are coming, who is generating this graph, the Revman software. So at every stage, I started knocking the doors. I went to IRC, Dr. Raju, who is doing a lot of data analysis. Then I went KMC. I met Dr. Prasanna Mitra in one of the things. I stuck somewhere in risk of bias. So what can, sir, don't worry, you send your PhD student. He cannot say that you come, I will teach you. So he said, you send your PhD. So he went there, she went, discuss. And finally, we could able to come. Now I can say I'm the new beginner in systematic review. And after that, our department, Dr. Akshay, our head of the department said, sir, we should have, and he taken a lead. And we had a 3 days workshop with KMC Mangalore faculty are trained in with CMC Vellore, Cochrane, Dr. Unni Krishnan and all. They came and I got training after it was almost, they accepted the systematic review. So this journey is good. So learning something new is good. I could see Vidya madam is here sitting. So that is the best example and I would say that if we join hands together, don't worry about within department. We should go beyond department, beyond institute, and try to work as a systematic review as a team. Definitely things will come out because it has many plus point of systematic review. Scientific review board, again, madam, we need not have to submit. The madam will quickly process it, not to worry. But then it will go to ethics or original research. Then ethical comments, definitely we have to address. Here also, we have to follow ethics and all that is there. Slowly, systematic review, mandatory ethics approval may come in future. I don't know. There was a discussion. But there are many good things where we need not have to go to some of the other processes. So systematic review is, you all know, it is a higher level of evidence. So anyway, we are doing efforts to do a lot of review of literature. Let us do it systematically. So any support required further to follow it up, we have now in-house team. You are all going to get trained. Already there are some more people which are trained. So let us join hand together and take it forward. And something as madam has rightly mentioned, if the systematic review is coming out of this group, that will be satisfaction for Dr. Richard as well, resource person that coming all the way. That is one. But one thing I would like to say that as a university, we say that the institute or the department should contribute, or university's main role is teaching, training, research and service. Being a medical patient care, I must compliment ophthalmology department for doing excellent in all 4 domains. It is rarely that people are doing good in clinical work, good in teaching training. Also, they follow OSCE, they follow workplace-based assessment. They do. There are many trained famer people there. But in addition to that, you are also giving complex to community medicine by organizing service-related outreach activity. So, good round of applause for the ophthalmology department. Keep doing, and we'll be happy to contribute anything required, like any administrative support of software. If demand goes, we can ask for a licensing of the software and all we can ask. So all the best and thanks for invitation.
Thank you, sir. Now I request Dr. Abhay Nirgude to hand over the mementos as a token of appreciation to Mr. Richard Kirubakaran. Thank you, sir. We are delighted to welcome Mr. Richard, sir, as our lead instructor for this workshop. Welcome, sir. We are truly honored to have you join us today. We invite you to share your expertise and enlighten us with your speech.
First of all, I would like to thank for inviting me to this workshop. We generally try to do this workshop for 5 days at Vellore. 5 days we try to put this information together in 2 days, and as ma'am was we are discussing about, we want to have all hands on. We want everybody to access the software. There's a lot of uh, discussion happens before organizing this, and she's been chasing me from I think last year. She told, when is your workshop? It's in February. So I told, please, like 6 months before she contacted to organize this workshop. See the effort in organizing such an event. 6 months before planning and executing it. I just thank for the organizers and thank the administration on supporting all of these activities. As ma'am was saying, try to, even if you publish one review, that is a, best outcome that we could expect out of this workshop. And like you already have some, support from Manipal. There are people, FISA, who has been associated with Cochrane, writes reviews, and they also do conduct some training programs as well. So it's easier to access some resources there as well for you. So, and we are also available if you need any help or something after you finish this, we can, try and see how we can support your review. Thank you and all the best in the journey of systematic review. Thanks.
Thank you, sir. I now request Dr. Saujanya Kaur ma'am to propose the vote of thanks.
Dignitaries on the dais and off the dais, dear senior colleagues, friends, uh, systematic review and meta-analysis and evidence synthesis remains a very crucial method in today's world, and it helps in obviously summarizing the evidence and formulating new questions and clearing multiple queries which we have. And I think this is a very relevant uh, uh, workshop in today's world, in our institute as well as anywhere worldwide. So first and foremost, I would like to thank our Honorable Chancellor, Shri Abdullah Kuni, and Pro-Chancellor, who have been a source of inspiration for us. Our Vice-Chancellor, he's not here with us today in today's program, but he's always supported our department. And Dr. Richard Kirubakaran and Dr. Rekha, who are the resource persons today, and he has been very helpful and he has readily agreed. He the day I asked him to be a resource person, I mean, he's immediately agreed to be part of this. He's traveled all the way from Vellore to be with us today. And Dr. Abhay, uh, Professor Abhay Nirgude, Faculty of Medicine Dean, he's been a source of encouragement to me personally and to our department. In all our research endeavors, he's never said no. He's always encouraged us. And thank you, sir. Thank you very much for that. And I would like to thank all the participants, senior colleagues who have come all the way and taking time off your clinical work. And that shows the dedication, as previously mentioned. I would like to thank the organizing committee members who have been always very helpful, never say no attitude. And our beloved head of department, she is full of enthusiasm always, brimming with smile always, and who's been very, very supportive. Our SDA, Gayatri, who's been like the backbone of our department. Nothing works in the department without her. And her team, Rashmita and Nitish. Thank you, everyone. The catering services, the IT department, the audiovisual team. Thank you, one and all. And I really hope there are more than one systematic reviews coming out of this program. Thank you.
Thank you, ma'am. Now I request all to raise for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभाशिष मागे त्राहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय 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 हे
Let's capture this memorable moment with a group photo.
We were able to just complete the search strategy, right? So you can see the search strategy that you see on the Cochrane review. This kind of gives you a kind of a reference. You cannot just directly use that into your review. Probably you can adapt that and modify. Okay, so now you have a validation or a reference check for your search strategy. So any review that you start, you look for a Prospero, you look at the existing review, and there are certain justifications that you can provide why you intend to do this review. One could be the review is very old. Therefore, there are new studies exist on the topic. Therefore, I want to perform a review on the topic. Like your case, there was a review already. Now you can say, should actually do a review? Maybe you have to think, who is going to publish my work? Now you notice that that review is published 2 years before. Now there are 5 more studies published. Then there is an option for you to do a review on the same topic. Or it could be a review that doesn't have a proper quality. You can say that the review does not have properly done. There are methodological challenges are there. Therefore, I wanted to use the latest methods of conducting the review. So you just have to find proper justification to try and conduct these reviews. Or there is a funding for your review. There is somebody who is funding your review, demands for policy making. Then you could do a review on the topic. Okay. So now, once you finish this searching for reviews, and this is the diagram that you should just remember. You can see that there are 3 different components. One is that population group, who's your participant, what is the definition, all synonym keywords. And second is going to be your intervention keywords. And if possible, you can also do a outcome level search, but it is not advisable to search for an outcome level because not all the information are available in the abstract, because what you are searching here is you're only searching at an abstract level, because the information might be available in the full text. PubMed doesn't search the entire full text and give you the result. Therefore, don't directly jump on to search for an outcome. So once you have this, filter for your study design, and then you will get your result. And the key important thing to remember is Boolean operators and or not. What or is going to do? Increase. And is going to do? Narrow down. And not is going to exclude. So why not is going to be useful? We are only interested in human studies. If you look at a trial, there could be preclinical studies, animal studies, in vitro studies, and all sort of studies are there. Therefore, you can exclude those studies by using a not filter. Okay, then you will be able to identify only the human studies for your review. So once you've done this, the next step is how do we screen these studies for inclusion? Right? You're not going to get only 10 studies for your review directly. So you might end up getting 500 studies, 400 studies as your result. And you can imagine that one database giving 500 studies, Embase is going to give you 300 studies, and Cochrane is going to give you another 500 studies. So all of these studies are going to be overlapping. There's going to be a lot of duplicates are going to be available. So we should remove the duplicates first. Okay. And then start screening the studies for your inclusion criteria. That is the next stage. So to do this particular screening of studies, there are various tools available. Some of them are paid, some of them are open. One of the common tools what people use called Ryan, Rayyan. Okay, make a note of it. I'll just quickly demonstrate that tool. And if you want to know what all tools available for systematic reviews, you can go to this website and you can ask for the tool. You want a search, strings, blah, all of this. Okay. So I'm just going to look up here. You can see all these tools are available, screening tools. These are softwares. You can see these are very various types of tools are available for screening alone. Okay, you will not have time to learn all of this, and most of them are not free. So you can get the details of all of this tool here in this systematic review toolbox. But what we are going to just see right now is called Ryan. Okay, that is a tool that we will be quickly seeing. But if you have, your laptops, you can go and register in Ryan. It is free for registering, and for a single user, I think it's free. If you want to just include more people, then you might want to, buy a subscription for that. Okay, I will just give you 5 minutes. If you have your laptops, you can go to this Ryan tool and then register for it. Okay, everybody has created a link or created a user account in this tool. Okay. Now I'll give you a quick approach. Assume that you are going to do a search. Go to PubMed now. Okay, I'm just searching for a topic directly without using any search strategy. I'm searching for iron supplementation and pregnancy. What is that tells you? What does that informs you? Do we really give iron supplementation during pregnancy to prevent anemia or treat anemia? Okay. So this is a question that I'm interested in. I can do a big search strategy, but for the time being, I'm not doing any big search strategy. I'm just simply asking for a studies. And also I'm going to tell PubMed, can you give me only randomized control trial? I can just click here and then pull only randomized control trial on this topic. Can you just do the search and tell me what is your result? Can you perform a search and then tell me what is your result? So you should get 374 as the same result. That is why two people do this and validate the findings. Okay, which means correct. There's no problem there. You all done? Okay, I'll give you 2 minutes. Perfect. Okay, everybody got this? Yes, which means that you are actually trying to validate the result. So similarly, when you do it, 2% independently does the search and confirms whether the data are correct. Now, the next step is I'm going to take all of the study and then start screening for inclusion. Though I selected randomized control trial as a filter, I might have studies which may not be relevant for my review. Okay, now you can see save as all result and then save them as a PubMed format and then create this file. Can you do that? I repeat again, save as all result and then PubMed. Can you just do that? Hello? So it will automatically download the file and then save it somewhere in your desktop or downloads. Have you done that? Everybody? Perfect. Okay. Now, similarly, you will do this search in Embase, Web of Science, Google Scholar, wherever the database that you are searching for. Okay. Now, what I'm going to do is I will again select only the results on this page and then again create a file just to show how the duplicate function works. I repeat again, save, select only this page, not the all result. Only this page and then PubMed create. So what I'm trying to do is assume that you are downloading these two files. One file is from PubMed, another file is from Embase. Then you should have two files created. Got it? Okay, now this searching is over. Now we go to the Ryan tool. Is everybody is in this particular page? Or your screen looks different? Yeah, probably you might use the latest version. So I'm using the old version. But you should find this My Review, New Review as an option. Were you able to find? Create review. Okay, let me just switch to. You might find this view. Okay, because I was using this when it was free. Now it becomes a commercial tool. You end up paying. Okay, you can click on this new review and give the name. Just say whatever the review name is. Okay, I'm just saying this iron supplementation review example. This is a systematic review. This is a biomedical review. You can give some description. It is not mandatory, but you can just type something there and then create a review. Done? Let me know if you have done it. Okay? All good? Okay, it is asking you next is what? Upload the articles. Now select file and pick up the results that you are got from PubMed. First, one by one, add, and you can see that data is uploaded. Okay? We can do the upload, second upload later on. First upload done. Click on continue. Now you can invite your collaborators. I said two people independently doing it, right? So you can take somebody whose neighbor who's sitting next to you, take their email ID and then type their email ID here. And then mark it as collaborator. And then say invite. Just for your learning purpose, you can do this. Otherwise, you can skip. You can take the person who's sitting next to you, take their email ID, which they have registered here, and then invite them to this review. And then click on invite. Okay? If you don't want, you can just click on skip, not a problem. Done? So after you invite, you will get in this view. Click on the review data tab here. So after you invite, so you will see this overview, review, AI assistant and screening. And review data tells you you have got 374 articles for your review. and then go to screening. Screening tab. So this is where you will be started screening for your inclusion criteria. So what you will do, you will read the title and it tells you that these are studies, randomized control trial and placebo and supplementation. Do you want the study for your review? If you feel it is not, then you will say exclude. When you exclude, you can also say a reason why you are excluding it. You can see that I started screening. I can simply click on include and after reading. I'm just clicking the button now, but technically you should read the title and the abstract and then make your decision whether to include or exclude. Can you all attempt to do? Just try clicking on some buttons just for the practice. You can do for a couple of reviews, and maybe you don't have adequate information in the abstract. Then you can say maybe I will look up for the full text and then make a decision. You can do all of that. And you have all the filters for you to filter and check out. You can apply some filters here if you want. You can delete it. It's just trying to help you to go to the appropriate studies where the terms are present. So among this, randomized word is present in 226 exactly out of 374 articles. So you can only filter these number of studies. Or you can say observational data. Definitely it is not going to be useful. There are 14 longitudinal studies. But I have to read. This is a randomized control trial. See, longitudinal prevalence. The term is present there, basically. So you have to read. Definitely, this is just a filtering to. It's not that the word is present, you can exclude it. No. No, it's a randomized control trial. No, you don't. My recommendation: don't apply any filters. Anyway, you have to screen 374. You rather screen everything than taking some sort of a filter and then do it. Definitely, you have to read all of this 374. Filter is just to a feature that they are helping you to buy for it. You screen, yeah. Technically, you have to screen. These are just features helping you to get some satisfaction. Oh, I have completed this set. I completed Indian study. I completed 2015 studies. Yes. And you can see that the green ones are randomized control trial and the red ones are, if you look at this one will be highlighted in red, prevalence and all of that. This is just a feature, but I don't recommend to use this. Okay. Now, you all just practiced include, exclude some selection. And the people who have been invited, you can also get an email in your inbox that you have been invited for this review. Okay. You can click there and you should be able to perform the decision. For those who have been invited, their person who's sitting next to you, you would have got an email. If you click there, you will get the review. You can also independently make a decision. And now here there's a button called blind on. If you click on this blind on, you will turn off the blind. Therefore, you can see that what this person says and the person who's invited says, what was his decision. Here, blind on and off. The person who's invited have to go and make a decision. Only then that will be visible. I'll show you. Here, Richard says exclude. If you invite another person, if it is green, then it will say he is accepting and you are rejecting. So I did not invite anybody. Maybe if you are invited, you should see the. Okay, explore this option of invite and agreement. Yes, yes. Acceptance, it will take you to the platform where you go and make your own decisions there. The owner of the review will be able to unblind them. Who is the owner? They will be able to unblind. I can show you an example in a previous platform, not in this one. You can see here, there are two people. He is saying X, he is saying no. So it will be like this when two person actually done. Can you try that? So how many of you are okay with the invite? Any doubt, please? Okay, everybody is fine with the. Okay. Please ask questions. Okay, where will you find this information? You can just see that here in the stool. So you can see here, when you click on the review, go to screening, you can see this option over here, all review, undecided, excluded, included, maybe, conflict. If you click on conflict, it will tell you how many studies that you are actually conflicting. One is saying yes, another one is saying no. If you click on included, you can see that two of them actually said yes, yes, there's no conflict. So if there is a conflict, what we should do? There is an option over here. These are, I think now currently it will ask you for, cost, but I will show you in the older version what the feature that is there. So now if you look at this, in this example, I'm going to the older version. You might have an option of review chat. So another person you can ask, can we review this study that we are not agreeing? Then he will be available somewhere in US. You can come on the chat and then you can just type your question and then try to resolve it and make a decision at the end. Or you can call him on the Zoom, review it together, try to solve it. Or you have a third author who plays an arbitrary role, trying to review it together, make a decision. Okay. I'll go back to the new version. And there is a component called AI assistant. What that does is basically helps you to kind of prioritize the studies based upon your selection. Okay. So I don't know whether it is freely available here in this version, but it is available in the old version. So they keep on upgrading the features. Once you subscribe, only you will be able to, access those features. But I'll just demonstrate that here, screening, and there is a option of drop down. Here you can see that all reviews undecided, excluded, maybe, conflict. Here you should be able to do it. And there is an option of compute rating, which is a component which allows you to just do some AI kind of thing. These are additional information that are in place. Now everybody clear? Searching and screening. All this information needs to be presented in a prisma flow diagram. Okay, prisma flow diagram. Like consort tells you how many screen, how many included, how many analyzed, how many drop out. Similarly here, prisma flow diagram needs to be filled in. Okay, what do we do after you complete the screening? You can go here and then say these are the included studies in my review, and you can go and export that set of studies separately and you can take it into the review manager. I'll just tell you that. Go to your overview. So you can see all the details, how many unresolved, how many all this, how many screen, all this information will be available. Okay, you can also see this prisma diagram, but it will ask you money. But you can do it with review manager. I'll tell you how you can do it in RevMan. Okay. So I wanted you to upload the second batch of studies again. Go to this review data and then click on add review from my device. Select file, the second set of studies, and then continue. Now you can see the duplicate. One second, let this get uploaded. So I go into here, add references from my device, and then selected the file, second file that we have downloaded from PubMed, and then upload. I select the second file and then continue. Done? Yeah, because everybody goes one IP and it does not know whether it is a robot or it is a human. So we all are using the same IP to reach this website now. So it is suspecting something happening there. Okay, you can do this later. I think that is the way you can go, and it automatically detect duplicates. If you click on that, it just tells you the duplicate. Okay. Yeah. Yes, other databases. Because you end up screening the same studies multiple times, waste time. First, you detect the duplicates and say out of this 1,000 records, we only have a unique ID of 500 records. We will screen only 500. That is how you report in the Prisma template. Okay. That is the advantage of using this tool. Yes, yes. You upload all of the different studies from different database, detect duplicate and start screening it. Okay. How many of you use Mendeley? Zotero? Okay, you can do the same thing in Mendeley and Zotero and then upload it here. Okay, Mendeley also tells you duplicate. Zotero will also tell you duplicates. You can do that using that tool and you can upload it. How many of you have EndNote? EndNote is much more, professional, but it's expensive. It's not free. Okay. Now, after finishing this, No. There should be a feature of exporting. Where is this? They have changed a lot of stuff. Okay, I'll go back to the old version. This one. So here what happens is after you perform your screening, so I can go and export this data. So when you click on export, it will ask you all the filtered study, included studies, do you want to export? Yes, I can export in various formats. And then click on export, it sends an email to you as a file. Then you can have it directly in your folder. You don't have to use this tool. So the end of this tool is screening and identifying the study. Okay, clear? Here I don't know, ma'am, where it is. You can just here. Here. You can click on export and then you can change the format you want, whatever format, EndNote, CSV, and then export it. You want the filtered, you can just filter that information. So okay, everybody is clear now? So we will stop here. Now the process is, after screening, we should start extracting data from each paper. Email, it will come to your email, registered email. So go and check your email, you will get all the references. Not the full text, not the PDF. It just gives you the set of references that you agreed to include in your review. I'll come there. We have to make the Prisma. You can do it here directly if you subscribe for it. Or we can do it manually just by going through this information. I'll teach you how to do it in a while. So before you create a Prisma, you now identified out of this 374 records, you identified 5 studies eligible for your review. Okay? Right? Everybody got it? Now from these 5 studies, we should collect information for writing your review. There are 2 information that we will be extracting. One is that risk of bias, ROB, that is a critical appraisal of a study. That is number 1. Number 2, we need to extract numerical data for meta-analysis. That is number 2. The third one, we should extract the study methods. What did the study do? When did they do it? Which location? What type of randomization? What is a cluster randomized trial? Those information we should extract. Okay, clear? So before I just hand over, we will try to. Has everybody installed the review manager? Yes? Can you all go to review manager? For Mac users, you have to use the online version, but it is a little complex. Better to use Windows. If you are using Mac, for analysis, you can use Windows. And it is easy to use this tool. And you can just, download it from the link that I've shared and you can use it. Can you all open this RevMan? Yes? Okay, now go to File and click on New. Go to File, click on New, and then say next. It is asking you what type of review that you are doing. It is an intervention review, and then select next. Okay? Done? Now you have to tell the software what is the name of the review. Iron supplement for pregnant women. Okay? Next, you should select the full review and then say finish. Now this template is ready for you. Were you able to reach this? For Windows users, were you able to reach? Okay. Now go to figures. Click on figures on the left hand side. Figures. Right click. Add figures. Click on Prisma template and then say finish. You should get this template now. Yeah, Prisma template, next and finish. Where you get the flow diagram? Okay, now this is where you fill the data. Double click on this empty box. Now you should be able to type 374 data is identified by database screening. So I go to figures. Everybody got the right click, add figure, Prisma template, next and finish. Okay, I'll come and help. So everybody got it? Others are able to get it? For those who got it, you have to go and double click on this Prisma diagram so that you can able to fill the numbers here. Just practice that. We'll give you 5 minutes. So I say 374 records were identified database screening, and you can see how many are duplicates. Then you have to say out of 374, 300 actually been, 74 were duplicates, 300 were actually screened. Then you can double click and then fill the entire flow. How many were excluded? How many are included? How many are included in meta analysis? This is manual. If you use the tool will do it for you and create the figures for you. Yeah, double click on the red box. Yeah, you will automatically get the information there.
How much we need to pay for it?
Yeah, good job.
How much we need to pay for that?
I don't know, you have to take on how many users.
1% pay.
No.
We can pay for that all.
You will subscribe academic access, academic. But you don't have to just for that creation. I don't think so with this world investing on that money because there's no use after that. Because the job is done. Just have to find some research assistant or your PG to this with the table. Yeah, there is a funding for it. You can of course get it. Even better tools are there. It can help you do all screening. That's it.
This is what is the previous one for data. Next box is for what to other systems.
Yeah. Other database, no, not other database. It could be you can find some studies unpublished.
Unpublished.
You find some, data from other languages.
So the thing here, the first box, we are searching from more free data. We need to add So we have to add that number.
We say there 370, delete all of this. Three databases that we search, MH 250, submit 500. So you have to decide what you want.
Second, suppose other data, other books are not there.
Delete it. If it's deleted, it's even more. Just say editable format. That's all. We will come to them. I will explain you what you get to. Let's get the Pratma template answer. And then please save this relevant file somewhere in your folder. Okay. Now we'll move on to next data, and then little bit on the statistical side of it.
ಯಾರ MD ಸರ್?
That's definitely. This one, right?
Good afternoon, all.
Welcome Dr. Rekha, and she'll be taking the next session. We have already introduced her in the, you were not there.
Yeah.
But warm welcome from all of us here. And it's been a interesting session so far. And hopefully it will be much more better with you coming in. So welcome.
Yeah,
Thank you.
So this session is primarily on data extraction. Assume that you identify the studies now. Try and help you to screen the studies. Now you know that there are 5 studies that you want to include in your review. Now we should start reading the full text, again 2% independently, reading the full text and then trying to capture the data from the paper. So there are 3 types of data that I mentioned. One is risk of bias. The second one is numerical data. The third one is study characteristics. So now we will talk about the numerical data. Otherwise, after lunch, it becomes very difficult. So we talk about the numbers before lunch, and then we'll take the other. It will remain same in the folder. You can just copy the same button is there, you can save it, or there is a copy icon is there, copy, and then paste it in a Word document. We'll talk about the tool later on completely. Have a template. It's all free. You can search for Cochrane data extraction form, which is freely available. Or if you have money, you can go to Providence. You can go to this. There are tools in which you can manage the entire data. It's all not free, therefore we are not teaching that. But understand that I can give you the resources. Free, yeah. That is again a Word document. We will give those of data. Okay, over to you.
So good afternoon, all. So this session will be biostatistics and effect measures. So before going to that, just I'll give you the introduction about what is the biostatistics. and how the summary statistics will be calculated and what are those, because these things will be very much involved in the meta-analysis results. So the outcome, as he suggested, there are 2 3 types, like a binary format and continuous format, and the other thing is like a count. Still the count data will be taken into as a binary format. So how the numeric and data and count and ordinal types, the basic things will be taken and we'll see. Okay, so the first thing is we want to know what is statistics. So statistics means we all know that it is a numerical calculation. So if you know that the census 10 years once, 5 years once, the data will be collected, and based on that we'll come to know that the mortality rate, fertility rate, and each region on state level. According to that, we will take the decision in the government level and for the policy making and other things. So if you look at the statistic, it's there is a procedures or the process how we are going to have a data. Okay, even meta-analysis also it will have the same similar format. So the statistics which is defined in the majorly the 5 point. Okay, the main important thing is collection. So that is the major role plays in the statistics. Even though if you do, except the meta-analysis, if you do any kind of analysis, the collection of data is very, very important. So what you are going to collect? So as per your research question, so you have to frame which patients and which group of patients you are going to take, and what are the informations as like a demographic, clinical characteristics, or any other important like a primary or secondary important data what you are going to find out. So those things will be framed in a pro forma before starting your study. Once you start your study, it will be finalized, so that will be taken to collect the data. Okay, so this pro forma will also called as a case report form, or it's like a pro forma, it's a general patient details collection information sheet. So once the data is collected, the next important things we cannot take as it is for the analysis point of view, because whatever the data have, certain amount of typograph error or some amount of information will be it misleading the amount what you have collected. So you have to look at the range check and whether the data what you have collected which is logical or not, or which is you have used as a numerical or string format. So collection of all the data will be in your hand, so you have to make it in a proper format before going for your analysis. So in after organizing your data, then the next step will be analysis. So here the analysis will be lot of statistical procedures are available, but still it depends on your research question and what is your comparison point of view, or if you are going to follow up the patient for a certain time point like 2 years or 3 years. And as per all those things, the analysis will be selected. Okay, the analysis method will be selected for the analysis. Then fourth step will be presenting, how we are going to present. So the presentation will be, usually it will be in a table format and graphical methods. Apart from that, if you do case study or case series, those kind of studies, so usually we won't present the tables like as like RCT studies. So instead of that, how we can present the data is in a text format, how you are writing in a thesis or in a manuscript, the result section. The same way we can present it. So the last important point is interpretation of numerical data. So what is your conclusion about the study? So far you have spent the money and manpower and all those things, the research was conducted, and from that finally what you are going to generalize for the subject. So considering all the 5 points, the statistic process involved, now come to biostatistics. It is very simple because we know the process. The biostatistic, it is nothing but the tools will be applied to the medical research data or clinical data. So that will be called as a biostatistics. So the biostatistics, it involved in many different areas. If you look at the human, plant, and animal research, especially in a human research, pharmacology, medicine, epidemiology, public health, and physiology, anatomy. Even anatomy, they will see the cadavers, how many nerves which is present on an average in the skin or cheese bone. So all those things they will see, an average will be taken, that will be help for the surgeon to do the appropriate things. And finally, genetic studies. So these are the areas majorly works Apart from that, the very important things why we need biostatistics, because lot of informations are there, but apart from that we have focused only four or 5 points to define the normalcy. So what is the normalcy? For example, if you are going to collect the hemoglobin level for the 100 patients, okay, so we cannot expect that all the patients will have a similar range of the hemoglobin. So some patients will have a very low level, say 6.5.5, or some patients will have a higher level, say about 12 or about 13. So the both the ranges are abnormal, but it will influence your entire data collection and your results when you are generalizing to the normal group. So to define the normalcy, whether I want to check whatever the data hemoglobin I have collected for the 100 patients, which is representable or not, or how the data is, whether it is normally distributed or it is a skewed pattern. Okay, even if you see, look at the meta-analysis, most of the studies, when you are collecting large number of studies, finally we cannot see the mean ST was reported for all the studies. Some of the studies will be reported median and interquartile range. Some of the study will reported the same outcome in terms of median and minimum and maximum. So why they are presenting median and IQR, why they are presenting median and minimum and maximum, that is one of the thing is due to the sample size. So when you take a very low number of sample, so your data will be definitely, it will be skewed. So it won't be normal. At the same time, when you collect more number of data, especially the lab parameters, you won't get the exactly the normal pattern. Okay, so it depends on the data. We have to look at whether it is normally distributed or not. Second thing is to study the correlation or association. So which is, I can give example, whether if you look at the age and cholesterol level, say the same number of 100 patients are there. Now I want to do a study whether the age is correlated or related with the cholesterol level. So what will you do? You will collect the age and cholesterol for each and every subject. Then according to the interest or the research question, so you will look at the data, the age and the cholesterol, simply it is a numerical data. So which will be used, the correlation analysis will look at that whether it is related to or not. So whether it is a positive direction, you can say that whether age is increasing, then your cholesterol level is increasing, or age is increasing, your cholesterol level is decreasing, or it is stable. So those kind of information we can identify through the statistical method of correlation. Similarly, the term association is refers to only where you are handling the categorical data. Okay, so for example, if you take a smoking status, so we cannot take a measurement, so you can say whether the person is smoker or not. The same way, the person's outcome, whether he developed the lung cancer or not. So the basic data structure is a nominal format. So in those kind of scenario, the association concept will be looked out. Then third and fourth important point is to evaluate the efficacy of the drugs, which is especially used in the RCTs trial. Say, for example, the end of the study, whether the treatment works better compared to the other treatment or other standard procedure or not. And finally, the fifth one is to determine the success or failure, which is usually the probability concept that is comes under those statistics. After the surgery, the person will alive or not within a 5 years. What is the survival rate? So those things concept comes under the biostatistics. That's the important. We are using the methodology and we are identifying the research question answer. Now we moving to the types of data. So data, we know that it's a collection of information from the patients or subjects or individuals. Whatever the data we are collecting, that will be broadly into two way. One is numerical and other one is non-numerical way. So numerical, we can say further it is divided into two parts, discrete and continuous. We'll see in the next slide what is discrete and continuous. And again, the qualitative data will be divided into two sections, which is nominal and ordinal. So here the quantitative means the term will give you the idea what is quantitative, because we can quantify the values. If you take age, what is the average age of the group of sample? Or what is the average HB value? Or what is the average height, weight? So those are the things you can quantify, you can measure it. That kind of data will be called as a quantitative data. So if you go to example, the number of children in a family, number of death, basically these are numerical values. So the numerical continuous data, again, it's given the examples, height, weight, blood pressure, heart rate. These are the variables we can measure it. So the next one is qualitative data. So the qualitative data means we cannot quantify. Instead of that, you can make a category. For example, if you take to classify the characteristics of people who are dead, number of subjects who underwent to the surgery. After that, within a 1 year, how many death and how many alive. So the number and percentage you can define it. And blood group, if you take it A positive, O positive, like that. So you cannot find out any order in that. So instead of that, if you look at the ordered categorical data, you can see the order, how it is slowly it's growing up. For example, socioeconomic status. So socioeconomic status, you can say that low, medium, and high. So you can see that some order in it. The similar way, if you look at the severity of the disease or some other condition, it will be like a none, then it will be mild and moderate and severe. So you can see the step-by-step progress of the disease or condition, which will have the order. But the nominal data will not have a order. It can be 2 levels or it can be like a multiple levels as like a blood group. Okay, so for the statistical application, it's a two broad branches, descriptive statistics and inferential. Say descriptive statistics means, again, the term will give you idea what is the description. So when you have a lot of information, finally you are going to infer, or you are going to present with a single value, which is called as a descriptive. So as like mean, median, these are the values comes under that. And again, inferential statistics, which will comes under the meta-analysis or regression techniques or Bayesian concept, everything comes under the inferential, because you are going to make a research question, you are going to compare two groups or three groups, or you are going to compare pre and post of the same group, and finally you will make the hypothetical concept, a hypothetical framework, you will use it, and you will take the decision. So those kind of concept comes under the inferential statistics. So this is just the first approach, which is comes under the descriptive statistics, the measures of central tendency. We all know that what is mean, median, mode. But how this important is, because in the meta-analysis, the first part important thing is numerical data. So how the data is reported as a numerical way. So the mean, median, mode are called as a central tendency, because once you have collected the data, these are the central values will represent the entire sample information or entire group information of the patient's detail. So that's what this is called, the central tendency. So we all know mean is nothing but the average, or which also called as a arithmetic mean. And it is nothing but adding all the data values and divided by the number of patients or subject. So which will give you the average value. Similarly, the median is nothing but the middle value or center of the data values. So that is also will be describing about the sample, but especially which will be used in a skewed data concept. So when your data is a normality, which means it is represented for the normal group, so you no need to use the median. But when you have a limited sample size, or when you have a very skewed data, so that time the median will be the appropriate statistics which will be represented to the sample. So apart from that, the mode, which will give you idea what is the number of times the particular event or particular object value is occurring, that will be called as a mode. So here the simple example is given, the hypothetical raw data. So some few numbers, 1 to 8 it is given. So how will you calculate the mean is just adding the all values and divided by number of values present. So which will give you the estimate as a 4.56. So now we can say that the 4.56 is the my arithmetic mean, which represents the entire sample. Similarly, if I want to find out the median, easily I can pick up the middle value. But whenever you do the median calculation, before one step, we have to arrange the data in ascending or descending order. After that, we have to find out the median value. Similarly, the mode value is which is the number occurring more number of times. So in this sample data, the number 5 is occurs multiple times, which is 2 times occurred. So the 5 is nothing but the mode. So now other part is measures of variation. When you do the meta-analysis, the two important thing is mean and standard deviation will be taken. So the one is standard deviation, which is nothing but it talks about the variations. So whenever you present the data or whenever you are pulling the data for the meta-analysis, two important informations are required. One is the central tendency value, which is always presented along with the variation, which is nothing but the standard deviation. So we have to look at what is happening. So I have given two examples, set A and set B. So we should understand how the variation is differs for both the group. So if you look at the set A, there are 5 values given here. Set B is given again the 5 values. If you calculate your arithmetic mean, it will be same. But if you look at the variations, the first group will have a no deviation. It is very, very few. But if you look at the second group, there are deviations. So whenever you present the data as a descriptive statistics, you have to present the mean along with the standard deviation. So these are the concept comes under the variance and how we can, some of the studies when you collect for your research interest under the meta-analysis, standard deviation won't be given directly. So instead of that, they will give the variance. So how to calculate variance or from using the variance concept. So that's the formula I have given here. It's just taking square root for the variance, then you will get the standard deviation, because majority of the studies will not exactly present the mean and standard deviation. Always it will be, if you take a mean NRS pain score or VAS score, which will be presented as a median IQR or minimum or the mean with the variance. So how to calculate those variance, which is given here, the S square equal to x minus x bar the whole square. So simply each individual value will be minus from the average and taken square. Then if you take the square root, which will give you the standard deviation. Finally, the range, as I said before, when you see the studies where they are reporting the range and how to derive the value SD from the range, so we can easily capture that. So the range is nothing but the whatever the data we have, from that we are ascending, we are making as a ascending order and finding the highest value and the lowest value. From that we can able to calculate what is the range. And wherever you are finding the median in the article, along with that, the IQR concept will be presented. This is one of the statistics which will talk about how the data is spread or how the deviation is present in the data. So the 50% of the deviation will be eliminated and the center of the data will be taken. From that, we can able to calculate the interquartile range. So finally, the formula is just Q3 minus Q1, which is nothing but quartile 3 and quartile 1 value will be calculated. From that we can take the difference. So which is simple example given here, how to calculate the interquartile range. The data is arranged here in the ascending order and find out the median. After median, the portion will be divided into two data sets. And in the first data set, we have to calculate the median, which is nothing but take the middle of the value, add them and divide that. So you will get the first quartile value. Similarly, in the second part, again we have to find out the middle value, that is 14 and 18, and take the average, you will get the 16. So interquartile range is nothing but the Q3 and Q1. So far we have seen that how the mean, medians and the deviations are important for the RCT studies or meta-analysis study. But how the data will be reported in a 3 different way. One is summary statistics, second one is table format, and third one is graph. So when I was working in one of the studies for the meta-analysis, it's exactly the outcome is NRS pain score. So I have found there are 25 studies. Among the 25 studies, only 8 studies, they have reported properly the mean and SD for the data because the sample size is more. But remaining all the studies, they have reported the data, the main primary outcome data in terms of figures and in terms of text format. So they didn't report it properly in the table format. So how to take the data from those things? So these are the 3 important ways how they will report it. The first one is summary statistics. So this is the article what we have taken for the study, RCT studies. They have reported the numerical rating scale, which is pain score, which is reported as a 6.2, 2.7, 5.4, and 2.3. So directly they have given mean ST with along with the p values. So this will be reported properly. So we have taken. So they didn't give any proper table for that because they want to look at only one time point assessment, how the NRS pain score between the groups. The second study we have taken, that is like the same variables which was collected in a VAS score, visual analog scale, but the different time point they have analyzed. Continuously they have seen 4 hours once baseline, 16 hours, 22 hours, and 46 hours. So we had an interest to look at the last time point, the 46 hours, so how the pain score was reported. So here in the study, they didn't report the mean and ST. So instead of that, they have reported median and interquartile range. So what we have done is we have taken the median and interquartile range, and from that we have taken the sample size. We have derived the mean and standard deviation. Those values were considered for the one of the study input. So third important slide is, so the same kind of the pain score was not given in the text format or a table format. It was reported in terms of figures. So from the figures we have seen, if you look at the y-axis, the NRS pain score was reported in terms of median, and they didn't give any other information. So what we have done is, using the median and sample size and other information, we have calculated mean and ST, and those information was collected as from this study. Okay, so these are the different types of studies, how they are reporting the summary statistics, which will be important for the meta-analysis to combine those values and to give the pooled estimate values. So numerical data for meta-analysis. So we know that the meta-analysis which will have a, yes. Because we are deriving those values, mean ST, from the given picture median values and IQR or minimum maximum, the simple statistics. From that we can derive, and we are calculating. So you no need to mention anywhere in the footer or anywhere. So the second important thing is, in the meta-analysis, when you look at the numerical data, so the one important thing is the data extraction and management. So far we have seen that what is the types of data and what is the summary statistics which will help you to the meta-analysis. So here we are going to look at data extraction outcomes. So as I said before, when you start your study, make the research question. After that, what is the outcome and how it will be reported in terms of numerical format or in terms of like a binary or ordinal format, and what is the sample size. Whenever you collecting the number of articles or manuscript for your meta-analysis, these are the important points you have to find out. What is the sample size they have used? So if you find out the sample size is very less, maybe the reported statistics will be skewed, or skewed statistics they will be reported. Or sometime, instead of the IQR, they will report minimum and maximum, because when you're using the Likert scale or pain score measurement, the majority of the last endpoint value will be like a zeros, because the no pain. So when you have a large number of zeros in your data, so obviously there will be you cannot calculate the deviation or IQR. Instead of that, you will mention the minimum and maximum value. So that's why you have to look at the sample size, which will be very important. And second thing is missing participants information. Anybody is allowed to follow up or withdraw, or when you add up in the dropout rate, so what is the achievable number? These are all the points you have to look at. And summary data for each intervention group, which can be interpreted in terms of or reported in mean ST, or else the dichotomous format, number and percentage. And if you have any important like a confidence interval p-value, that is also important, because it will help you the confidence interval for deriving the deviation values. And subgroup analysis. Suppose your main outcome is not reported in the primary outcome section, then it is reported in the subgroup analysis or a secondary outcome analysis. So that is also important to notify all the informations. So here we are going to look at the measures of treatment effect, which is again how the data. So far we have seen the broad category of data types, but most of the articles will elaborately will present in different way. So the binary data can be dichotomous, or sometime it will be represented in terms of rates. And second thing is counts, infrequent events, number of strokes. So that is also reported way. The counts of frequent events, episodes of the jerk's birthday, and short ordinal scales, none, mild, moderate, severe. So where you are looking at the quality of life of the caregivers or any other pain score. So the Likert scale will be limited 0 to 4. 0 means none, 1 means mild, moderate. So those kind of scale, how they are reporting in the articles. Sometime long ordinal scale, as I said, VAS score, NRS or depression scales, which will have a many number of categories, 0 to 10, 0 to 100, something like that. So it will give you the progress of the severity or the reduction of the pain. And continuous data as like a blood pressure, how it will be reported mean as T. And sensor data, this is another scenario where after the oncology trials, majorly it's involved the survival analysis concept. So we want to know that the censored information on survival times. So among all those things, we are going to focus only two things. One is summary statistics of the dichotomous data and the summary of the numerical data. So if you look at the what is the dichotomous outcome? So we know that dichotomous, it can be a binary. So the binary means it can be this way or that way. So if you take 100 patients after the surgery, within a 5 years or within a 3 years, how many are dead or how many will be alive? Okay. So there is only two possibilities, this or that. So in that case, when you have a dichotomous whale like a VAS score 0 to 10 or say NRS pain score 1 to 100, so which will be categorized into two way. One is pain or no pain. Okay. So that's the way we can derive the data. Instead of taking all the data values or measurements values, we can divide, we can make a cutoff, and if the values comes below this, we can say this is the no pain category. Or if it is more than this cutoff, we can say that the score value is high. So we can say that there is a pain. So in that way, we can categorize, we can take it for the analysis. So not quite a dichotomous data is say counts of infrequent events and ordinal. These are the data. Again, we are going to make a two category as like a binary format or dichotomous format. So the counts of infrequent events, how many times it's occurred per day or per month or per year. So when you doing these kind of measurements, again, we can make a cutoff and you can say that this or this. So you finally, you will make your outcome as a binary format for the further analysis. Again, the ordinal data, say this example, multiple ordered categories implying magnitude, because it's very important when you look at the quality of life of the caregivers, when especially the oncology or the psychiatry studies. So they will give the ordinal scale format, which will have a lot of categories. So based on that, the score values will be given. So again, we can make it as a no pain and pain instead of taking the entire data or the average value. And meta-analysis of dichotomous variables or a dichotomous outcome, which will be reported in three different ways. One is a risk ratio, and second one is odds ratio or risk difference. The risk difference is related to the relative risk. So the first two is very important. The relative risk or risk ratio, which will be used as a measure of effect in the cohort studies. So where you are collecting your cohort patients who will have a similar characteristics of some particular conditions or particular features. So they will be one group. The other groups also followed for a certain time point. And end of the time after 1 year or 2 years, you are looking at that whether the group is developed any outcome or not. So you can fix your outcome as a particular event. But apart from that also, the patients can develop some other outcome also. So in those kind of cohort studies or prospective studies, the relative risk will be used as a measure of effect. And second one is odds ratio. These measures will be used in a case control. So where you are taking cases as well as control, and you are going back to their history and what are the exposure or the factors are influencing to develop the cases or the particular conditions. So in those kind of case control studies, the odds ratio will be the measure of the effect. So now look at this data. So especially the binary information or the counts or the numbers will be reported frequently in a 2 by 2 table, because we have a 2 columns and 2 rows. That's what it is called as a 2 by 2 table or contingency table. So if you look at your column, which will give you the 2 outcome values, one is headache and no headache. Okay. In your row, which is exposure, caffeine and decaffeine. Okay. So when you're following certain period of the subjects or individuals, and we are looking at how many of them had a headache, how many of them not developing the headache. Similarly, in the other group also we are looking at. So what is the total number? The sample sizes, study size is 132. Out of 132, 68 the subjects were had the caffeine and 64 not had the caffeine. So what happens here? The outcome, only who taken the caffeine out of 68, how many of them developed the headache is 17. So 17 out of 68, you will get a value. Similarly, in the decaffeine group, the 9 developed the headache. So 9 out of 64, that is the percentage. So based on this, we can calculate the simple relative risk calculation on odds ratio. Okay. So how to create or how to calculate or derive it is, the relative risk is nothing but risk in treatment group divided by the risk in control group. Okay. Risk in treatment group divided by the risk in control group. So what is the risk in treatment group, which is 17 out of 68. And the second group, 9 out of 64. So the proportion values given, the risk in the treatment group is 0.25 proportion value. And the similar way in other group, the risk was 0.14. Okay. When you take a division, so you will get a 1.7. So how will you report the 1.7? We can say the slight increase the chance of the headache. Similarly, odds ratio, which will be calculated as per the 2 by 2 table, the simple formula we can take AD by BC. Okay, here the AD is A cell value is 17 and the D cell value is 55. So multiply those two values, 17 divided by, multiply by 55 divided by B and C. So 51 into 9. So you will get odds in a treatment group divided by odds in a control group. So the odds ratio value will be 2.037. Okay. So the third measure what we have seen is a risk difference, which is nothing but it is related to the relative risk. What we have calculated as a risk in a treatment group or exposure group, first caffeine group is 0.25. So 0.25 minus 0.14. It's simply taking the difference between the two proportion values. So you will get the risk difference as 0.1094. Okay. So these are the three important measures will be used or reported for the binary concept, not for the numerical data. So summary statistics, so far we have seen the binary. Now we are looking at the summary statistics for the continuous data. So as I said, there are different way we can have the how they have reported in article or manuscript or thesis. So here the numerical data which will lies in the two concept. One is long ordinal scale. The other one is short ordinal scales. Okay. Usually in the nursing studies and the other things, what they will do is you will use the Likert scale and we can assess in a two way. So finally each question, for example, if you take a quality of life, it will be 20 questions or 30 questions will be asked for the caregivers, and the 30 questions answers will be added. The finally one total score will be given for the individuals or caregiver. After taking the calculation of all the total score, we'll find out the average. Based on the average score, we can make a division whether they have a good quality of life or they have a poor quality of life. Okay. So how we are making those cutoff? Because again, we are going to use simple statistic of arithmetic mean. So mean value or median value based, the cutoff will be determined. After that, we can take a binary format. So that's what here it is previously we have seen. But here, instead of that, we are going to take as a total score of the Likert scale, and we are reporting in terms of mean and standard deviation. So this ordinal data, again, it is having, if you look at this picture, it's simply given to understand 1 to 5, it is given. 1 is a mild pain or no pain, you can consider. 5 is a severe pain. Okay. So the data is collected for each and every subject, 1, 2, 3, 4, 5. So finally, if you imagine your total column value, the score value for each subject, it will be like a numerical value. So again, this will be taken and calculated as a deviation and the simple arithmetic mean. So that will be used as a reporting value. So what are the measurement scale? As I said, the quality of life and other, wherever you are using Likert scale and many domain where you want to define it, a physical domain or a psychological domain of the caregiver's question. So again, it will be reported mean and ST format. Apart from that, the important thing is like the change versus endpoint. If you look at the VAS score studies, usually the baseline will be collected and each time point after 6 hours or after the 2 hours. So multiple time point, the outcome will be collected. If it is a 2 group or 3 groups, again for all the 3 groups, the multiple time point, the VAS score will be collected. So how it will be reported in a proper study means they will report it the pre-value and each time point value, what is the summary statistics, all the things will be reported. Or sometime if you have an interest to look at the change from baseline to post-baseline, so they will report it mean ST in the baseline, mean ST in the post-baseline. Then the third column will be the change from the baseline to post-baseline. Then p-value. This is the format usually we will present it. Apart from that, most of the studies, what they will do is, instead of presenting the mean ST in the base and post baseline, directly they will present the change from baseline for the 2 groups. But what happens is sometimes they won't present the SD value for the change of the difference of the mean values. So we need to have all the information, especially where they are reporting the numerical data, the baseline individual time point we have to have. At the same time, change also reported along with the deviation value. Because if the deviation is not presented, we cannot give the summary value for the meta-analysis study where we are combining and finding the result. So change score can minimize between person variation because we are taking the difference between the pre and post or baseline to post baseline. So which will minimize the between person variation, and measuring outcome twice can lead increased variance. And whenever we do the numerical data we are handling for the meta-analysis, obviously we can take change or endpoint score as it is, what they have reported for each individual value. The change score required SD. That's what I said. So if the studies are present, their values or reporting values as a mean SD in a pre-post, apart from that, if they are presenting change alone, which means the mean difference alone, we have to have a SD. So whenever you are collecting the study for meta-analysis, you have to look at very carefully how they have reported the results. Simple descriptive statistic, but that will impact the your results. So you have to carefully look at the mean ST, or if it is reported median IQR, or if they are median IQR means you have to look at your sample size, what they have taken the sample size, and you have to derive it. If it is given change, then you have to think about any confidence interval, anything is presented along with the mean difference. From the confidence interval also, we can derive the standard deviation, then take the mean ST and use for your study. Okay, so that's what the this session. So this session is fully important to understand the simple statistics, but it will give you the more impact on your results when you are collecting the studies for your analysis. So that's it. Any questions?
Okay, we are talking about the data extraction. So we have just crossed level 3, where we are trying to extract some data from each paper. Okay, and numerical data is slightly challenging, but once you start reading paper, it might be easier for you to understand what we are exactly looking for. When we do practical, you will be able to understand what information goes into the data analysis. What I wanted you to do right now is, if you go to Google and ask for data extraction or collection form, data collection Cochrane. Yeah, just search for Cochrane data collection form. Laptop, they just have to on it. Projector on. Yeah, it went on sleep mode. Okay, if you just go online and do a Google search for Cochrane data extraction form Airways, you should be able to find a form, a template. This is a very comprehensive form, collecting data starting from randomized control trial and all non-randomized studies as well. Okay, can you just take a look at this form? You can see that it actually starts from this eligibility screening. Okay, the eligibility screening was done using Ryan tool. So therefore, this table is not required for us. Is everybody able to find this form? No? Okay, just wait for some more time. Go to ask for data collection Cochrane Airways. You will find this, there is a document which says data and assessment form template. Download this. It's a Word document. Yes. So this form is very, very comprehensive. It starts from screening and all the way goes up to collecting data from various designs. What we are interested in, we already performed the screening in Ryan tool, right? We have done the screening, we know, but we don't want these additional tables which are present. You can modify this form. You can see this. This just talks about the entire information, starting from what type of RCT that you are interested in. Whether the study is a simple randomized control trial or cluster randomized, quasi-randomized, interrupted time series, other design. These are various designs of performing a trial. Yes. That you have to manually screen it. You can just create a checklist. In the description you see, right? There you can list down your checklist if you want. But there's no option of ticking all of the box. Whereas in the manual process, you can tick all of this box. You can see here, we are just saying that we only include randomized control trial. Now it is asking, oh, it is a RCT. If it is RCT, then you tell me where exactly RCT is present. You have to note the location in the paper. If it is a cluster randomized study, you select that as a quasi-randomized or cluster randomized study, where it is present. The Cochrane process of data extraction is very, very detailed. So documentation on all of this happens in a Cochrane extraction form. Because Cochrane keeps on updating its review every 2 years. So therefore, you might have to go back and submit your form back to the editorial unit. Whereas if you write a non-Cochrane review, nobody is going to look at whether you actually have a data extraction form or not. Nobody is going to ask for it. Yes. Yes. 300. 300 forms, which may not go through the entire extraction because this starts with the eligibility. Okay. So if you say it is not a randomized control trial, you can see that this is include and exclude here itself. Up to you how you, if you take up the covidence and all this tools, it can allow you to download it in Excel. Okay, if you can manage everything in Excel, you wish to manage everything in Excel. Or it's up to you. You can also create a AP data form, AP info form for creating this data collection. So there are various ways you can manage this data. But at the end of the day, you will have only 10 studies or 5 studies. It is worth spending so much of energy on creating these forms and storing and all of that. And then you are going to fill only 5 forms. This is at the stage of collection, data collection, not screening. But this form is comprehensive. You can delete that steps. Yeah. So I'll go through this. So you can see it is starting. What is the type of article it is? Give me some information about it. Then you see screen the studies for eligibility. So this has already been done in the Ryan tool. Therefore, this is done. We don't want this. We can delete this. Okay, I don't want this table. Okay. Now, this is the characteristics of studies that I mentioned. What are the characteristics? I want to know what is the aim of the study, whether it is an equivalence trial, superiority trial, non-inferiority trial, non-equivalence trial. What was that study design? And then what is the actual parallel trial or a cluster or a pragmatic trial or a platform trial? There are a lot of various types of trials are there. What it is? Yeah. Okay. So this is a comprehensive collection for a Cochrane review. Okay. The screening also need to be documented on this. Now the technology is available, therefore we remove the screening, which means that 374 studies already screened in Ryan. So you will not have 374 forms. What you will have is only 10 forms that are included in your review. Now it's clear? Is there confusion? Technology comes, there are tools extracting the same data in an online medium. You don't need this form directly, but you have to have access and you should pay for it. Covidence in such type of tool that exists for data collection. Yes, not the full text. Yes, yes, that is your inclusion criteria. You need to have it. That's you don't mark each and everything manually. See, I tell you an example of how people do screening. So you see here, right? Cochrane methodology. I'm talking about Cochrane now. Now Cochrane says, I will only include randomized control trial. When I go and look at the abstract, it says it is not a randomized control trial. Other designs, yes. Done. I will straight away go and exclude it. I will not even look at what patient information because it is not RCT. So why will I just fill all the forms? Now, if it is an RCT, yes, then I will see patient. If it is adult, my studies on children exclude directly. It's up to you how you want it to function. Like if you want to give all the detailed information, you can collect it. Or if you know that I have written the protocol, I know what I'm looking for, I can simply, because nobody's going to go back and ask you. The importance here is Cochrane will ask you what level that you excluded. Whereas if you're doing a non-Cochrane review, nobody's going to question you how many studies are, patient level exclusion, how many studies are, intervention level exclusion. Nobody's going to ask. So therefore, you don't really need to say, because sometimes you might find 1,000 studies. Doing that screening itself will take a lot of time for you to actually read, because you have to read to answer all of them. Correct. No, this is acceptable. So now you don't even use this form now. There's a tool called Covidence. You do all of this into a Covidence and you import it directly there. So I'll just give you one example of how that, but you don't have access to it. You can ask for an no, you low and middle income country, you ask for access, they will provide you. If you have funding, then they might ask you money. You can check that. This is a Cochrane suggested tool. Okay. You can see it's connected to Cochrane. So you can see this reviews which has been linked up with the Cochrane. You can get your Prisma flow diagram. You can export the data in various formats. So this will do all of that. If you have money, you can subscribe for this. And it will start from screening and all the way goes up to data extraction. You can see import the references, title and abstract screening, full text review, and extract data. So you can see extract. When I say extract, so it is giving you the full text. So these are the extraction methodology: quality studies, data extraction. You start, it will give you the template automatically here. What is the sequence generation? Make a judgment. You have to read the paper and do all the extraction here manually. You can edit this, add domain, delete domain, edit, and all of that. Data extraction. You can see methodology. What is the type of study? Population, inclusion, exclusion criteria, baseline data, intervention. This is a template by software itself. Take from this paper. We have to do. Either you do it in Word document or you learn the tool. It depends upon how much time that you have. And if you have 5 studies, if you know how to use a Word document, finish the job there. If you have 5 studies, you have a lot of time and money, then you can buy the software and then spend time on learning it and then play with it, and then you could extract the data. So it depends on what level that you want to go. Why you are a professional organization writing reviews, there's a funding for it. Probably I will go with the software because I want to manage the team. I have 10 people who are working on the review, then I could manage the team with this software and tool. Otherwise, it's up to your decision how you want to manage. And all of this will come into an Excel file at the end of the day. So you can see all the completed forms. You can go here and ask for a export function. After you do all this, you can export them. These are various tags. Here you can just export them in the format you want, CSV or Excel or whatever. But this has been built by in the software itself. Okay. Let's not learn all the softwares because it might confuse you. And to learn this itself, it takes 1 month to understand how to fix. Okay, let's not go into that. Let's come back here. So here I will start collecting data for each study. So I should say when the study is being done, when it is ended, duration of participants, ethical approval, and then go on to talk about the inclusion exclusion criteria in the studies, informed consent, withdrawal, age, all this demographic data. There ends the participant. And then intervention. How many people were randomized? What was the theoretical basis? What was the description, duration of treatment, timing, delivery, provider, co-intervention? All these compliance, all this have to be filled. You might not have all the information, but as maximum as possible, you should fill. And then copy the same thing and paste it for the comparison group and fill it for the comparison group. If it is a multi-arm trial, one more copy paste, fill the third group. Similarly, outcome data. Rekha was talking about this data, right? Mortality. Mortality is yes or no. It is a dichotomous outcome. Therefore, 2x2 table data needs to be collected. So you can see what type of data either information has been obtained. If it is a scale, rating scale, more the value is better or less the value is better. So directions. So all these need to be documented, upper, lower. You copy paste this table multiple times for each outcome and try to extract the data. Understood? So this is the entire process. Once you fill this information, then goes risk of bias. Okay, risk of bias where you will be trying to perform the bias assessment. Okay, on all of these different domains. So maybe we will take this risk of bias domain tomorrow morning when we are fresh to understand how the risk of bias happens. And you can see this form contains all this. And then dichotomous data, what you should capture, number of people with the event. There are 100 people randomized, 80 of them or 20 of them have died. The comparison group, 100 people randomized, 30 people have died. So this data we have to capture from the paper. If it is a continuous data, it is asking you to capture the mean, standard deviation and number of participants from the result. And this will be repeated for each. These are not required. These are interrupted time series analysis. So I will delete this unwanted information which is there. And finally, other information. What is the conclusion? Is there any information required from the author? Should I write an email to the author for asking any missing information? The author might say, we have randomly divided into 2 groups. Is it a randomized control trial? We don't know. So you might want to contact author for more information. Not specified how it's going to add value to your review. Everybody will write everything is non-specified. It's all not having good quality studies, right? So you should attempt to contact authors for any missing information. So all this have to be filled. So you can see for one study data extraction, if you extract it, it will take at least 1 day. This is for a systematic review, only the numerical data for meta-analysis. Meta-analysis. There are three components. That is what I'm trying to say. The first component that you are trying to extract is for the general information and characteristics of included studies. Number one. Second component will be your risk of bias. The third component will be your data and analysis, which is meta-analysis. There are three components of extraction has to be done. Only if you perform these three, then you should be able to give a good quality systematic review. Okay, the challenge that you might face is in two places. One is the risk of bias and the numerical data. Otherwise, the characteristics is what they say in the paper. It is just anybody can do it. They just copy and paste it here. Whereas the risk of bias is you have to critically appraise the article. What they say is actually true or not. The numerical data, again, you can do it, just copy paste. If you understand it, just copy and paste it from the paper. Sometimes this paper doesn't give us that directly. We might have to use graphs, or you might have to recalculate, and all of that has to be done. Or if it is not available, you can write to the authors for information. There are 5 papers which reported the outcome. The 6th paper did not report it. But it has been done on the same sort of a framework. Probably you would have thought, oh, let's not report this because it doesn't show significant value. So in that case, you would have documented, but it is not available for you to use it. So you might have to contact the authors. So what happens in trial? You wanted to study everything, and then finally you write a report. Is there a chance that person can change the outcomes and report what he wants? Possibly, right? Maybe, I want to only show a significant result to sell my paper. I found that this is not significant, therefore I dropped that outcome while reporting. So everybody pre-specifies, everybody gives it. But who writes at the end of the day? So that is one of the component of risk of bias. We'll talk about the bias assessment tomorrow. Okay, this form needs to be filled for 5 studies, 10 studies that you include. Only if you do this, then you can go on to write your review. Okay, now we'll go back to RevMan. I'll just walk you through what RevMan is trying to help us. Now you can see this. Everybody able to fill the Prisma time template? And you can just try copying this. Copy, open a Word document, and then paste it. It comes as a figure after you fill it. That's all. The first figure is ready for your publication. Prisma template. After you filling the Prisma template, just copy and paste it in a Word document. Done? Can you just make that attempt to see whether you are comfortable in copy pasting? Done? Copy paste? Okay, if you want, you cannot edit this in the Word document. You have to go back to RevMan to edit if you want to make any changes. This becomes an image. Okay? The first figure is ready for you to just submit for your publication. That is a Prisma template. Now, if you go back to how do I write my review, what all I should just add. So you can go to this place, background. If you save as, You can also create an image and then import it, but copy paste is very straightforward. So you can see my screen, then you can perform. Double click. You see this icon which says copy. And then go to a Word document and paste it. Done? Okay, done? Sure. Okay. So now, how do we just start writing a protocol? So you can see here, Cochrane offers you to template for writing a protocol, but don't write it in this platform because you cannot just submit it to publication. So you rather copy the template here and then open a Word document. Can you paste it? You can see this gives us a template for writing your protocol. What I should write in my protocol? Description of condition. Can you copy and paste it and create in a Word document? Yes? So you do not know what I should fill and all of this. You can go back to RevMan and ask the RevMan itself what I should write. You place your cursor here, right click, and then go to help. Okay? Were you able to find? Or you can just use this guidance. If you're not able to take the help button, there is a guidance which gives you much more precise information. Were you able to see the guidance icon here? When you click that, under each section, it will tell you what you're supposed to write. You can see here, description, a background. So you should talk about clear defined question and all of this. And under each heading, you will find the details. Now the handbook is on online. So you can see here an online handbook, a brief description of the condition being addressed, who is affected and its significance. It may include information about diagnosis, prognosis, prevalence, incidence, burden of condition, and all of this. You're able to find this? Yeah, you have to open this detail. When you click on the details, detail? Okay, then what you do, just go to the online, that's all, it's training.cochrane.handbook. Just search for Cochrane handbook, straightforward. Go to Cochrane handbook, open it online handbook. You want to buy a PDF, you can buy, or if you this is chapter 1. So chapter 3, I think. Yeah. Just go to chapter 3, reporting the reviews. And then below that, you will find reporting of new Cochrane reviews, background and objective. So this is going to give you an idea of what you should write. Okay, it's all there in the handbook. Or the easiest way, download a Cochrane review and see what they have written. Okay, you want to theoretically know, you can get it from the handbook. Practically, if you want to see what they wrote, take up a Cochrane review, read what goes there. Understood? And what is important here in the template is, this place is very, very important. From methods. What is the type of study? Criteria for considering studies for the review. RCT. What is the population name? What is the intervention? What is the outcome? What is primary and what is secondary? And what is the databases that you are going to search electronically? What are the other sources that you will search? Like clinical trial registries and all of that. And how do you select the studies? I am using Ryan tool for screening the studies and 2 people independently selecting the studies for inclusion. How are you going to extract data? I will use a data collection form, or I will use an Excel form, or you'll use an Covidence. Then you have to fill all of this. We'll talk about this heterogeneity and meta-analysis tomorrow. So these are needs to be filled in. So now, yeah, you have to tell how did you perform your search. You will develop a search strategy. How will you develop? What are the keywords? Okay, now what I would all of you to do is take this Word document that you got. So everybody is able to create this template? Yes, no? Yes. So now start writing some bullet points in the methods. Morning you started with a PICO, right? You said I want to do a review on this PICO. Now go to the methods and then start filling some details. You don't have to make a sentence. Just make bullet points what all goes there. Can you spend some 15 minutes there? They have just submitted this search strategy. Original search up to 2020. And after that, additional search has been done. So they present the information for Embase separately, PubMed separately, Cochrane library. Yeah, this has to be submitted. This is not a Cochrane review. This is a review published in some journal. Yeah, it goes as a supplementary file. Yeah, as a supplementary file. Just a few sentences. We have searched using this following search strategy. You can see here. You can see they have used a Ryan tool. All this is okay. Here you go. The assistant from the information specialist. We search the Cochrane library, Medline, PubMed, Embase from this, and then search terms of detail provided in the supplementary file. The date. That's all it is. Just one sentence with no time or language restriction. Finish. That's all they are expected to write in a paper. But what is more important is how the keywords are being collected and you use the operator. That's the most important, aspect of this. Writing, you can borrow anywhere and write it. It's available. Corporate actually has other languages. You don't have to specifically change it. That's because there is a many parallels happening. And two right articles Japanese and efficiency. And the system translates that as and efficiency. It will come, and most of the abstract will be in English. So the full manuscript will be Japanese. But at least have an English version of that abstract. Until it is not indexed in PubMed, you will miss, of course, you will miss that. Yeah. I will just show you that to give you some clarity. So you can see here. Now you can see over here additional filters. You can go to others, article language. You can see all of these languages. Let's take Spanish. Spanish, you will find a lot of articles. I apply this. There are 4 Spanish articles are there. You see all of them are in English because it's a translated version, but the original article will be in Spanish. It does search, but if it is not indexed, then it's not going to be available here. Okay, how many of you are able to find some reviews which gives you the search strategy? Okay, if you have them, can you go to PubMed and apply that and see whether you're getting a similar result? Can you validate that? Meaning, I got this search strategy now from PubMed. I'm going to copy this and then go back to PubMed and then recreate it. That's all I just So you can see that easily you can just reproduce this. And if you want to learn how to do it, you just have to divide this. You can see wherever you find an AND operator, that is going to be the new group. You can see now, how many groups are there? So you can see 4 groups that they are trying to create and combine. Pregnancy, gestation, all this combination, iron mesh terms, iron compounds, and then dietary supplement, pharmaceutical preparation, pills, all this, and hemoglobin. They also search for an outcome, hemoglobin and all of this mesh keywords, and then obtain the result. Okay. So can you just try to make that sense of how the keywords are being used, what they have done in the study? Just copy paste. You don't have to do manually. Then you have to understand where to use or and where to use and. So here you can see that pregnancy is one group. All the terms associated with pregnancy, gestation, and all of that, they use or. So how do you search manually in PubMed if you can't copy paste? Go to advanced search. Okay, and you can easily type. You see here operators automatically comes in PubMed. So you can click on or. What is the other keyword? Pregnant women. So when you use 2 keywords, you have to specify using a quote. You can see that it automatically adds or. Then the next keyword, you can go to mesh or. Okay, if you want to do manually, you have to just copy paste each keyword and then use or, and you can also use this select mesh term and all of that. Then perform a search. Now you can see that these many articles are available in PubMed. So this becomes your keyword number 8. Okay, then you can go back iron and all of this. Then you can say 8 and number 9. If you want to play with the numbers, you can create each one and store it in one number. And then what I will do, I'll tell 8 and number 7. Okay, not or, because I'm combining 2 different groups. So instead of just typing all the information again, and specify the numbers. So that you can find it here in this, not in this keyword. You can see in here, number 3, number 4, number 5, or. And you will finally find 9 and 18 and 25 and 41. That's a combination of all of this. Which means that the 41 times they have just entered some information to get the search strategy done. Okay. Can you go through a couple of this and then ask if you have any questions? Okay, here you can see, here let's take this Cochrane library. I think that might be easier to follow. They are saying that the mesh keyword that I'm looking for is pregnant women. Pregnant women is a mesh keyword. The second one, they are talking for pregnancy as a mesh keyword. Number one will be the pregnancy, pregnant women. Number two will be pregnancy. Number three is what? Gestation. Number four is pregnancy. Number five is pregnancies. Six is pregnant. Spelling variation. And then they are combining all that with the numbers at number 7. You can see 1 or 2, which is a mesh. Number 8, 3 or 4 or 5 or 6, which is not a mesh. Again, number 9, combining 7 or 8. They're going with the sequence. So remember, in mathematics, 5 plus 6 minus 2. What will be the answer? Because you're going in the sequence. You're first adding and then subtracting. If I put a bracket in this last and then try to add, it might have a different meaning. So similarly, when you search for it, it depends upon how you try to search for it. Okay? So that is why you can see they are going in the sequence. Mesh separately or, and the keyword separately or, and then combine the mesh versus this. It might end up with the same result, but they are trying to give a clarity on the search. Anybody has got any questions here? Cochrane is not free to search, unfortunately, but we could do it in PubMed. Okay? Okay. If you go, all of you just follow what I'm saying, delete this if you already have done something. Yeah, I'm deleting it. I'm just going to do that now. So now you can see here, I want to search for pregnant women, right? Okay. I can directly say here as mesh major term and pregnant women. Or you can go to a mesh database. There is a separate database called mesh, and I'm checking, is there a pregnant woman as a mesh keyword? Yes, this is a word introduced in 2003. Before that, there is no pregnant women as a separate entity. They are calling pregnancy or something else. Okay? Understood? Everybody able to reach mesh database and get this? Can you repeat what I'm doing? Now I'm just saying that I want to add this information and find studies from PubMed. Just watch my screen and then you can repeat. I'm clicking here, add to search builder, and then search PubMed. Now if I go to advanced, you will see the number 1. Can you just confirm whether you have number 1? I think that doesn't matter actually. It's just one word, right? Everybody got 1? And click for search PubMed. Did you get number 1 or where some other number? Okay, if you don't delete it, you will have another number there. Completed? Okay, what is the next keyword? Pregnancy. I can go back to mesh again. I'm searching for pregnancy. What you can see, there are a lot variety of pregnancy as a keyword is available. But this one is introduced in 1963. Let's go with this. And then add to builder. And then search PubMed. Now you go back to the advanced search. You will see number 2. How many of you got this number 2? Okay, cool. Others, we'll give it 2 minutes time. Number 2 done. Same process repeated, but using the keyword called pregnancy. Okay. Number 2, how many of you got number 2? Shall we move on to number 3? Number 3, gestation. This is straightforward. You don't have to do anything. Just copy and paste here. Add, search. Done. Can you repeat the same thing for other keywords? Pregnancy, pregnancies, pregnant, and all of that. All combination keywords have to be applied. Sometimes mesh may not be added. So they would have missed some studies. So you cannot completely believe. Yeah, you can see. I'll show you an example what happens. Just a minute. Let me finish this. That's a very good question. Correct. So you can see that. Exactly. You can see what is the importance of pregnancy using as a mesh keyword, just using a open keyword. You can see that these many studies are actually additionally more. 1,000, 1 lakh plus studies already will be covered here. In addition to that, there are more studies which has this term. Absolutely, but you have to ensure that we capture all that in a keyword search. The search strategy should have all combinations. But it will reduce at the end. When you just combine it together, you will not get that many studies. Basically, the idea is all combination variants you have to just apply. Not trust that pregnancy alone will cover all the mesh keywords. You have to explicitly state it. Mesh is basically, if you want to understand the logic behind it is, let's say you got 100 books for your library. What the role of a librarian? He has to mention some sort of a rule. Either it has to be arranged in alphabetical order or it should be arranged in a department-wise order or something that you should manage. So mesh is like a standardization. I publish an article in a journal about pregnancy. When it enters into PubMed, PubMed assume is like a library. So what it does, it adds a pregnancy keyword next to my article. Whether it is actually tagged to the mesh database, even sometimes it will add, it may not be added to the mesh database. It will directly go. Because there's only 10 keywords that you can add, pregnancy being a 11th, it is not been added. So therefore, you will not find when you search for mesh. When you keep it as open, then that will come as a result. Correct, but you have to explicitly state that you have covered everything. Otherwise, they will not know, right? You're assuming PubMed does the job, but how valid is it? We don't know. So we have to mention in here, the validity of your review depends on the keywords that you employ and the search strategy that you provide. It is just basically a new introduction of library basically. Like you see ICD coding, COVID. You search for COVID, COVID can be searched, right? Why we didn't have a standardization? So therefore, you try to bring some new keywords. Even if you look at this, pregnant woman is a new mesh term. 2003 that they have added it. I don't know why they added. You can take it like that. You have super specialty just breaking up from different domain department, right? Something like that. Okay, quickly. You all attempted all of this number. Now what I should do? So I am going to use not and, or. So I can directly use everything or I can just tell number one. I can also type here directly number two. Or if you want to do number one. Okay, sorry, you did it. Number one. Or this is a search that they have done for a mesh. Okay, you can see that number 7. Number 8 is for 3 or 4. You can directly type also. Okay, 3 to 6. Now I can combine the 7 and 8. Yes. For 2 things, it's not a matter. If you have combining multiple things, bracket matters a lot. These are same domain, doesn't matter. If you combine and or together, bracket makes a difference. Now you can see for this particular domain, you can see this result and this result remains the same. Which means that the set of studies that you have here is actually part of this. Now you might ask, why should we just do this? We can directly do this, right? That was your question. Why should we just add this? But we are documenting it. It doesn't make a difference on the result, but we are telling the readers we are able to, construct the search strategy in a proper way. At the end of the day, they're really not having any impact. You can see all the mesh keywords, exactly the same result. Mathematically, if you evaluate, it's the same result, but qualitatively, we should document that. Does everybody get the same result? Now, similarly, you go and search for the iron supplementation and then combine it using AND operator. Can you do it? I'll just present this. Can you just do this and tell me? whether you are getting the same result or not. Not at the moment. There are it's new, you just have to learn, right? Like how you write, basically. That's a concept of plagiarism, where you try to avoid plagiarism to introduce some new way of describing it. So there are some place where you can find, but nobody trusts that actually. Can you repeat this for the iron supplementation? Iron, quickly. They are using something new here. If you make a note, you can find the star. What does the star indicates? Star is kind of a truncation, meaning in the language of searching, star possibly takes all combination. If you look at therapy, therapeutic, therapeutics, you can just say therapy star. All combinations will be taken by the system. So similarly, here star indicates iron supplementation, whatever combination next to it. So they're just checking out mesh. Okay, everything possibly they can find, they are attempting to capture that. And then combine this two, forget about the hemoglobin. Combine this two and tell me what is your result. Sorry? Ah, it will be there. Oh, you deleted completely from there. Then it's gone. If you remove it from the history, it is gone. Sorry, here. If you are really interested in the same topic, what you can do is you can create an account in PubMed and then store your search strategy. Therefore, you get an update automatically every week, every month. If there is any new study, it can send an email to you. That is one way. The second way is we can go here and then download all the results in a PubMed format. Okay, for screening. And you can also document your search strategy by downloading this search keywords and the steps in a Excel file. So for manual download this search strategy, and also along with that download the set of studies. If you want to work in cloud, create a user account and then you can store it directly in your user account. Later you can retrieve anytime. Clear? For those who have got a user account, it's free to create, but you should use your Gmail or some other account to access it. So you have to authenticate the permission from your Google account to access this site, and then you can store it in your user account. Okay, these are the steps. So please document and update your protocol that you're writing. Just save that, please. For tomorrow, we will try to just add the rest of the other information. Therefore, your protocol is kind of ready and you can go and register in Prospero. Okay? So any questions, or we will just stop here for today? And please save all the documents that you have created. All the files that you have created, please save it before you shut down your system. Okay, thank you all. Let's meet tomorrow. Which one? This one? Oh, that I just copied from here. Or if you want that kind of a document, what you can do is, no, here, go here. I also moved out. So if you want that all combinations, you can see here. All these will be available here. You can copy all of this and paste it if you want. If you don't want to see the numbers, if you want to confuse everybody, you can just copy all this. Finally. Any announcements or any announcements to? Nothing. We are closed. Oh, we'll start tomorrow at 9 sharp. So please be here. Okay, thank you, everyone. Yeah. Oh, yeah. This is the way the government understood the going. Data extraction is present, which is a critical appraisal of a randomized control trial. Okay. Why we should critically appraise? Like the reason behind is if you look at studies, especially while conducting systematic reviews, you might end up including all variety of a good quality, bad quality studies. So we are not really trying to criticize somebody's work because this has already been a public domain, peer reviewed and published. So don't think that, oh, we are criticizing and saying they did not do a good job. So what we are trying to say here is, we are just trying to say risk of bias. We're not calling that as a bias directly. Okay. So therefore, the tool that we are using is here is called Cochrane Risk of Bias tool. There are multiple tools available for critical appraisal. Yesterday I mentioned a tool called CASP, CASP. How many of you are looked at what is CASP? Okay, CASP is a tool which actually tries to evaluate a trial or a study which is going to be talking about internal validity and an external validity. Okay, there are two important components in conducting studies. One is the internal validity of a study. So internal validity tells us that how good is the study or a methodology which we have employed to arrive at this conclusion. External validity talks about how good is the study applicable to my setting. There are two different aspects to a study. Okay, so external validity primarily applies when you wanted to draw some conclusion for your practice. For example, during COVID, we all seen a lot of mortality happen. There is a study which is conducted in UK where the mortality rate is only 7%, whereas in India the mortality rate is 20%. Okay, they might see a fantastic benefit with the drug. Is that result is directly applicable to us? What do you think? Not necessarily, because their health system is completely different and they were able to give a result which is good because of their health system. If you just try and say, oh, that study has showed a fantastic effect in UK study, let me just start practicing here. You may not get the same result, but you might improve the quality of care or something. But definitely it might be difficult to show a beneficial effect because the health system is completely different here. And the problem that we face is 20% of death. We are, even if you try to reduce 2% of mortality, that is a great for us. Okay, that is the kind of validity that we are talking about, but we will not focus on the external validity of studies. Okay, so here we are talking about internal validity of especially randomized controlled trial. Is there anybody who wanted to do systematic review, not including randomized controlled trial and including other various type of studies? If you wish to do it, then the internal validity of those studied as a different tool. Okay, so for that, where you should go is, you should go to the website called Latitude Network. Just make a note of it. There is a website called Latitude Network. So here you will find different types of tool helping you for evaluating its internal validity. Okay, so you could just go here and say, I want to look at a cohort study. You can see these are the tools available for evaluating cohort study. Probably if you read some systematic review, you would have come across Newcastle Ottawa scale, and all the risk of bias tool are being systematically assembled in this place. Okay, this is a very important resource if you are looking for any tools for assessing bias. If you look at a randomized control trial, you can see that there are many tools available. What people are accepting currently is risk of bias 1 and risk of bias 2, which is basically coming from a Cochrane methodology perspective. Okay, you can see that it has been published at various time points. Initially, people used to use Downs and Black tool and various other tools. These are very old tool. Currently, people use this tools for evaluating. And also, look at this. If you are trying to evaluate a systematic review for your its internal validity, then there is a tool called AmStar checklist. So you get all this information over here talking about the validity of studies. And also I would like to refer to another website. This is another website which has been developed by the same group of people, Equator Network, which gives you information about the reporting guidelines, what type of study that you are planning to do. And the first place I would say is, if you plan to do any research, you must go to this website and then read what they are expecting you to report when you publish it. So the product at the end of the day is a publication, right? Whatever that study and research that we do, we wanted to, at the end of the day, publish it. So if you want to publish in a high quality journal, there are minimum requirement for you to just, adhere to those reporting principle. So this is a guidance that provides you. If you are trying to do a randomized control trial, you should just look up for a consort checklist. The consort checklist is going to give you that these are the minimum information that has to be present in a article when you write. So if you plan your study based upon what you are supposed to write at the end, then you can do a good quality study. Okay. Then at the end of the day, you go and submit to a journal, and the journal says that these informations are missing. You would have done good quality studies, but you are not documented it. Where will you go and find? Probably you write something on your own. So to avoid that kind of a problem, you definitely have to just start with the consort or these reporting guidelines checklist and see what you must report at the end of your research study. Okay, for a systematic review, you can see here there is a Prisma checklist. That is a checklist which kinds of gives us an idea of what all we must. It is kind of a checklist, so you just have to see we have all this information collected in your study or not. And now people are coming with a lot of new guidelines, including AI and all of that. So you can find all of them over here in this two place. Okay, I'll just stop, go back to the. Okay. So we are primarily looking at the validity of randomized control trial, and I'm going to demonstrate that a risk of bias 1 and risk of bias 2 is the extension of risk of bias 1. Risk of bias 2 is little more detailed version of it. If you can understand this principle here, then it's just a translation of extended version of that 2. Okay, I'll just start from basics and then we can build on to number 2. Okay. So now, every randomized control trial that we do, the idea of randomization is what? Why we must do a randomized control trial? Why can't we just simply do a controlled clinical trial or a non-randomized clinical trial, quasi-randomized trial? There are a lot of variety of trials are present, but among all of them, randomized control trial seems to be on the top. Why? Reduces biases. Okay, what type of bias? How it is reducing? How it is achieving? How do you know it is reducing? Selection bias, right? What is a process? Exactly. So you can see that when you try to just recruit a subject into your study, if you do even a random, selection, sometimes it might not be, able to give a proper allocation. For example, if you take a smoking, as a one of a confounder, which is going to play a role on your, results, there are variety of randomization techniques are available, not just only purely a randomized. We say people often write, we randomly divided into 2 groups. How do we verify randomization actually worked? The idea of randomization is to balance these known and unknown confounders equally in between 2 groups, right? That is what the randomization is trying to do. Therefore, what we are saying is, when I'm going to start treating my patient with the drug, both the groups are, equally having the same characteristics. So which means, if you're going to look at the, baseline characteristics of your study, or when you're reading any article, if you look at the baseline characteristics of, study, the data, which is going to tell you that whether the randomization is actually worked or not. Okay. So that is one way of cross verifying. People can say that, oh, I've done a randomization. Whether it has really happened, you can cross verify that looking at the characteristics of data at the baseline. Okay. And you can see that if there are randomization doesn't work properly, people go for other approaches of randomization, which is stratified randomization or permuted block randomization and cluster randomization. So these are variety of randomization procedures which are there, depends upon what sort of problem that you might face. Okay. And I just start with the problem and then we can find solutions to it. So typically when you just try to do any randomized control trial, the most common approach people try to take is a parallel arm trial. What is parallel arm trial? One group is going to receive intervention, other group is going to receive control. Okay, only two arms. Sometimes you might do a multi-arm trial. I want to add another, arm. So multi-arm, usually parallel arm trial is what people try to do. So this is an example of a parallel arm trial where you initially start with a problem called selection bias. Okay, the selection bias is a first problem that can occur in a study while recruiting the subject. So to avoid this selection bias, we all know randomization is a technique to ensure that we have been fair to select everybody into a study and allocate them into two groups. Okay, that is the first solution to this selection bias. There are two stages of approach here when you avoid selection bias. First is, how did you generate the sequence? Meaning, what is the method of randomization? You're saying, oh, I have done a randomized control trial. Now you have to tell me that what is the method of randomization. So there are various of methods. We'll go through a couple of methods there. And then the second stage is, you got your randomization done. How did you ensure that you have just used that randomization appropriately? That is where concealment is going to play a role. So two things combined together forms randomization. Okay, not just only saying, oh, I've done a randomized control trial. Okay. The second bias that you can see is performance bias. So now the participants are recruited in your study. Now they have been assigned with the treatment. They started taking the medication. Now a nurse comes in and tells the doctor, listen, he's not well, he's been having some problem. Then the doctor adds co-medication in between. Or the doctor is aware of, the PA is aware of what the treatment that this patient is on. He wants to show a beneficial effect on this treatment. He goes and modifies the dosage, or he tries to add additional co-intervention. Therefore, there could be a beneficial effect. So that is called a performance bias. So to avoid performance bias, we are trying to ensure that nobody aware of what treatment that they are taking, which is blinding or masking is a technique. Okay. And the third bias, what happens when they are on the study, they have been taking medications. People say, oh, I got well, so let me just not take medication. They will not adhere to the treatment. Especially you can see this tuberculosis treatment regimens. Adherence becomes a big challenge. Okay, people are trying to out whether we can reduce the duration of treatment so that the treatment course can be completed. So attrition bias is the biggest challenge. People might not take, or they might drop out from the study. Okay, that is a third problem which can occur. So we can evaluate it, but we cannot control that. Like you can control the blinding using performance bias through blinding. You are trying to control the selection bias through randomization. Attrition bias can be estimated. You could attempt to control by increasing your sample size at the initial stage of accounting dropouts, but it's very difficult to completely control. And the fourth bias what we can encounter is detection bias. Okay, detection bias is bias in which people trying to just assess the outcome and then just give some numbers. Let's say I'm interested in measuring a weight. So the patient comes, it is 55.6. I know that this guy is going to take intervention. So I can make it into 54 or 55. This I want to measure pain. And then you can just go walk in. And these participants are on intervention arm. If you're going to measure pain, Though if they say that it is 4, I can just give a pain scale of 3. So I have a choice of fabricating the data while assessing the outcome. That becomes my detection bias. To overcome this detection bias, I should ensure that the person who is evaluating the outcome is not aware of what the patient is taking. Okay. And finally, reporting bias. Reporting bias is what yesterday we briefly discussed, where people try to write their article at the completion of their analysis. So they attempted to analyze the data, not significant. Then they went to somebody, they said, oh, come on, let's look at the data between children and adult. Then they analyze the data as subgroup, and then the children subgroup turned out to be significant. Or you divided that into age group less than 35, greater than 35. The age group less than 35 turned out to be significant. Now what will happen in your final paper? You might just highlight that the age group less than 35, we found a significant result, found in this particular study. But what was the initial objective? The initial objective to say whether the treatment helps. But at the end of the day, when you write your paper, you are just saying that less than 35 age group is getting benefit. Okay, so that kind of a reporting bias, what you initially intend to do something, but while publishing your paper, you completely change your secondary outcome to primary outcome subgroup to primary outcome. All these modifications that you try to fabricate at the end will end up with the bias. So you can see that all of these stages, what you are trying to do as a PI, you are trying to show a beneficial effect, right? To show a beneficial effect of your particular drug that you are trying to evaluate, you are knowingly or unknowingly, you are trying to introduce some sort of a bias through the process at various stages. So if you design your trial and ensure that if you don't want to introduce bias, you should plan some methodologies. So those methods, what we are going to see and check, this is one of the way that you can design your trial. But what we are trying to do in systematic review is try and read the paper and see whether is there any possibility of such biases occurred during this process. And we are not saying that because it is peer reviewed and published, we cannot go and say that it is not correctly done. This has already been done and over. What we are saying is, I have little doubt on your paper and your findings because of this reason. So now you can relate that the data that we are going to collect, it depends upon the method that people have used for collecting the data. If there is going to be a problem in the methodology, what is going to happen as a result? The results might be fabricated, or it could be overestimating the treatment effect, telling you that the intervention seems to be super fantastic. But it is not because of the effect of drug, it's because of the problems or the bias that you introduce during the process. Okay? Any questions on these 5 domains? Okay, you can tabulate it, problem and a solution. The problem is all in the block, blue color box. The solutions are in the red. Okay, let's look at what are good methods of a sequence generation. This is about selection bias. So you can see that the sequence generation approach is basically trying to ensure that the allocation of participant happens before. What are the good methods? And it tries to minimize the selection bias. These are different methods qualify for a good, low risk of bias. So if people have said we use a random number table. Okay, random number table you can obtain from any online, and then you can use the random number table or computer generated. Nowadays people use computer generated approach. Did anybody aware of any computer generation randomization? Any tool that helps you to generate a randomized code? Excel, you can use it, but it is not going to give you proper allocation. There are tools, something called sequence generator. Okay, just make a note of it. So I'll just give you a demo of what that tries to do. Mhm. Okay, this is one of the website which you can get your randomization code, random.org. So there are a couple of open online tools are available to generate the codes. This is one of the tool where you can just specify your number and then you can generate the code automatically. There are a couple of other tools are there. Maybe I will just share. I think it's the this one, sealed envelope. Sorry. This is a website which is easy to use. Okay. So you can simply just ask for a yeah, you can go to this create a list. You can see this allows you to just create a block randomization and you just have to, you can see that list is created. So there are two groups, group A and group B, and you wanted to create using a block randomization technique. Okay. So you want a block size of 4, 6, and 8. You can see the first group is 4, and the second is 6, and the third one is 8. So similarly, it goes on with various blocks up to reaching this 50 sample size, 25 in intervention and 25 in the control arm. Okay. So this is a very good open source where you can easily use and create a random sequence generator. Okay. Computer. So usually people now use most of the analysis or random generator using computer generated approach. Or if you see somebody who's using coin toss or shuffling cards or drawing lots, so these are methods which is used previously, not now. If you are doing a systematic review and including studies which are done in 1980s or 1970s, you may not find everybody is using a computer generated method. So these are other methods in which people perform their study. You could consider them as a low risk of bias. High risk of bias, what people try to do, quasi-randomized study. What is quasi-randomized study? You can predict who's getting what. Monday intervention, Tuesday control. Is it a randomized control trial? It is called as randomized control trial. But if your Monday is a treatment, Tuesday is a placebo, and your friend is going to visit on Tuesday, you wanted them to just come on Tuesday? And you might say that, come on, there is no going to be, you are going to receive placebo. It's not helpful. Please come on Monday. So there is a chance that you can predict who will receive what. That is called quasi-randomized trial. And you can easily, identify. You can say odd number, date of birth, odd number, intervention, even number, placebo. Then if you know the date of birth of a person, you can identify whether he is in placebo or he is in intervention. Okay, these are methods which are there, but it is not very robust to get a proper randomization. You can easily figure out who's going to get what, and whether after getting also you can figure out what treatment that they are actually on. So therefore, this method, date of birth, date of visit, record number, alternative days, these are not qualified for a good randomization procedure. It will score less and qualify for a high risk of bias. Okay. Sometimes people do non-randomized study, and non-randomized study has its own biases to begin with assumptions and theoretical thing. Sometimes you may not actually able to perform a randomized control trial if you work with people with special care and all of that. So therefore, you try to perform non-randomized studies. And there are empirical evidence which suggests, you can see that people just evaluated all non-randomized studies, and then what they found compared against the randomized control trial is all non-randomization studies are overestimating the treatment effect. So if you just pool the data with the randomized control trial, if your effect size is going to be, say, 20% reduction in mortality, okay, if you use all non-randomized studies, you will find 40% reduction in mortality, which means that always non-randomized studies, there is some biases to confound that there is a possibility of overestimating of the treatment effect. Okay, that is what people have able to identify through empirical research. And the second step, now that you have this code, I have showed you the code, right? Sealed envelope where you have the number. So what people try to do, they'll give you, if you go to a statistician or any programmer, they're going to give you this list. What do you do with the list? Just keep it as it is, and then see, oh, the first patient comes in, you have the list opened on your table, and then checking, oh, this is a placebo, drug B. So it looks like he's very old. Should I really give him an intervention? Maybe I will shift one line there and then give him a placebo, and a healthy people I'll try to give up intervention. There is a possibility that even though I have created a random list, it is on my table, there is a possibility of I am modifying the way that I should give this random list to them. Okay, therefore the second step comes into picture, which is called allocation concealment. Okay, what allocation concealment is trying to do? It is trying to ensure that I do not know what I am going to give. The patient will not know what he is going to take. There is an in-between process. Maybe most of the time we get confused with blinding. It is not blinding. In between this process of I am not knowing and the patient is not knowing what it is, it happens before taking the drug and after starting the drug. That is the point in which you can divide it into two categories. Before starting the drug, it's called as allocation concealment. Okay, after it becomes blinding. So you can see that what it tries to do is, again, we're talking about the selection bias here. We are trying to reduce the selection bias by ensuring that nobody is aware of. What are the good techniques people use in terms of allocation? You can see that people use these various techniques for allocation concealment, starting from central allocation or central or web-based allocation. So mostly if you see that people conduct a multicentric trial, so what they try to do, they cannot go and just do allocation for each site. They will have a centralized system where you take a phone and then just say that I have recruited one subject for this. Can you tell me the assignment code? The computer will assign the code and you have to supposed to provide that particular procedure or the drug. So that is called a centralized allocation system, which is usually performed in a multi-centric trial. And what people can do in academic, RCTs, sequentially numbered identical drug containers or serially numbered sealed opaque envelopes. Sealed opaque envelope is what people commonly use. What they do, they take up this list that I have got from there and then take one first patient. Okay, I will write it and cut it into a paper, put it into a cover, keep it inside. And I'll mark it as 1. So like that, I will have 50 covers on my table. I do not know what is present. The statistician who's generated the code, he will arrange this 50 covers for me and I will keep this 50 covers on the table. Okay. So I will just go with the serial number. I cannot randomly pick. You can say, I've done all of this. I randomly choose lottery select. No, that doesn't work in this process. So you should go serially numbered. When you get first patient, first number, second patient, second number. So you can see that, let's say, for example, you have done a sample size of 50, but you have just stopped recruiting subjects after 20th because you went and reported back to your monitoring committee that I assigned a lot of adverse reaction with this drug, and the committee suggests that you cannot complete your study. You have to put a stop, early stop of your study. Can we just go and publish this work? Let's say your sample size is 50, but you recruited only 20 subjects. Are you going to be sure that 10 of them will receive intervention, 10 of them will receive control? No. When you think that there will be an equal number? You want 25 in intervention, 25 in control, and total sample size 50. Right? You started recruiting your subject. I have given you 50 covers. You started recruiting it. 20 subjects, you are seeing a lot of side effects, and you wanted to go and report back to the data committee. The committee says you cannot continue your study. Now, what will be your allocation? Will you get equal number 10 in intervention, 10 in control? May not. Okay. When do you think it is going to be equal? Only if you reach 50, you will be sure that 25 actually got intervention, 25 actually got control. That is where the technique of block randomization comes. You can see over here in this list. If you know these kind of problem going to occur, you have to tell your statistician that I am going to do a block randomization. What you see in the first block, 4. Once you reach 4 subject, what is going to happen? You're going to have 2 of them in intervention and 2 of them in group A. When you reach 10 subject, what is going to happen? 5 in A, 5 in B. When you reach 18, what's going to happen? So you can see this kind of techniques helps you to ensure that once you cross that block, you are actually having an equal participant in both the groups. Okay. If you don't use this block randomization and just run a random thing, then what is happening is only if you have 25 people, probably after 20, you will have 5 of them actually got intervention, 5 of them actually reported adverse event. So you can't even publish that work. So you have to be careful when you try to generate these codes and trying to ensure that you follow appropriate method. Depends on whether you are testing a new drug or you're testing a well-established drug. And the high risk of bias happens when the patient know what they are taking, or if somebody knows, even if it is a envelope, people can see through and identify what is the code present inside. So you have to ensure that you fold it so nobody aware of what is there in the cover. Okay, that is the level that you should ensure the concealment. This is a very important slide which clearly tells you that what is allocation concealment and blinding, because most of the time these two information got mixed up. Because the patient do not know, I do not know, it is concealing, which means it's also blinding. That is how people think. Concealment, what we are trying to say is patient not even been started taking the drug. Concealment ensures that he has been assigned to the treatment or control. He's not even taking any drug. You are going to this place. That's all I've just said. That is the allocation concealment. And what happens after that is a blinding, which happens as a performance bias. Okay, these are two different things. Don't get mixed up with these things. Okay. And very important. Let's say, for example, that you are trying to do a surgical trial. Okay, you want to do a surgical trial. What is possible between these two? Or we can do both. We can do both. I'm talking about performance bias. Performance bias includes the surgeon as well. Multiple person also. They know what they are supposed to do, right? He will be doing. He will be knowing what he's supposed to do, right? He will. Okay, surgical trials. It is unlikely that you can blind the person who's actually going to operate. Maybe you are talking about the outcome assessor bias. That is also blinding is important. Maybe you can do a similar, dressing and all of that, so that the patient doesn't know what procedure has been done. You can blind the patient, not the surgeon or the PA who's doing it. But you can still perform allocation concealment. Selection bias you can avoid. Okay. Certain instance, then you cannot go and say, oh, you did not perform this, therefore you have high risk of bias. No, the intervention demands them, you cannot do it. So therefore you can say it is low risk of bias. So it depends upon the situation. You have to look up what is applicable and then make your decision there. Okay. If you have the facilities, then it's good. If you, yes, it's very expensive to manage your human resource and all of the system. Generally, it is been done in a multicentric trial. Okay, if you can do it in a web base, then it's fine. You don't have to actually, have a phone call and all of that. You enter the subject ID into a platform, and the platform assigns automatically the code. There is no choice that you can change it or modify it. Okay. So remember, allocation concealment is always, or a selection bias could be always possible to avoid if you try to ensure a proper method, even including surgical trial. Only during the performance where you have to see whether it is possible or not applicable. Okay, blinding is an option for surgical trials. Okay. So remember, allocation concealment is always possible. This talks about selection bias, and the second one talks about the performance bias. Okay. Then we talk about the detection bias. Again, the blinding goes to makes going to help you in terms of in surgical trial outcome assessor detection bias you can avoid. Even you have a laparoscopic or incision based surgery, you can do a similar sort of dressing so that patient doesn't know what procedure has been done, and the person who's going to come and evaluate will not know what procedure has been performed. So next is the performance bias. We talked about the problems there. And the major important thing here in the performance bias is people often use some terms called double blind, triple blind. In all these terminologies, we did a double blind clinical trial. What is the meaning of double blind? Patient and investigator or statistician, okay, or outcome assessor or caregiver. There are a lot of people involved in a trial, right? So you cannot make an assumption of double blinds means patient and the investigator. So therefore, what consort tells you is don't use these terminologies like double blind, triple blind, and all of that. You describe who are blinded in the study. The patient, investigator, and the caregiver is unaware of the treatment allocation. If we write an article now, consort, according to consort, you should write it. You cannot call this double blind, triple blind studies. Okay, because it goes with an assumption. Okay, so remember, when you just try to use this, you have to ensure that the blinding happens. And sometimes if it does not happens, then you just have to explicitly state that the PI is aware of what procedure has been done, and he is not involved in evaluating the outcome. Though I am a PI who was allocated the treatment, but I did not intervene on measuring the outcome. The person who has been doing his routine job is actually assess the outcome for this study. Therefore, he has not been biased, looking at intervention and control and all of that. He is not aware of any of the allocation. So you just write it clearly so that people, evaluate it properly. And detection bias, again, we are talking about the blinding as a tool to ensure that the outcomes are measured fairly without any, favor to one particular treatment or the procedure. And here, as I just mentioned, including surgical trial, you can try to blind. So here, when we talk about this detection bias, we are talking about two different types of outcome. One is an objective outcome and the subjective outcome. Okay, what is this subjective outcome? Subjective outcome are patient reported. Okay. Anything else? What is objective outcome? Even weight gain or weight loss, even if you measure, I can change it. Even it is 35.5, I can have an option of fabricating it. So objective outcomes are, you cannot modify it, even if you measure it, like death. You cannot change that. So you have to see that objective outcomes, detection bias is really not important to evaluate. Whereas a subjective outcome, it is very important, like pain, not only patient reported, even if you measure it, and then if there is a possibility of changing it, there is a potential source of bias can occur. So subjective and objective outcome, you have to think whether it is subjective or objective. Objectives are, you cannot modify or change the outcome after knowing it. So weight measurement, can you make it an objective or subjective? I gave you a clue. You can assess in both the ways. How do you do it? No. I'm not getting there. I'm just collecting. I'm talking about the data collection itself. Maybe you can look up for a two-person looking at the way, thing and then cross-checking that whether it is done properly. That is a objective way of measuring it. Even though it is measured subjectively, it can convert into an objective. Or you can ask them, go take a printout. Nobody is there. You weigh on the machine, get a printout and come. It is an objective way of measuring it because nobody is involved in measuring it. The computer decides what is the weight. It can be subjective. If somebody is going to note down the weight and then write down, it becomes a subjective outcome. Okay. So you have to read while reading the paper. Did the paper give you an adequate information to make the decision? Okay. So those are the things. So we remember that you are not going to do a study. You are going to read a study to check what all ways that people would have introduced bias. Okay. That is very, very important. And pain, depression. So at the end of the day, you are trying to minimize the bias. That's all we are trying to do. Okay, The effects of blinding on outcome: inadequate blinding leads to both performance as well as a detection bias. And it's also important that what type of control group that you are trying to use. And you can see a couple of empirical evidence which is suggesting that the blinding component alone, if you try to use, there is a possibility of overestimating the treatment effect, because the way that people are reported or measured the outcome is not done correctly. Therefore, there is a possibility that there is a high level of beneficial effect that we can find. So next is an attrition bias. So as I just mentioned, attrition bias is dropout, loss to follow. And what we are trying to do is, when we try to start your study, you might know that what is the likelihood of people not returning back to your clinic after you start a treatment. So you have to account them. Generally, people try to account around 10% of dropout rate, or max go 15% in a study. Okay, so that is done when you do a study, you can sure about it. But we are not conducting a study. We are trying to see the studies which are published are good. So therefore, what we try to do here is we are trying to check whether there is a what percentage of dropout is present in the reported paper. If you see that the reported paper is more than 20% dropout, there is a possibility of the study power goes down. When you can see that when you go to a statistician, he is going to help you with a sample size calculation, and you can note that sample size powered for 80% or 90%, we arrived at this calculated size. So that 80% was set for 100 people, but at the end of the study you only have 70 people available in your study. What will happen? Will the power remain still 80? No, it might come down to 70 or 75. Therefore, the results cannot be really giving you a proper findings. Okay, that becomes a problem due to the loss to follow up. Okay, the second problem is unequal dropout. One group, all 40 people are there. Another group, only 25 people are available. All 40, you have randomized, totally 80 subject. One group, 35 people were there. Another group, 25 people only there. Is it not a equal dropout? There is an unequal dropout. Therefore, the results can change because of data. Okay, that is another problem can encounter in the attrition bias. And this is very important. Sometimes people try to perform their analysis using intention to treat and per protocol analysis. Usually, when you see all the clinical trials, people try to just run a per protocol analysis or complete case analysis to see how many people were available at the end of the study and then determine the benefit. But there is a sensitivity analysis people run. In the example of 40 and 40, 35 is present, 25 is present at the end of the study. The question is, what happened to this 5 individual and 15 individuals in the other group? So that is the intention treat analysis. So you intend to treat all this 15 subject who was missing and 5 subject was missing in the intervention arm, keeping all the 40 equally, and then checking your result. If the results remains the same, then the dropout people are not influencing your conclusion. Okay, it is an assumption based computation which is going to help to determine the results are valid or not. So that is how people try to check whether this is an attrition actually makes a difference in your results or not. That is one way of checking. Incomplete outcome data in a systematic review, you can see that the data not available for all participants, and sometimes depends upon what type of outcome that they are measuring, whether it is a dichotomous outcome or continuous data. This can have an impact. And yeah, this is another problem. whether it is because of benefit, worst case scenario, or good case scenario. The people would have got benefit, therefore they did just not participated in the study, not coming back, or they had serious adverse event, therefore they did not come back to your study or not. So those becomes very challenging to determine. So you have to be very, very careful in terms of evaluating the attrition bias. Like I just mentioned, intention to treat is one of the approach, and trying to check whether the dropout actually makes a difference to your final conclusion. Yeah, there are various methods available, worst case, best case scenario, to trying to see what happens to these individual, and you can also run some imputations method without statistical procedures. Okay, yeah, this is what I just mentioned. More than 20% will reduce the power, therefore there is a slight problem in the studies. Okay, these are the good method. Probably you just have to just make a note of this slide. So no missing data, it is good. All the 40 people you have randomized in both the groups, 40, 40, 80, everybody is present, no problem. And the reasons for missing not related to the outcomes, then it is good. Missing data balanced across the group, similar reasons, it's okay. Number of participants missing, a possible effect size not enough to change the observed effect with the intention to treat, then it's fine. Otherwise, all the other problems that you see, if not there, then it treated as a high risk of bias. So generally, you have to do some investigation on this attrition bias to come to a conclusion whether there is high risk of low risk of bias. Okay. And this is finally on selective reporting. As we all know, only positive results likely to have a better position in a journal article. If you have a negative study, it is very difficult to sell it, and it might be very challenging for us to find a place to tell it, unless it is a true result. If it is against all the published data, it is very difficult for us to go and publish this negative study. There are multiple reasons for a negative study. Either it could be a very small sample size, you have not done adequate recruitment of calculation, therefore you are not able to demonstrate an effect. Okay, or sometimes what people try to do is choose an outcome which is not at all appropriate. Then they will try to sell that article. So there are multiple problems on selective reporting, especially when it comes to a systematic review. What we are trying to see is, we are trying to see whether the data that has been presented is shifting from what you are actually planned to do. So how do we do it? You can go and look up for a clinical trial registration document, which is your protocol. When you start designing your study, these are the things that I'm going to measure, and then you publicly register your trial in a public domain. Do you know aware of where we should publish in India? CTRA. Okay, if you are in US, clinicaltrial.gov, and there is a WHO portal. For each country there are different registration methodologies there, and this has to be done prospectively. That is more important. You cannot do a retrospective registration before you recruit a single subject, but it will take 1 week or 1 month or 2 months, depends upon how they function. So you should be prepared for registering well in advance. And not reporting some outcomes, reporting outcomes which they think it is beneficial. These are scenarios where a selective reporting can happen. Okay, what is low risk of bias? Study appears to be free from other source of risk, and you can see that there are a lot of other problems can happen in a study, starting from early stopping, or it depends upon extreme baseline imbalances which can lead to biases, or possible fabrication data, or conflict of interest could also play a major role in terms of having a favorable result. Okay, these are other biases which you can add on to check how good is the quality, internal validity of a study. And as I just mentioned, there is consort checklist, which is going to help you to plan your study properly well in advance. Therefore, whatever information, what we are talking about, bias, if you read this, all these element is already available. If you plan to execute your study properly based on consort, you can, report all the information adequately for a reader to evaluate your study, and then your study might be free from all this risk of bias. Okay, right. Let's look through some, examples. So there is a three different, response that you have to give: low, unclear, and high risk of bias. High indicates red, which is not a good. Low indicates green, which is really nice. Unclear means yellow. That is where you find this traffic light figure which says red, green, and yellow. And this is how you will find information in from the paper. The study was randomized. What will be your decision? Unclear? Okay, anybody has got any other? Okay, with this given information, you will mark that as unclear, but you might want to reach out to the person who's conducted the study. Can you elaborate on? Don't give them whether you are done and computer generated or block generated. He will say computer. Without knowing, if you give him a choice like that, he will just select one. That's why you don't ask a question about whether you use computer on. Can you elaborate on your randomization method? Keep it open for him to just explain it to you. Then you make your decision based upon what he has written in your email. Okay. Second one, study was randomized in block of 8. Unclear? Is there anybody want to take any other option? Probably with this unclear, but you can also go and just look up for an other publication of these individuals. If somebody says block randomization, all of this, probably they would have done multiple studies or they know what they are writing. So probably I would go and investigate the other publication of this group and see whether they used a similar sort of a clear explain method or not. Okay, it's easy to say unclear for all of this. That is not the way that you evaluate and make a decision. So you have become a detective for this article. You have to find ways of finding what is the truth there. Okay, I would go back and look up more information and then make a decision. It will likely to fall on the low risk of bias because they know that block kind of size 8 and these specification gives you some clue about what they are thinking. Okay, next, what is your decision? Low? Again, they did not tell you what is the method of randomization, whether it is sequential number or a random number, nothing. That gives you some clue, but they did not explain you the method to qualify for a low risk of bias. You still don't know that whether it is in computer or random number table, what is allocation. They're just giving some, because they're not being reported properly. These are not giving adequate information. Just investigating would be a better idea before jumping on to low risk of bias. Next. This is low means good. Probably here they said computer generated random sequence, and then you do not know really allocation is being done or not. Maybe you can qualify to be a low, but you still want to know what did they do with the computer generated number. Now you can see all consort people write it report correctly. You read old papers, you will find a lot of these problems. See, those times nobody is aware of all this method. Consort is only 2000 somewhere consort has come. Before paper, if you read it, then you will all find like this. They would have done it, but they are not reported clearly. So last one. Yeah, it is a quasi-randomized study which is on date of birth. Okay, next. Low. Okay. Next. No, they are admitting unable to, do it. It's a surgical trial. No, we don't know. Not the complete context. I'm just giving you some. Okay, you can have a both option, but investigating is better. What is the role of research assistant there, and what their role, and then try to make a decision. Okay, the study was double blind. Yeah, likely to be low because double blind is a word people would have used before. You have to investigate that again. The patient are not aware of treatment group. Single blinded. We don't know exactly whether it is PI should actually need to blind or all of that. So these are the ways people will report. If you read above before 2000 studies, you will find some information but not clear information. So you have to make some decision there. Placebo was identical in appearance. Participants were blinded to the intervention and the placebo. Low risk of bias because they attempt to try and ensure that the placebo is matching, the colors are matching, they know what they have done. But you need adequate information, but this is likely to be low. This one? What do you think? Low or high? This is very important that objective outcome or subjective outcome comes into picture. Mortality is objective or subjective? Objective. If you blind, will you stop people dying? It's not going to happen, right? So it does not really matter whether it is blinding happened or not. No, it could be any out. I'm interested in mortality. It's not about studies' primary interest. Study can make mortality as a secondary outcome. That is not the problem. For this outcome of my interest, mortality, whether there is blinding or not. So it's not really important for me. I will mark that as a low risk of bias. Okay, next. This is not only for mortality, this is for other outcomes. High risk of bias. Next. High or low? Low, okay. Next. Now you would have told that you will receive either this or that procedure. You will not reveal that this is what I'm going to do for you. Only the surgeon know what procedure that too after in the theater they'll open and see what procedure needs to be done. So okay, it's likely to be unclear at this stage. You can just shift after discussion and blinding not reported. Unclear. You don't have any evidence to support high. So remember that it's always not just making a decision judgment. You have to support your judgment based upon why do you think. And remember again, two people independently needs to do this. Even if you say I, the next person will come and say no, it is low. Then you have a discussion to come to a conclusion. So always that there are two people performing this to ensure that there is a check everywhere. Okay. So now I'll just stop here. You will take a break now or what time? 3 will come at 11 o'clock. Okay, fine. Sure. Now, yes, please.
How to calculate the low
I'm coming there, and just we have time. I'm just checking the time. We will do it. Open up your Revman that you all are practicing yesterday. I hope you all saved that Revman file. You will include it. It will be included, but you will handle it at the later stage. So I will tell you what happens with this study. You will evaluate it for grading. The grade will come into picture, and then you combine this quality and the data, and then decide whether you wanted to believe that result is giving you appropriate answer or not, or you downgraded that and tell that this result is a low quality evidence. I don't have certainty on this evidence. Though the data is good, the studies are done not properly, all biased. Therefore, my certainty that I have with this data is very, very low. So you handle that in the later stage. The quality of evidence will be very, very uncertain. The uncertain indicates that you can likely to do another study, good quality study. So if you have all the good quality studies already in place, then you have more confidence to make your decision. So that is called evidence to decision making framework. As a systematic review, you will not go into that framework. As a systematic review, you will just stop on creating SOF table. You create the table, this is what we found. You keep it. Then the guidelines panel comes and looks at the systematic review, and then they rate the evidence. And then they say that you call it as a good study, good result, but we call that as a very uncertain result. Therefore, we are not going to go. We will make a decision on other approaches like Delphi or vote counting and all of that. So there are two different stages of using this. One is that creating a review. Another one is using review for decision making. So this is not your mistake. They have done that. You are evaluated and given it. That's all. You are summarizing the information that is there. So you stop there by summarizing it in a systematic way. Any other questions? This is a journey. You start with review and all the way go up to policy making. And in the process, people look at a lot of evidence. When you talk about the policy making, it is not going to stop only at looking at effectiveness or efficacy of intervention. To determine the intervention is beneficial, you have to know what is the economic evaluation, cost involved in it, whether it is availability, feasibility, and all of the other parameters to make your decision, which includes other sort of evidence into picture. People call that as a health technology assessment, where people try to evaluate for its pricing. HTA. Anybody from pharmacology? Okay. So people use these kind of approaches on industries, and UK NICE guidelines actually uses HTA approach. Even including India, they are just establishing a center for health technology assessment. Government of India is just establishing that. Now any procurement of drug will have to pass through this HTA process. Okay, let's get back to this RevMan, and let's do this risk of bias creation. Now I'm going to demonstrate that same thing here. Okay, now are you open your RevMan? Okay, the first thing is to perform this risk of bias evaluation, you have to have a full text article, number one, because those are included studies. We are extracting data, right? So you already have the full text article. You would have read already. Now go to studies, references to studies, included study, right click and add study. Can you do that? Studies and references, reference to studies, included studies. And right click, you will find the add study button. Now you just give a name. I'm just adding finish. And again, add one more study ID. And then say finish. Any name, just random name. Finish, finish. Yeah, I'm just went to this place and then right click, add study, and then type any name and then say finish. So based upon the author, let's say you have written an article and then the first author name and the year of publication can be added, or author name et al. Whatever format that you want, you can just type that. Yeah, you can just change. You can just go right click and edit. You can do all of that. Done? Okay, if you're done, then you have to go to this tables. Click on tables. So what this allows you to do is, this allows you to just capture this characteristics of this study. So now you have a data collection format according to Cochrane, asking you to tell what is the method of this study. So you can take up any randomized control trial and read it and then say, this is a parallel arm randomized control trial or cluster randomized trial or equivalence trial. So after reading, you can fill this information. You can type something wrong now. The tables option here, when you click here, it will just appear. So participant, inclusion criteria, exclusion criteria. Yeah. Yeah, click on this. Yes. Interventions, you just have to talk about what the intervention dosage, what is the mode of delivery, what is the time, duration. Whatever is there in the data collection form, you can bring it here actually. Okay, and then outcomes, primary, secondary, and the notes. So you can just collect whatever data that you want to show. Okay. For each included studies that you have, you can see that we have to fill this risk of bias assessment table. Like we have just seen the example with the text. So we are saying low, high, like that. You can see this option, low, unclear, and high risk of bias. Okay. So after reading the paper, you have to make a decision whether there is a sequence generation done properly or not. If it is a computer generated, you might say low risk of bias. Okay. Allocation concealment, sealed opaque envelope, low risk of bias. Blinding, personal, participant, low. Outcome assessor blinded, no loss to follow up. Everything that they stated in the trial registration document is presented in the publication. And it is an academic funded, low risk of bias. Okay. And similarly, for the second study, you can mark some domain with high risk. If it is unclear, you have to type some information, only then it will appear. Because by default, it will assume that you have not done your evaluation. Okay. Yeah, you just scroll down, you will find the second study. If you add the second ID, for each ID that you create, there is a table created. If you have 10 study, yes. If you have 10 study included, 10 tables that you have to, 10 ID you have to create, 10 tables will populate. Which one, sir? Nothing, just do it. I'm adding one. Suresh 2012. I'm adding it here. Done. You can see that there's a table created. You just fill the table. Can you all do that? Those are not two people. This is a final product. So you do the two people in the data extraction process form. Two people on a document, not here. Or you have a two dummy like this, do it separately and then compare it and make it into one. Not two people again. The web version also, Covidence has two people. If you go with Cochrane, Covidence has the two format of extraction. Yesterday I showed you, right? One reviewer, second reviewer. There are specific tools are there for extracting data and doing all of this, but it comes with the cost. Just see whether you are able to do this. I'm coming. complete this exercise. So after you fill all of this decision that you have just made, you go to figures, right click, add figures, risk of bias summary. Next, finish. So you get this traffic light figure you can see on all publications, right? So right click, figures, add figures, risk of bias. Next and finish. So you should get this figures created, okay? Green is good, red is a problem, yellow is a unclear. Figures, right click, add figures, and then risk of bias. Select graph and summary, you can choose both. And finish. This is summary, this is graph, this is summary. Just generate it and see, then you can feel. This is for each article, this is for the domain. So for this article, you can see everything is good, high quality. This is selection bias is present. I don't know all of this. And this one is all biased. This one is okay. It's randomly selected. It should not have like this scenario. You don't have to be, it will be a little bit unclear. Yeah, yeah. If you agree on unclear, unclear is unclear only. Just go to figures, right click, add figure, risk of bias graph. Select next, finish. It needs to pop up, automatically it will come. So you keep on adding more articles. For example, just watch here. I'm going to add another study. So you can see the table will create, and this, when you fill it, it automatically comes. Okay, let's continue with where we stopped. So risk of bias that we are trying to do is for a randomized control trial. Okay, once you perform this risk of bias assessment, you can also just copy the and paste it in a Word document. You can see, double click, you will get your copy button. So your second figure is ready for publication. First is a Prisma checklist. The second one is your risk of bias assessment. Can you just try that copy paste? Figures, copy and paste in a Word document so that it's kind of ready. Okay, were you able to copy and paste it? Same thing, ma'am. Like yesterday figures, you can see the copy button. You double click on the figures, you will find them this icon to copy and then paste it. Now go back to your protocol document that you are just using, the template. Now you can write something under risk of bias assessment. You can just type the 5 domains: selection bias, performance bias, detection bias, attrition bias, reporting bias. Remember that we are creating some document that we are writing on the protocol. Yes, no? Or saved or deleted yesterday? If you have these documents, then you can start making notes under each heading. That is what we've just learned, right? That's from Cochrane. ROB1. There is an extension of ROB1 which is called ROB2, risk of bias 2. So let me just so these are Cochrane tools. You can get the entire details about this. The risk of bias 2 is slightly longer than the risk of bias 1. I will just try to give you some idea of what this risk of bias 2 is trying to do. Now that you understood, there are 5 different domains for assessing risk of bias, right? So what are they? Selection bias, performance bias, detection bias, attrition bias, reporting bias. There are 5 domains of biases. The solutions for these bias: selection bias can be avoided by allocation, concealment, or randomization. Okay. Second, performance bias, blinding or masking. Reporting bias, okay, attrition bias, loss to follow up. Detection bias, again blinding or masking. The last bias is reporting bias, can be studied by looking at the study protocol. Okay, these are 5 major biases. So now the risk of bias tool actually tries to do evaluation for each outcome level. So what we have done in the one, it is for the study, correct? Whether the study is done properly or not. What is the internal validity of a study? Whereas the risk of bias 2 version says, what is the bias for this particular outcome? You might measure 5 outcomes in a study. So we are going even deeper down to one level, looking at each outcomes. For mortality in this study, what is the risk of bias? For pain, what is the risk of bias? For length of hospital stay, what is the risk of bias? So we are trying to ask a bias evaluation for each outcome level. Did you get it? That is the risk of bias 2 version tells you. Now you can see here, the questions are completely changed. So this tells you that this risk of bias arise from a randomization procedure. And then now the option is reflected with more uncertainty. It is not saying high, low, unclear. It is asking a response of yes, probably no, no or no information. NA stands for no information available. Okay? Was it confusing or it is, you're getting it? Okay, it is confusing for everybody when they read risk of bias 2 initially, because it is not a straightforward clue. This is present, there is no equation like that in this tool. What they are asking is, you have to reflect more uncertainty on your decision. So now you can see, was the allocation sequence random? When do you say random? You can read here. Yes. You can say yes if a random component was used in the sequence generation process, example, computer generated number. The same thing, but it is asking you to reflect your uncertainty for each outcome. And no, if no random element was used in generating the allocation sequence. Okay, so you have to make your decision on this 5 levels, not saying low, high or unclear. It is slightly difficult initially when you try to read this particular tool, but you are good to publish your article just with the risk of bias 1. But after another 2 years, people will forget 1 and they might shift to 2. Okay, so this tool is important. If you plan to submit to a journal which is a high quality journal, you might want to consider the risk of bias 2 version. Okay, how do you decide? You can go to the journal in which you want to publish and then read whether they have used this risk of bias 2 version or not. There is no many reviews which uses this apart from Cochrane review. Of course, Cochrane review, you have to use this. But other reviews, it is not mandatory that you should always stick to this tool. You can have an option of choosing ROB1 as well. Okay? Yes, no? How many of you are able to see ROB2 in any of your review that you read? Probably less, because it is just now 2 years old and people are just now adapting to this tool and finding it difficult to actually do this, because this requires a lot of reflection on your readings to answer all of this question. So you can see here the first question, was the allocation sequence random? Yes, we all know computer means yes. Was the allocation concealment until participants were enrolled and assigned to the intervention? This is basically a allocation concealment question, goes deeper into the allocation process. Did the baseline difference between intervention groups suggest a problem with the randomization procedure? We all see that in the before, right? But they are asking explicitly here. Then you make a decision at the end with answering all the question. This is a rule for this particular decision, whether it is low, some concern or high, based upon these set of questions. Fortunately, you don't have to do all of this because there's an Excel file which you can use for creating this. If you wanted to try this out, go to this Google, ask for risk of bias 2, and then download this Excel file. Can you do this? Don't worry about this macros problem. So you can see that this comes with the macros. Okay. And I'll click on this first form. Just have to, one second. Here from this, say Excel tool implement. Just search for risk of bias 2. Just Google search for risk of bias 2. You should get that. Yes. Generally, people use ROB1, but if a journal, high quality journal, if they adapted to this version, then you must, use this. Yeah, I'm just 1 second. Okay, I think you have to have some security. Let me just do this directly on the Shiny app. Okay, you can go here. RobVis. Okay, this is for the risk of bias 2 version. RobVis is a tool. And you can see there is an example data set that is available here. You can just enter this data directly here. So this is a study D1. These are domains. Domain 1, domain 2, domain 3, domain 4, domain 5, and overall, and the weight. Okay, let me just yeah, basically these are the same thing. Selection bias. Domain 1 is randomization procedure. Domain 2 is intervention, deviation from intervention. Domain 3 is, this is domain 2 again, missing data. Domain 4 is outcome assessor, which is an reporting bias. Domain 5 is reporting result. So basically the same thing which has been split into detailed signaling questions. So I'll just give you no, there is a format in which you can just upload a file. Let me just, you can see here data set, right? You download this data set and you open this and fill this data set here. Then upload it. It's very simple. This is all it is. So type the study name and then just put this. Ramesh, Ram. I'm just adding some. Okay, I'm just added this data. So once you do this evaluation, you have to create this data file and then go to this upload data and then just upload this one. Done. Now you generate plots. You will get your plots done. It's the same plot, but you can just get it for risk of bias too. Did you get that? No? Okay. Now what you should do, is everybody able to reach this place? Yes? Can you download this example data ROB2 data set? Yeah. Just search for this ROB2 WIS, Rob WIS. Just Google for Rob WIS. You just get this shiny.app.io. Click on this, you will able to reach this place. And then go here and download this data set. There is a rule actually, it is not probably low. Yeah, you could say probably low as well. But it will just fall into one category at the end. You can see this tool. When you define each of this outcome, you will say probably low. But at the end, there is only three choices. Either it is low, some concern, or high risk. For that define, yeah. For that particular domain, either these options are the final options, or no information. You just add these names, random names. You can keep it study one, whatever you want. You can add random names as well. And then go back here to this site. You have to generate. Click here, upload the data, and then you can see generate plot. You can choose Cochrane color you want. And then download the plot. And then save it for your publication. Can you try and do that? Yes, ma'am. I'm selecting the risk of bias 2 and then uploading the data that we downloaded. And then click generate plot below. Yeah, we'll upload that same file. And then generate figures. This will produce this plot. This will go as a publication. You can save this as a image and then you can save this, download this as JPEG or any format and then save that. For publication. So it will take time, but it will download as a figure. Now you can save this in a Word document. So you can go here, insert, picture. This is done. But I just put a insert picture and then select the downloaded. Done. So this is for risk of bias 2. If at all you wanted to use ROB2, then you should use this visualization to. Nobody will ask you what did your decision, how did you arrive at it, but you have to just generate this figure using the. That is version 1. This is version 2. This is version 2. No. Depends on which journal that you plan to submit, and yes. So how do you decide which one to choose? You go to the journal and see what they are publishing. If they are accepting 2, then you probably stick to the 2 version. They will not tell 1 or 2. They'll only say risk of bias need to be evaluated. It's your choice of choosing 1 or 2. And the practical approach is go to the journal website and see whether they are publishing 2. If they don't publish 2, it's good. You can use 1 and publish your paper. Okay, done? Shall we move on? Or need 2 minutes, 3 minutes time? Okay. So now that you have completed the risk of bias, the second or third or the final data extraction is the meta-analysis. Okay. So we got around 2 hours to spend on meta-analysis. If you are okay with this, then we move on to meta-analysis. Okay. Right. So yesterday we briefly learned about what type of data that we should extract. Yesterday we know dichotomous data. There are various types of data that are available, and then we are trying to extract data from each study for our meta-analysis. So we will do this practically today, not go into the details of again data. So I wanted you to just go to RevMan. Go to RevMan. Okay. Everybody is in RevMan. Just ensure that if you conduct a meta-analysis, you need minimum 2 studies to combine the data. Otherwise, it is not a meta-analysis. So we all have more than 2 studies or at least 2 studies available, right? We had at least 2 studies to generate the figures. Now, we are going to stick to an example of iron supplementation versus placebo. That is what we have learned yesterday, iron supplementation versus placebo. What is the outcome? Hemoglobin level. So is hemoglobin level is a continuous data or dichotomous data? Continuous data. It is a measurement, right? And how will you summarize that data? How people will report it in a paper? Mean and standard deviation. What is the average hemoglobin count in the intervention arm and the control arm? So technically in papers, you should extract the mean and standard deviation and the number of people who are randomized in the arm. Let's see how we can meta-analyze that particular comparison and the outcome. Let's go here to data analysis. Go to data analysis. Okay. Right click. Right click. You're getting add comparison. Click on add comparison. What is our comparison here in this example? Iron supplementation versus placebo. Can you type that? Done. If you have finished typing the comparison name, sometimes you might have iron supplementation versus another form of iron supplementation. Then you should have another comparison. Or iron supplementation versus, alternative option. That could be another comparison. So in this example, we are only comparing iron supplementation versus placebo. And then say finish. So you should get some table created like this. Yes? All right. Now, if you open this data and analysis, you can see your comparison which is created. Iron supplementation versus placebo. Can you click on that? Did you find that? Just double click on data analysis. You should be able to find. Now select this comparison and then right click. What we are trying to do is we are trying to add outcome, which is hemoglobin level, right? Click on outcome. Now the outcome is hemoglobin level, which is continuous data. Can you select continuous? And then say next. Type hemoglobin level. Change the experimental to iron supplementation. The control group to placebo. Can you do that? Done? So once you finish typing information, then you can click on finish, not next. You should get up in this view. Did you get this view? All right. Now we have just completed 2 tasks. What is the first task? Set up your comparison. What is the comparison here? Iron supplementation versus placebo. Step number 2. What did we do? Add outcome. What is the outcome here? Hemoglobin level. Then in between we did something. What did we do? Whether it is continuous or dichotomous, we have to decide what type of data it is. Then you will land up in this page. The third step is add studies. Fourth step is add data. There are only 4 steps to complete your meta-analysis. Okay. Now, third step is add studies. You can see a button over here. Click on this and you will find the included study list. Were you able to find? Select a study which contributes data, and then say finish. This button, add study, click that, select the study of interest, and then say finish. So you need to have at least minimum 2 studies to be added. Only then you can combine the data together. So we're coming. First we add studies and then add data. So finished? Everybody has got these 2 studies added? Okay, now I'm going to give you some random examples. Then you can add this. Assume that the first study, there are 100 people randomized in the iron supplementation group, placebo 100 people randomized. The average hemoglobin level is 14.5 with 2.4. With the placebo group, it is 10.1, 2.3. Can you enter this data? Okay, just enter these 2 data. Done? So these data are being extracted from each article. So I'm just giving you directly this data. So here you should read the article and extract this information from the paper. So what is the first data tells you? Don't look at anything, just look at the number. What the number tells you? The average hemoglobin level in the iron supplementation group is 14.5 unit. Whereas in the control group, placebo group, what is the average hemoglobin level? 10.1 unit, which means which one is better? Iron supplementation is better compared to placebo. Second study, 15.2 and 9.3. Which one is better? Iron supplementation is better. Okay, both the studies are saying iron supplementation is good, working. So we are trying to synthesize this 2 information into a single value. Okay, that is where meta-analysis is going to play a role. You can see here, you can change the scales of, if you're not able to see your plot clearly, you can just make little bigger, smaller like this. Once you see proper figure, then you can click on this forest plot icon to see the result. Okay, done? Click on the forest plot icon, you should see the results. Now, you are trying to quantify this information. So what you see on the first study is, there is a 4 unit increase in hemoglobin level, which is 4.4. Right? In the second study, there is a 5.9 unit increase in the hemoglobin level with the help of iron supplementation. When you combine these 2 data together, what is the overall result tells you? There is 4.59 unit increase in the hemoglobin level if you are going to give a iron supplementation compared to placebo. The question is, did we just take 4.4 and 5.9 average it again? No, that is not meta-analysis. The meta-analysis is a weighted average. You can notice that there is a weight assigned to each study. What is the weight for the first study? 80 percentages weight has been given. Second study, 19 percentage. The reflection of this weight is what you see in the green color box. The green color box for the first study is bigger, which means it carries more weight. And the second study, green color box is smaller. So the small and big variation actually tells you the weight associated with that particular study. Clear? Now when you take a weight determined by the number of participants and the variance in the study. So you can notice the first study, how many people? 100 and 100. Second study, 50 and 50. Now if I change the second study to 500 participants, what is going to happen? What's going to happen? It is going to take more weightage. You can see here, this becomes 70, that becomes lesser. So sample size is the important factor to believe that the results are true. Now you can see we are trying to add 150 participants. Therefore, the diamond that you are creating tells you the true result. That is the idea of meta-analysis. Not just simple average, it is a weighted average where you increase your sample size, then you get more power. The confidence that you have on the estimate will increase to make an appropriate decision. Okay. Now what does a diamond tells you? The diamond is an effect which says 4.69 to 4.11 to 5.25 is your confidence interval. Clear? Now you can see that this is not correct. So you have to go and change this here. Tell your readers that this is not correct. Favors placebo. And then change this to iron supplementation. That is why don't directly look at the labels. First look at the data to see what the data tells you. And then these labels can be changed depends upon what the data tells you. Now you can see I go to here and then go to graph and then change this. Can you do that? The properties icon and then graph. Come to the graph. This is a positive outcome, right? More the value indicates better. If it is pain, then it is okay. It depends on the outcome that you are measuring, direction of effect. Then everybody change the label. Once you have done, then you can also just click on this icon so that your risk of bias is also being plugged in along with the graph. And then save this, copy, go to a Word document. Just click the icon there, risk of bias icon. And then copy this figure, put it in a Word document. There are a lot of icons here, right? Just Just copy forest plot, go back to forest plot, copy, and then go to Word document and then paste it. Then your forest plot is ready, meta-analysis done, and you can prepare your manuscript. Based on the outcome, that's why you check the data first, what the data tells you. Whether the labels also tells you the same result or not. That's a default software option. So you have to manually change that. Did you get it? Okay, now the next outcome is length of hospital stay. Can you create this length of hospital stay? So that's the exercise for you to do. I'm not going to do it. I wanted you to just analyze the data, length of hospital stay. Okay, I'm going to give you the data. This is the outcome of interest. Like we did hemoglobin level. Next outcome is study 1. Okay, it's your exercise now. Okay, what was the findings? Everybody able to get the forest plot? Or need some time? Got it? Okay, the challenge here is it's not generating forest plot. The major challenge is getting the right data from paper. Okay, so you might spend a lot of time on extracting the data from paper. Once you extract the paper, it is like 5 minutes job, right? You can see you created a forest plot in 5 minutes. Okay, the other challenges that we might encounter in meta-analysis, let's talk about that. The first problem is you can see that there are a lot of other icons here. Okay, this icon talks about whether you are analyzing the data using a right effect measure. So what is this MD stands for is mean difference. What is mean difference? It is basically subtraction. 14.5 minus 10.5. What is the value? 4.4. That is what you get here. Okay. So 15.2 minus 9.3. 5.9. So that is a mean difference. That's all it is. Yesterday in the talk, Rekha was mentioning about the effect measure, mean difference. So this is what meta-analysis is actually using, mean difference. Okay, now you can see that the second problem is, are these studies are consistent, where you have to check your heterogeneity. Okay, is this first study says benefit favoring treatment. Second one also says it is beneficial favoring and supplementation. What if the results are going to be like this? I'm going to modify this data now just to show you. Like this. What is your heterogeneity here? Can you read from this? There is a heterogeneity tab which is available there, right? It tells you I square equal to 91%. So what does that indicates? Is the first study result is agreeing on the second study? The first study says 4-unit increase in the hemoglobin level, whereas the second study says 1-unit increase in your hemoglobin level. Which one is the truth? That is where the heterogeneity is trying to tell you that both the studies are disagreeing. We are getting 91% of heterogeneity. How can it be possible in a randomized control trial? If everybody is controlling all the factors, you should slightly get a variation, not a too much of variation. What if the results are going to be like this? What is this result? One is saying better, another one is saying not better. So can you combine this data and say that the diamond is fantastic? No, nobody will accept it, right? So you can see that heterogeneity is a very important aspect. When you try to perform your meta-analysis, you should also need to know whether what we are doing is making sense clinically. Okay? It is a statistical procedure for estimating it, but it can arise due to clinical reasons. Being, you have recruited in your inclusion criteria people with adult and children. I would have only studied adult. When I combine this together, statistically you will find a variation. You have studied outcome measurement at 5 months. I have measured outcome measurement at 1 month. Can you see an hemoglobin level increase within 1 month? It has to have some time. So because of that reason, you see a variation in the heterogeneity is 91%. So there could be multiple reasons can introduce this sort of a heterogeneous result. The diamond is trying to combine these two results and give you the pooled estimate. That is your meta-analysis. That's your pooled estimate. So in the forest plot, what you are searching is for the diamond. The diamond is your overall evidence. That is why I'm saying statistically diamond will create, but it doesn't make sense to pool the data because it is not clinically valid. You cannot do a meta-analysis. That's why I'm trying to explain you. Heterogeneity is a very important aspect. The heterogeneity is already defined from 0 to 100%. The lower the heterogeneity value, I square, it is homogeneous result. But in this, I have just changed the data. It will calculate for you. Yes, yes. By default, you will have an heterogeneity available in all of your estimate. No, it should be there. Okay. Just get the forest plot, you will be able to see that. You are accepting or not. The question is, the heterogeneity is what? Okay, let's do it this way. Okay, now you two of them are disagreeing. I am a moderator. I am just trying to come to a consensus. If I just tell you that not accepting your result, not accepting our result, I am coming at the one conclusion. Do you agree with me? Both of you will disagree, right? Because either not accepting your result, either not accepting the result. So, but I am just coming with my own result. So now this doesn't make sense because none of the results that are available in the paper is not the true result that I am telling. There is a lot of heterogeneity. Do you really want to accept these findings? You are not going to accept. Nobody is going to accept because it is not the true reflection of this data. Okay, now the idea is to what level that you can agree the diamond when there is an heterogeneity. So 0 is perfect. Everybody is accepting. Meaning now I'm going to change this data exactly closer to this value. Now what is going to happen? Because both the studies are telling the same result and I am also happy there is no heterogeneity. I don't have to debate or discuss nothing. Now, this is not going to happen always. Right? This is not going to be always because the studies are done in different places. There will be certain amount of heterogeneity. Now, instead of this result, I'm going to get a result like this. Look at this result. There is 91% of heterogeneity exists. Now the question is, how serious that you want to consider this? 91 seems to be from 0 it went to 91. Total is 100%. It's a very serious heterogeneity. But you can see that it is not against the drug. It is the same site which is favoring the drug or the iron supplementation, telling us iron supplement still works. But there is a lot of heterogeneity. Now we should go and investigate this, why this has been happening like this. You are also saying it is working. They are also saying it is working. But in that study, it gives a fantastic result. Now I go back and read your study and I found that the healthcare system in your study is really good. Therefore, you are able to demonstrate a fantastic result, 4-unit increase. Whereas this study is done in somewhere in India in a different, remote location. I was not able to demonstrate. Now I can go and tell the readers that this study is done in India, this study is done in UK. Therefore, this amount of heterogeneity can be explained. Therefore, you are accepting that 91%, knowing that this could be the potential reason. You're able to understand now? When the heterogeneity can be high, that is not your problem, that is not your mistake. But you try to explain that why the heterogeneity is arising first. If you can explain that by a subgroup analysis, what we can do, we can go and tell that this study is done in India, this study is done in UK. Therefore, I'm going to tell everybody that you will get a different result. If you do your study at different setting, the overall results are favoring the treatment. There is no doubt about it. But you cannot see the same effect everywhere. Now you can pull the data, even 91% heterogeneity is there. I can pull the data and explain it. If it is on the other side completely, you cannot pull the data and tell her whether it is actually working, because one is saying working, another one is saying not working. I cannot conclude that it is going to work. Understood now the difference of how heterogeneity plays a role? And statistically, you can adjust this by using a method called random effect model. You can see here the fixed and random effect model. If you click on random effect, what it tries to do is the heterogeneity will remain the same, but the benefit will be distributed. So if you look at the data here, it is 3.7 in a random effect. Whereas when you say fixed effect model, you are climbing 3.9. So you can see that the confidence interval here is narrow here, which is 3.3, which is basically coming from this study. It is not even considering this study. You can see it ends at 3.11. And this starts at 3.7. So it's somewhere here, it is not including this value. Now, when you just go to a random effect model, you will notice that the minimum is somewhere including from this. And also takes the highest value of this. So both the study gets a importance. Are you getting that? Okay, now these two studies are done in different place, right? Understood? Now the diamond is going to be telling you what? Yes. What is trying to tell you? It's trying to tell you that there is a minimum of 3 unit increase in your hemoglobin level with iron supplementation, and it could be 4.4 unit increase in your hemoglobin level with iron supplementation. You can see this here. This is basically this value here. Understood? Are you getting this? It will be there not to extent of 91%. Probably it will be like 50, 60, 70. Or not necessarily. Because our observational studies, of course, you start with the random effect. And randomized control trial, you expect a similar result or a closer result to the fixed effect. You always start with the fixed effect for randomized control trial. Then you switch to a random effect model. Are you able to understand this? Let me again explain, try to explain. Let's see. Now, these two studies are done in, don't look at this. Now, two studies are done in, one is in UK, one is in India. The UK study tells you that there is a 4 unit increase in hemoglobin level. The confidence interval tells us there is a minimum of 3 unit increase, maximum of 5 unit increase. Did you get that first study? Done. The study done in India, what is your benefit there? 1 unit increase in your hemoglobin level. It could be as minimum as 0.5 units to 3.14 unit. So now I am just finding there is a heterogeneity present, 91%. It is very serious because 100% is the total. We are able to see 91% of variation. Now I'm going to just adjust this using a statistical model. First, I started a fixed effect. When I pull this data using a fixed effect, what I'm trying to conclude? Now tell the data, see the data and tell me what I'm trying to conclude. I'm going to say that I'm generalizing this. I'm saying that the average increase of hemoglobin will be 3.9 unit, and it could range from 3.3 unit to 4.4 unit. Is it applicable to India? Why no? It's not even touching. It's only 3.44, which is 3.22. We are generalizing 3.3 unit, you will definitely get, which is not acceptable, right? So when you use a fixed effect model, you are not getting the correct conclusion. You are drawing the attention of readers that it is definitely beneficial. But what is truth there? The truth is this. I have to analyze the data. Now tell me what is the truth. Now I'm saying that it is not 3.3 unit you will get. You will get only 0.6 as a minimum increase, which is the reflection of our Indian data into the pooled estimate, which will be making sense for people when reading it. Otherwise, the model tries to give you a false output in your analysis. So when you have a heterogeneous I-square value more, then it's always appropriate to use a random effect model than just presenting a fixed effect. Now you get it? So, okay, now I will go back to this example. Now I'm just going to change this data. Now you see, what is this heterogeneity? 0. What is this value? 4.36, 3.78. Okay, now we are in random effect, right? Let's see fixed effect. It will not have any effect on this data because everybody is saying the same thing. There is no difference between the two of them. Either fixed or random is not going to affect your result. But when you are started saying different things, there is a statistical methods to arrive at taking your option, taking the other person option also into the pooled estimate. Okay, that is a idea here. Yes. Doesn't, when it is 0% random fixed doesn't matter actually. It's usually, when you do a randomized control trial, you assume to have a kind of a different, same similar sort of a result. So you start with fixed and then shift to a random. For observational study, you start with random. There is no fixed there. 50% there is an heterogeneity. There are cutoff, but it depends on your, clinical understanding. So use two different instruments for measuring it. One instrument is not very good, another instrument is actually good about measuring it. So you start with the random. Fixed and random, yes. That's because the calculation changes, because random assumes that, the other study is also important. But fixed study says that, the bigger studies are more important than the smaller studies. It's a statistical calculation goes behind for computing weight, and weight determines the diamond actually. It's a weighted average, right? So when the weight changes, the diamond also changes. Okay. So when you read any meta-analysis, it's always important to look for the diamond, and along with that, you should also look for this heterogeneity. What is the amount of heterogeneity present? When it is more than 90%, definitely people will not pool the data together. If they attempt to pool, then they would have given some explanation why they just actually pooled it. Then you understand that because of this different reasons, this different results are different. Yes, please. Yeah. No, that time there were, these are formulas, yes. The formulas are available here. You can just get this, all the statistical procedures available on these calculations. These are statistical formulas only. Yeah. Even p-value calculation is done in manually, right? Before all stat table and then compare the table value and this. I will come there. Are we good with forest plot? You can see here there is one more icon which you can create, which gives you a funnel plot. So what this funnel plot is trying to tell you is there a publication bias? Technically, it's very difficult to determine publication bias. Statistically, what the software trying to see is there a small studies that you have missed out with a less sample size? The logic behind that is, so you all know that only positive studies reach the publication. All negative studies not going to reach. So if there are some negative studies, did we miss those small studies or not? So that is the idea that you will see on the funnel plot. And with 2 studies, you will not able to determine anything. So minimum 10 studies should be there to at least make sense of what the funnel plot is trying to tell. And there are other procedures along with that to try and investigate the publication bias. So Cochrane not very favorable on funnel plot because they perform a good search. And if your search is done in all the databases, then you don't suspect any publication bias generally. So you say that I only searched in 2 databases, I left all the non-English language, then automatically your methodology itself gives you a clue that there is a possibility of publication bias. So you don't have to investigate through a statistical procedure. Assumption of that particular outcome. This for each outcome. Sometimes, not always. Depends on the journal. Depends on controversial topic. That it's a qualitative. You have to tell. Application doesn't do anything for you. Everything what you are doing is just supporting your work. This is not an AI tool. Yes. It's not going to see. You are wanted to see a funnel plot. You have the data here. You have the data entered here. So you are asking the computer to check for a funnel plot calculation. The data that you entered, if you change, you can see this 2 here, right? Now I'm going to change the data. Now you will see this funnel plot different because this value is here and this different mean difference is different here. So the value that you enter changes the information there. There is no as such rule of minimum. Whatever you have access, please search for it. At least PubMed is common for everybody. The smart way to do this is go and look for a similar publication which is published in a journal. If you plan to submit to a journal, go to that journal and see what they are accepting. At the end of the day, you wanted that editor to accept your paper, right? So you just look for the database that they have searched. Just at least perform your search in those database. So generally PubMed, and if you have access to Cochrane, you can do that, and Google Scholar. And in addition to that, any specific databases that you think which is relevant. Embase. Yes. If it is, it will be poor. It will be all very bad quality studies. But you can run that, if you know that these are predatory journals, you could investigate it. That could be a methodological systematic review. So you could see predatory studies versus, good quality studies. What was your finding? Then you can just go and say, oh, predatory journals, don't even include it. It doesn't make any, contribution to your overall result. It actually misleads the entire analysis. then you can just exclude it. People are smart, even they write predatory journals. They know what the results and they cook up the data fabricated to reach the same findings. It won't have a different findings completely. Okay, now we'll go back and then now you all understood, right? You know, how these software, yeah. Oh, publication bias, the concept is what we are assuming is the small studies are unlikely to reach the publication, right? So what you are going to do here is you're all showing that it is favors, favors, favors. But some meta-analysis, what you will find is there is favors, there is no difference. So, okay, I'll give you an example now just to give you that clarity. It is only suspected or undetected. There is no yes or no there. Therefore, it is just suspected or undetected. Okay, this is the kind of picture that we want to draw when we see there is a publication bias. So what it is trying to tell you is, you can see that on the top that you all have here, these are larger studies where the sample size is more and the weightage of these studies are more. And you can see there are smaller studies at the bottom, which means that these studies are very, very less sample size and the weightage for these studies are, low. So when you try to estimate the treatment effect, where you say 1 unit increase, 2 unit decrease, 1 unit decrease, you can see both the sides, the studies are there. But you see more studies here. And then you're also able to find studies with less sample size, which shows a negative result. But you see a gap in between the positive, negative studies on the top and the bottom. You're getting that? So the graph is like this. This is a positive result. Positive result favors hemoglobin is good. Okay, you can see that larger studies, these are less sample size. All the studies you're able to identify by your search. Did you get this site? Okay, you performed a search and you got all these studies which are showing positive result. Fantastic, great. But this side is a negative result. Okay, so you are just performed a search and you get studies which has a larger sample size telling you there is a negative result. You also find studies with a lesser sample size telling you there is a negative result. But in between you see a big gap. That is trying to tell you that there are possibly some studies that we are not able to identify, because we also find a small studies that are published, even smaller than that. So therefore, there is a possibility of publication bias. Okay, this can only be performed when you have adequate amount of data in a meta-analysis like this to make sense. Most often you will not have these many datas and you will not see that kind of a gap. Therefore, you trust your search strategy and then correlate with that to see whether what is the possibility of publication bias in your review. Yes. No, don't even suggest to do a publication bias funnel plot. So don't run a funnel plot unless you have a minimum of 10 studies. Only then you can make sense. Not only this approach, there are multiple approaches. Trim and fill, Eggers and Beggars. There are a lot of tests are available. But that is not really important because it's a statistical calculations. Yes. Nothing, this is not a diamond. We are talking about the studies, individual studies. The diamond is probably this line that you see as a treatment effect, which is in the middle, at the average. That kinds of classifies the positive or negative. Yeah. Correct. That's right. So you can notice here the SD 0 starts and then all the way increases. All right, then we have to do one more analysis. So now that we have just done with continuous data, so we all know how to generate plot now, and we also learned about what is fixed effect and random effect, what is trying to do. Okay, and we also learned about the heterogeneity. The heterogeneity is a important factor to look when you are reading any meta-analysis. The more the heterogeneity, the more the danger there. We cannot trust it. The lesser the heterogeneity, the studies are agreeing, then we can trust the diamond. So diamond is your hold estimate. Now we will look up for another outcome. Let's do a stillbirth. So go back to Rahman. Click on data analysis and iron supplementation and placebo. Now add outcome. This time, stillbirth is yes or no, right? Whether baby is born alive or dead. Stillbirth, yes or no. The dichotomous. Next, stillbirth. Can you type that? Yeah, this time it is dichotomous. Stillbirth because it's yes or no. And then finish. The same step, add study. Now, this time you should add the data in a dichotomous fashion. 100 people, iron supplementation, 10 stillbirth, 20 stillbirth, 50, 50, 6 and you should always go and change your labels. You can choose anything that you want, risk ratio, odds ratio, just by click of a button. Done? Okay, now tell me what is happening in the data. What is the first study tells you? Don't look at all the risk ratio and all of that. Just look up for the data. There are 100 people randomized to receive iron supplementation. 10 stillbirths, which is still a bad result. Okay. What happened to 20? So compared to placebo, iron supplementation actually less. So means iron supplementation is actually helping people. Okay. Next study. 6 stillbirth versus 10. Okay. So still iron supplementation seems to be helping. Both the studies are saying iron supplementation actually lesser number of stillbirth compared to placebo. Now we are trying to calculate this with a single metric, which is a risk ratio. What is saying is it reduces the risk of stillbirth by 50%. Why 50%? You can see from 20 it is reduced to 10 off 50%. Whereas in the second study, it is 60%. Okay, it reduces from 10 individuals to 6. There are 40% reduction can happen. Okay, that is why you get 60%. Now when you combine these two data together, what are you trying to conclude? Iron supplementation actually reduces the stillbirth by 47%, which is 100 minus 53 is 47%. Now, is it a correct result? What is your I square? 0, which means that both the studies are giving the same result. Both of them are agreeing that there is a benefit with the iron supplementation. So therefore, there's no problem. You don't have to go and look for whether it is a random effect, fixed effect. All these is not required. Okay. Now, if I just change this data slightly, what does your result suggest? Still it is 0%. It is not making a difference. Okay. Now I will go and change a little bit more. What are you trying now? It is the second study is saying iron supplementation is not really working. There is a higher stillbirth compared to placebo. When I try to combine this together, how much is heterogeneity? 65%. Now is it a true result? Maybe you cannot know right now. We have to go and investigate this. Now you can see that why it is not working in the second study. The second study, the healthcare system is very poor. They don't have facilities. Probably we are not able to demonstrate a benefit in the stillbirth. Whereas in the hemoglobin level, we could have seen a reduction or increase in hemoglobin. But stillbirth is a different outcome. So that is why you should go and investigate this. Even if it is 65%, we should still go and check why it is happening. What is the reason? Okay, now you cannot go with the fixed effect model. Now I should incorporate this and tell this as a random effect model. The I square is 65%. Still, there is a good amount of heterogeneity is present. Therefore, I want to incorporate using a random effect model and try to explain why this is happening. Is that clear? Can you do one exercise now before we break for lunch? Quickly, one exercise. Mortality, study 1. $24 out of 250. Okay, can you do this? Okay, those who are here, you can just go to the great platform and trying to create a user account. So this is the last step of doing a systematic review. So just go to this platform and then create a user account. All right, everybody has got their user account created. Great. Okay, what's going to happen now is, so you got your risk of bias done, which talks about the quality of your studies, right? And we got the statistical analysis, which is meta-analysis. Now, you can see that the method is actually helping us to determine whether the results are valid or not. So how do we combine these two information and make a summary out of it? Because if you say only statistical data, fantastic result. If you look at the actual process, it's all completely fraud, fabricated data. So you cannot really trust that findings. Therefore, you want to combine these two information and then try to summarize this information in a format that everybody can accept it. So this great framework, which is basically developed from McMaster Group in Canada, and they uses this BHC Bradford Hill criteria for causality assessment. So this has been adapted and derived from that particular method, trying to give us a idea of summarizing the information together. Okay, so let me see if I can. There are two aspects to this grade format. The first one is, as a systematic review author, you could summarize your findings. The second approach for this tool is, as a guidelines member, how to use the grade method. There are two direction of the same tool, but two different perspective. Okay. So what you might try to do as a systematic reviewer, you will try to just evaluate the studies based on this factors. So quality of evidence, you can see that there are 4 levels of evidence that you can grade: high, moderate, low, very low. Okay, these are the 4 final decisions for this outcome. Okay, you remember that example that we have done, iron supplementation versus placebo. What are the 2 outcomes? Hemoglobin level and stillbirth. So now the question is, for hemoglobin level, what will be your confidence on this result? So there are 4 levels result that we can provide. Very high or high grade means we are very confident that the true effect lies close to the estimate of effect, which they are telling us you don't have to further do any studies. We are very certain about the benefit. Moderate means we are moderately confident in the effect estimate. The true effect is likely to be close to the estimate of effect, but there is a possibility that it is substantially different. Low means our confidence in the effect estimate is limited, and very low means we have very little confidence in the effect estimate, and the true effect is likely to be different from the estimate of effect. So you can see that they reflect that how much belief that you have on the hemoglobin level result. What was our hemoglobin result? Average improvement 4 unit. The pooled estimate says there is going to be a 4 unit increase in your hemoglobin level if you are going to use iron supplementation compared to placebo. Now to arrive at this final conclusion of high, moderate, low or very low, we have to use this different factors that are going to help us in determining this findings. Okay, what are they? The first factor is study limitations. So you can see that study limitation talks about the risk of bias. Remember that there are 5 biases that we talked about, right? If all the domains are going to be red, then it is not a good quality study. The data coming from that study is not going to be helping us to arrive at high quality evidence. That is the first factor. The second factor that you can see, inconsistency of results. What is the inconsistency? How do you measure heterogeneity? I-square. So if the I-square value is more, then the confidence that we have will be low. It will not give you a correct result. Number 2. The third one is indirectness of evidence. Indirectness tells you that the data that we have obtained, the participant that they are contributed, is not a true reflection of my subject or what we have in our country or what we see across. The dosage that they use in the studies are completely different. First study uses dosage of 20 milligram. Second study uses 50 milligram. So how do I determine which milligram of dosage that I should just use it? Therefore, there's a indirect evidence. Okay. Precision, imprecision talks about whether the confidence interval that we have is allowing us to make a clinical decision, not statistical decision. That is a imprecision. And finally, publication bias. Publication bias talks about, did you miss any small studies? So those are 5 domains in which you evaluate the quality of your confidence that you have on the estimate. So this kinds of summarizes the result at the end and then formulate a table. So we're going to use this software to generate that particular table. That is going to be our task. Okay, for that, we must create an account. I hope you all have created an account in this tool. Okay, if you log in, so I have Cochrane account, I'm just logging in through, but you can just create your own account and then log in. Yeah. Which chart? There, I think. Okay, is everybody able to reach this place? So if you log in and create an account, you will be able to see this sort of window. Can you all just reach there after you logged in? Done? So now the first task is create a new project. I'm just giving some name. You can give any name that you want. So the software allows us to extract the information from Review Manager. If you use the RevMan tool that I've shared, you can import the data directly from there. So if you use an online tool, then you should allow some access and all of that. But this is straightforward. You can see here import question. You can just select that, and then the analysis that you have done, you have saved it somewhere, right? Go to that place and then import this file. So I'm going to go import and select this file and then import the question. Can you do that? No, I saved it in the RevMan file. The same RevMan file that we have used for analysis. You can save any location of maybe download desktop folder. Anywhere. What you should do, import, go to the place, and then select the location where you have saved it. Either in downloads or desktop. You will find something like this 5. So select that file and then import it. Revman file. Did you all save the Revman file? No? Save that Revman file somewhere in the desktop or some folder, and then import the entire file in the Grade Pro. That is not required. That's for publication. So you should be able to see the import file. After you finish importing, you will get something like this. When you click on this, you should just get some view like this. If you need help, just raise your hand. I can come over and help if anybody needs help. Okay, what you can see here when you import this, it is going to import all the data that you have used for your analysis. Okay. So you can notice here, the first outcome is hemoglobin level, and the second outcome is stillbirth. Probably if you have created multiple outcomes, you will have all the information there. You can delete them here. You can go here, you can say delete the unwanted data that you can delete it over here. Okay. So I have these two outcomes in my view. Now I have to tell the computer that I'm going to evaluate this for creating summary of findings. So it is asking me all these different questions. So I'm going to make a decision over here. The first thing is asking is, what is the type of study contributed data to this outcome? These are randomized control trial. Okay, when you say randomized control trial, the software keeps the decision and its assumption to be high certainty. Okay, there are 4 levels, right? High, moderate, low, very low. So it assumes that RCTs are very good quality study. Therefore, the results are going to be very, very high certain evidence. Okay, now, first thing, I will go mark everything as not serious. All these domains, mark this as not serious. You will see that the certainty that we have in this result is high. Can you try that? Just mark everything is not serious, undetected. You will get high certainty evidence. Can you make your decision? Okay, everybody got high? So if you don't find any problem on any of this domain, the software keeps an assumption that RCTs are high quality evidence. Okay, but we have to make a decision on each of the domain. So now the first domain is risk of bias. Now, how many studies have contributed data? 2 studies contributed data. Now I have to go look at this outcome that we have created. These are 2 studies. Now tell me whether there is a bias in these 2 studies. So you can see the risk of bias graph, right? So this is for example. Do you think there is a bias? Some of them are red. So there is a possibility of bias present in the study. Now the question is, do you want to take it? How serious is this bias? Whether it is a 1 level downgrade or 2 level that you want to downgrade it. So I'll just add this first study bias for your clarification. Rani. Okay, now tell me. The first study is super, no problem at all. Second study has a bias. So you wanted to downgrade this? Yes, there is a problem in one study. The question is how much you want to downgrade. There are 2 levels that you can go. One being serious, another being very serious. What level that you want to downgrade? 1 level. That it's your wish. Your team has to agree on what level that you are downgrading. There's no rule. Okay, now you want to say downgrade by 1 level, which is serious. When you say serious, you should also give an explanation of why you are saying it serious. And you will go and say, One study with high risk of bias, therefore we are downgrading it for serious level. So any decision that you do, you just explain the reason why you are doing it as a group. Okay, so I will save this. Now you can see that the evidence is come down from high to moderate. Why? Because we found some problem in the bias in the study. The second domain, inconsistency. Is there inconsistency here? Yeah, what is the value? 90%. There is an inconsistency. Do you want to downgrade it? Yes. By how much level? By 2 level. Why? It's not objective decision. Because it is high, you cannot downgrade it. So you should look at the direction of effect. You can see the direction of effect is in the same side. Both of them are agreeing that iron supplementation is working. You don't have to be too much harsh there. Maybe you can say it is okay to have 1 level downgrade. If it is on the other side, it's okay to be very serious. Okay, now I will go back here and then downgrade this by at least 1 level. I still feel there's a problem, but not downgraded by 2 level. Okay, again explain the reason. Indirectness. Now the question is, you have to go and look at the characteristics of these two studies. What is data present in both the studies? Whether it is iron supplementation is same, what is the form, what is the dosage, what is the duration. In all of that you have to know. And if one study uses only 2 months, another study uses 6 months, is there a directness? There seems to be problem, right? One is just giving 2 months and showing a result, another one is giving 6 months and showing a result. It is not a generalizable result. Therefore, there is an indirect evidence. I want to downgrade this by at least 1 level. Now you can notice here, I downloaded 1 more level, then it goes to low. Did you notice that? Now if I downgrade this again 1 level, that's all. It goes to a very low quality evidence. And then we talk about imprecision. Imprecision, now go back and look at this data. And we are asking a question, is this result is clinically significant or not? Okay, what is clinical significance? The clinical significance tells you that what you are expecting, whether the result is able to show you that or not. So as a clinician, if you are going to give an intervention, if the intervention is going to improvise their hemoglobin level by 0.2, is it a great intervention? How much you think that the hemoglobin level should be increased? One unit, 200 ml is not good. At least minimum of 2. So 2 unit increase seems to be a great intervention. It's pregnancy, during pregnancy. So 2 ml is good, 2 unit is good. So now you look at the data, I wanted to see a result, minimum of 2 unit increase in the hemoglobin level. What does the diamond tells you? The diamond tells you that there is a 3.94 unit. Minimum is how much? 3.35. Minimum is 3.35. Is that result is above 2? Yes. Then this result is clinically meaningful result. Therefore, it is a precise result giving you that I have no doubt about the benefit of this drug because the intervention is increasing the hemoglobin level by at least 3 unit. I am expecting only 2 unit. Therefore, I don't want to downgrade this. So not serious. And publication bias, of course, usually undetected and apply. and your results becomes very low because of one second, because of that you are able to downgrade these three domains, and this outcome becomes a critical outcome, giving you a very low certainty evidence. Okay, yeah, questions please. No, it's not about how wide is how close or how narrow is not the question. The question is about whether you see a benefit giving you a confidence that it is working. Now you set a limit of 2 decision point where it is definitely working. So now the result is above 2, therefore we don't have any problem. Suppose if the result is 1.5, then you will downgrade that for your imprecision. It's not about the size width of the confidence interval. It's fine. Benefit is benefit. Minimum is more. It can be 500 also. It does not matter. Okay? That is your clinical decision again. How you make your decision, whether it's critical or important. Very low is the decision for this outcome. But how important is the outcome? It is a very critical outcome to determine the benefit of this drug. Yeah. So that you a priori decide, not do it at this stage. When you create your table, you decide this a priori, and this is not relevant for your systematic review, the importance criteria, only for the guidelines. It will be removed when you export it, actually. It won't come in the systematic review. They will use this. They will use this before they look at the data. So they will give all the protocol and evaluate which outcome is critical for them in decision making. Then they will come and mark. Expert panel, the guidelines panel members will be a part of all the decision making. So what I will do, I am a systematic reviewer. I will go without all of this. I will just go and present my review and data. Now the team will be sitting. They will review the decision and then say that, no, I don't agree, it is serious. They will change the decision from serious to low. And then they will say critical outcome. This is a critical outcome. Then they will just make all the changes. Okay, that we are not going to go towards that policy making. So now here we are just focusing on the summary of findings table. Now first outcome is over. Now second outcome, stillbirth. What is the design? Randomized control trial, apply. So now if you look at these two studies, this two studies is not the same two studies that contributed data before. So these are different set of studies which contributed data. You can see this is different. First is Rani and Suresh. This one is Richard and Suresh is contributing data. Therefore, I have to look at this risk of bias, not the previous one. Okay? So don't say, oh, this is the same, let's mark everything same. No. For each outcome, the risk of bias is going to be changed. Now, tell me whether you want to downgrade this. Yes? How much? 1 level. Okay. Next, inconsistency is there. Yes, inconsistency is present 65%. But I have used a random effect model and telling you incorporating both the results. You can still say that 65 is okay and I will not downgrade it. Okay, there is no specific objective criteria here. It is all a subjective decision, but you provided a given explanation. Okay. So it is 50 or 49. Will you still consider? So again, it's a criteria that you have to clinically or as a group you have to decide. How serious is this 65%? So this 65%, though the results are going in different direction, but you can see that the point, the confidence interval in the second study starts from 0.57, includes 0.25. So the confidence intervals are overlapping between each other. Therefore, I don't want to make it very serious. Maybe I can say it is not a major problem. You can disagree or agree, but you just write an explanation why you are saying that. Okay? Indirectness, again looking at the duration, dosage, and what is the impact. Yes, not serious. No, even then it is just how you explain it, right? There is no 90%, it doesn't mean it is high. So it's just basically how you wanted to explain that to your readers. And imprecision, here, it is serious. You can see that it is just rendering benefit as well as it says harmful. So therefore, it is serious, not giving a clear picture. Publication bias undetected. Apply. So you get a low certainty evidence here. Okay, can you just create this like this, and then I will tell you how you can export this. Just make your decision. Okay, everybody made some decision on that. So now once you make a decision, and then what you should do is you have to click on this grid icon. The icon here at the end, next to importance, change this to summary of findings table. Change this format to summary of findings table. Now here you can see what happens in this view. Were you able to see that? When you click on that, it actually going to give you an idea of how you write your summary. The evidence is very certain, and you apply that. Okay? Just watch my screen. So you can write some sort of a template conclusion for each of these outcomes. Did you get that? So select this. I'm selecting it is a no effect. and then I'm just selecting the options available. So just ensure I repeat again. There is a grid icon over here. Click on this and then change to summary of findings table. Only then you can see this option. Everybody able to change that to summary of findings? So once you change that to summary of findings, you can see that there is a arrow mark which allows you to export it. Just export this in an MS Word document, because if you publish it, export button here, just watch my screen, there's an export. Select all and then MS Word document, and then you should have your table ready. Yes. You will get a table like this, which you can find in all the reviews. Can you just confirm whether you can see a table like this? Okay, now you have got all the different graph, forest plot, summary of findings, Prisma flow diagram, search strategy, all of this with you now. So you just have to write your manuscript to complete it. Okay. So the review is ready with all the available information. So you just have to, go and write your manuscript and submit. Everybody able to get this plot? Table finally? Okay, now that you have know all of this, you have been sent with one particular review. Everybody has that review, right? The PDF document review. No? You got a document. Can you open that up now? The WhatsApp group, whatever group, just open that Cochrane review. This is a review which has been shared, right? Now, so whenever you read any Cochrane review, so what you might notice is you will find the summary of findings which just gives you a direct answer to your question. Okay. So this is an important, table which summarizes the entire finding. So you can see that the population, setting, intervention, comparison. And then the results are described the same way that we are seeing here. What is the quality of evidence for this first outcome? Visual improvement at the end of treatment. What is the relative risk? It's 2 times better than the placebo. But the confidence that they have is very low. Why did they have very low confidence? You have to see a footnote. Downgraded for risk of bias, imprecision and heterogeneity. Therefore, this becomes a very low certainty evidence. And all of this outcome that you see are very low. Okay. Now, look at the results. What is the conclusion? They are very uncertain about the effect because of very low certainty evidence. Did you now able to correlate how the conclusion is driven by this summary of findings? It is not directly telling you that the data is beneficial, because data shows there's a fantastic result. But you cannot just believe the data directly, because it actually comes how the methodology is and you combine it together to make a conclusion. Okay, here how many studies contributed data? It is a single study actually contributed data, that too only 22 participants. But still there is able to publish a Cochrane review. You are thinking that, oh, one study, how can I do, and all of that. The question is important means when one study will also, even there are reviews, there's no studies will get published. Okay. So it's a single study, very less sample size, randomized control trial. You can see that all of this evidence are uncertain because The sample size is not adequate. But if you don't document this in a proper way, you will never know. You will see that as a randomized control trial. You will never see that as a synthesized evidence. Okay, what is the amount of bias involved in this study? Can you tell me? Go to figures. This is a flow diagram. This is a risk of bias. You can see that the included study has got these many different studies. But for the analysis, only one study contributed data. Okay, you can see that there is lot of orange, yellow. So you can see those figures here. You can see the forest plots, all single study. Okay, can you go through and tell me what did you observe, whether you will be able to confidently create it? Okay, we got another 15 minutes with us. Just can you recreate one forest plot from this example? From this review, can you recreate one forest plot? You can choose anything that you want. Just see whether you are able to create one forest plot, at least one. If you want to just see them directly, you can go and click this download data. If you want to see it in Revman, download this data. I agree, and then download this data. You can open this in Revman. Can you try that and then see how they have done it? Were you able to download that? Go to Cochrane library, search for it and download. Sorry, thanks for reminding. Okay, I think Sir was interested in network meta-analysis. So if you are interested in, there's something called NMA Studio. Okay, this is for network meta-analysis, where you can try and perform some network meta-analysis, but requires a little bit of learning. But all the resources are available within this platform. So you just have to go there and explore the resources here. It just keep on updating. People are keep on updating on this, developing this tool. It becomes user friendly over time. You can see a couple of examples available already in this platform. You can check out how you wanted to just run this. So this example is for antidepressant. And you can see placebo compared to all different available antidepressant, and then trying to see what was the treatment effect. So how do we interpret this? Let me, okay, I think these are, they changed the interface now. Yeah, this was updated actually. This was the site was exist before, but now they have updated this to version 2. Oh, I'm not a user of this right now. Maybe you can just, I think there should be some registration or something is might need it. If it is open, you can access it. I think it should be open. Yeah, it's not registration. You can just use it. Okay, I'll stop here. And any questions, happy to take, or we can wrap up.
One suggestion, sir. If you
Yeah.
can just summarize, because for each one you have different tools, no? Like ROB1, ROB2, then some Cochrane. So like that, if you have to start, can you just tell us one which we can use to begin with?
Okay.
The flow.
So it's a recap of what we done. You just have
In
to
a
follow the
nutshell.
schedule. Yeah.
Yeah, in a nutshell.
So just process the schedule that we have actually taken. So what did we learn in the first section? The first class we talked about the PICO. The PICO is where you begin. Okay. PICO is where you start your research question. And then secondly, I introduce perplexity to check whether there is a existing information available. And next, Prospero to check. And also check in epistemonicos to see whether any reviews exist. That will allow you whether you want to go on pursuing your topic or restructuring your question, PICO. Now you finalize your question, then we begin by keeping an inclusion-exclusion criteria, which is a study design, which is very important. And intervention, RCT, is very important. Okay, next, identify the databases. Various database that you are aware of, you can go and search and develop your search strategy. Okay. So once you have done with finding studies, what did we do? Screening. Ryan is a tool you use for screening. It is all there in the document protocol that I'm asking you to write. Okay. It's a Ryan tool that we use for screening. After screening, what did we do? We got the full text. We got the full text, and then what we are supposed to do with the full text? Extract 3 different types of information. One is the characteristics of studies. Second is the risk of bias. And the third one is the numerical data. These are 3 information that we are trying to collect from each study. Okay. For risk of bias, Cochrane risk of bias tool is used for RCT, version 1, version 2. For developing graphs, you can use RevMan. And ROB2, RobWis is a tool for developing graph. Okay. And then for meta-analysis, Prisma, all the things you can use RevMan. Prisma flow diagram, forest plot, funnel plot, all of this can be done in RevMan. And then finally, we want to combine this risk of bias and the meta-analysis using grade tool for creating summary of findings. So this will allow you to create 4 different figures: Prisma flow diagram, risk of bias, meta-analysis forest plot, and then funnel plot. And then finally a table which talks about the summary of findings. So these are 5 components goes into your manuscript for your publication. Clear? And NMA is, of course, if you are a little advanced and you want to do something more, you can just go and take a look at this NMA Studio. All right. Thank you all. Thanks for participating in this session. I think I hope you have learned about systematic reviews and meta-analysis. Your question is about incorporating all the available interventions. That is the scenario network. Yeah.
Thank you so much, Mr. Richard. I think it was a very, very enlightening session. We were practically like in the dark, you know, and we had our own imagination of how difficult and this thing, systematic review and meta-analysis would be. At least now we have a ray of hope for some of us who thought it was not possible at all. And most importantly, you generated a lot of interest in it. We hope to be successful, but at least we'll definitely start the journey. I think that much all of us can assure you. And just for the information of others, that this workshop was actually, it's a gift of ophthalmology to everybody, I should say, because on National Science Day last year, we got the 2nd place, and I think 1.5 lakh rupees was given. So then with the help of Saujanya and even Dr. Uma, they sort of helped us coordinate this workshop. We thought that we should use that to advance research for our knowledge of research further. So that's how it conceptualized, and yeah, the work is going on, as he said, since probably 6-7 months. And we are happy that people who are very interested from so many different, not only colleges, but different streams. You know, we have physiotherapy, we have ethics, we have an endocrine surgeon also. So, you know, we have varied people who've been very interested throughout and actively participating, asking doubts. So thank you, all the audience also, for wonderful participation. And if anyone wants to just share whatever their feedback about the workshop, you're welcome to do it. I think you should tell him how nice it was. It was definitely not boring. Today, it was like we didn't feel like going for lunch or tea break. Anyone? Yeah? 2-3 people can do it.
Extremely useful program. Yes. When I came here, I have done a couple of meta-analysis, but I didn't expect this sort of help and maybe improvised tools that I learned from you. Very, very practical. More than using just RevMen, you taught us so many AI tools. I think hopefully we'll do it faster and we'll do it better with the help that you have given. And hopefully we can seek out for more help whenever required, as and when we're doing studies also. Thank you so much. Sir wanted to talk.
Many times we attend workshops or some conferences for certificates, but here for the first time, we all have been actively involved in this and trying to learn from the depth. Maybe because we were all our minds were empty with regard to this particular thing, because we have read the meta-analysis and systematic reviews a lot when we are studying or when we are reading some guidelines and all. But how they have come to that approach, that we usually scratch our head. And sometimes we have read all these plots, graphs and all. But that particular tools, when we want to read and learn ourselves, it is really difficult. So here we have got a comprehensive knowledge about that particular thing. And maybe back end we will start going home and doing our own research, because nowadays a lot of things are on the web. So we do have because I myself have downloaded a lot of documents on network meta-analysis and I've been reading about that. But for last 1.5 years, I have not understood much about it. So I think now again, I will restart my journey on that and I'll try to do something. Thanks.
Maybe looking at the interest, I'm really motivated to have this session maybe every year, maybe for a longer duration, maybe 5 days together, like a protocol development and then analysis. Maybe we'll see, I guess, maybe.
The way that we do is, beginning of the year will be a protocol workshop. Like 5 days, sit, write your protocol, get your clarification done, and the protocol is ready. And then after 6 or 8 months, you have a review completion, where you come with all your full text article, sit and complete your review. So otherwise, this is kind of giving you an idea of what all happens, what all present there, and give you some, because it's more of a hands-on. We wanted to just keep everything practical there, giving some PowerPoint, it's going very boring. So therefore, this is slightly different from what we generally do. So if you have plans, start some working group, 1 or 2 topics, and they are consistent meetups, monthly ones or something, then slowly you can see a transition of many people, because this is easy to do. You don't lose, collect patient information, ensure that it is correct, and do all of this. Sit in one place and then collect all the articles and read it. And the impact of systematic review is very, very high. So publishing one randomized control trial and waiting to see an H index or I index. Even if you do one systematic review over 2 years, you'll be able to completely go on a different shift. That is the volume of impact on systematic.
You will announce.
So how long will you take for your
It depends on what type of review that you write. Again, you have to find some strategy of choosing your questions. And if you choose to ask, oh, I want to do antibiotics, there are a lot of studies going to be there. Or you can choose a very specific topic. Generally, systematic reviews are done in very specific topics. So therefore, it's easy for you to just focus and complete.
What is your suggestion for a beginner like us? How to make it
Basically, if you go towards some Ayurvedic drug or something which is not being studied, where Department of Ayush encourage people a lot of money there in Ayush. You apply grant there, if you have money to little relaxing.
The thing is, with Ayush, you don't have art.
That's fine, that is the limitation. But there are funding which is put there that is unused.
funding becomes for actually research.
This is also a research. If you want to publish a CFJ, systematic review conference as the original article. And if you do 5 PhD, 5 systematic review on a topic, you can apply for a PhD in Western University. In European University. Okay, there are people try only systematic review to get their PhD.
My question. So you should have a minimum 5 published for you to apply.
On that, yes, basically, and get your PhD done on writing videos on the same topic.
All the 5 reviews have to be
Same area. So we worked on a review on retail credit for ADHD. The PI of that project has got multiple students involved in it. And they are also doing their research component of it, and he gets his PhD by submitting all of his research. That happens only in European universities, not here. In India, it doesn't even qualify for promotions. Now, at least they consider it.
No, but you are eligible. If you publish 5 reviews, you are eligible for that.
Yeah, yeah.
European.
Europeans, you are eligible. In Indian context, systematic review itself is not considered for promotion. Now it is. The things are evolving very slow, but it will have its own pace of growing. It will grow.
Thank you once again, Dr. Richard. And on behalf of Department of Ophthalmology and Yenepoya University, we would like to hand over a certificate of appreciation to Dr. Richard and his wife, Dr. Rekha.
Yeah, you do it.
That he sent. Please fill in your feedback forms. That's really required. Thank you.